This is not an official notice. I'm just letting you know we're going to start around 9:55. So we just got a few more minutes. Make sure everybody has a chance to tune in for the live stream and everything. So good morning.
Good morning.
Good morning. Y'all are great. I haven't even done anything yet. This is awesome. Welcome to Monitorama. Welcome to Portland. The weather's pretty awesome, right? So the forecast was, what, like 90, 94, 92? Has anyone looked up the forecast now? 89. Tomorrow is 83 and Wednesday is like 66.
Welcome to Portland.
Thank you very much for coming out. I'm excited to see everybody at Packed House as usual. This is really cool. Let's see, quick raise of hands. Who all went out for the Sunday Fun Day event yesterday? Nice. It wasn't a lot. We had about, 35, 40 people, but it was a lot of fun. Previous years, we've done a soccer event at Fields Park on the north end. I thought this would be kind of an interesting change of pace, and that it allowed more people who look like me to kind of partake in the activities. And it was a lot of fun. We got free ice cream. Most people got free ice cream. So that was pretty cool. So I think Will's already mentioned everybody's kind of squeezing in, and I appreciate that very much. We've tried to accommodate some of the extra, just capacity by adding some space on the third floor. If you're feeling a little squeezed and you want somewhere to spread out or some casual seating, we have the rehearsal hall on the third floor, which is basically if you take the elevator to the third floor, you head straight back towards the bar and then go kind of to the right around the back. There should be signage up there pretty soon if there's not already. We've got some 10-foot rounds and some nice armchairs and things like that. And we have a live stream up there. I think we have a 6-foot screen with a live stream, so you're not going to miss out on anything. Bandwidth, hopefully we've upgraded this year. Well, technically we've upgraded. I paid for more. I think we burst up to 300 megs. So we're doing 150 megs, bursting to 300 megs, and before I came out here, they said within 10 minutes we'd already hit 120 megs. So again, it's not a surprise. I understand the crowd. It's fine. We might double that. We'll see. Be gentle. I encourage you. This isn't a this isn't a demand. It's an encouragement. Try to enjoy the event. I understand we're all working professionals here. If you need to have your laptop open, that's understandable. If you want to take notes, that's fine. If you need to work, it's probably better. If you want to step out, go up to the rehearsal hall. It's going to give you a better, more quiet experience. Hopefully you'll enjoy yourself more. So we had some refreshments out there this morning, snacks. We had some in-house coffee. If you've been here before, you know that we like to bring in a local barista, Nosa Familia. They do pour-overs. This year they're also adding some cold brew, I think like a tap cart thing. I haven't seen it yet, but it sounds really cool. And we'll have a station on both floors. And thank you to, are we doing the loop? Are we looking at this the whole time or is it looped around? Okay, awesome. So quick shout out, I'm not going to list all of them because like usually we have a lot of sponsors, but I want to thank all of our sponsors again. Quick round of applause for all of our sponsors. Thank you very much. Seriously, thank you all, both the sponsors, attendees, speakers, everybody for making this possible. I hear every year that this is a lot of people's favorite event. I'm biased, but it's kind of my favorite event. Anyways, I just hope everybody has a great time. I don't want to hold this off any longer. I will mention we have an after party this afternoon. We'll touch on it later. It's at the same place we've done it last year. It's Pips and Bounce. It's a ping pong bar thing. It's a lot of fun. You want to come out and play. We have a bracket. I think I pinned that in the general room or maybe the after party room, something like that. I pinned it on there. If you have questions, you want to get on the bracket, let me know. If you want to come out and just play casually, have a drink, chillax, whatever, that's awesome too. Okay, enough of that. Just a little background on this, our first speaker of the event. This is a guy that I found out about a few years ago. I've seen him do keynotes for Velocity and Strata and probably some other data events. And if you've been to a Monitorama, you know sometimes we kind of stretch our boundaries a little bit. We go beyond just strict monitoring or operational or engineering things. In particular, I have a particular love for affinity for statistics. If anybody in the room knows Kyle Kingsbury, I'm getting way off topic, but everybody knows AFER, Kyle Kingsbury. One of my favorite people, what he does particularly well, I mean, above many other things he does particularly well, is he has this ability of taking really advanced topics, especially in engineering, and distilling them down to things that, concepts that simple people like me can understand. Our next speaker is very similar in that regard, but with statistics. And that said, he might not even talk about that. I frankly, I don't know. I just know he's an amazing speaker. God, I'm rambling. John Rouser, amazing speaker. I know you're all going to love him. He's actually joins us from Snapchat. Yeah, I think that's all I have to say. But again, thank you all very much, and I hope you have a fantastic time.
Hi, everybody. Thanks, Jason. That was awesome. You're too kind to me. Let's see if I can make this thing go. Success? No? Maybe? Ooh, things are happening. All right, here we go. Okay. So I'm John Rouser, and I'm here from the future. Okay, so I'm not literally here from the future in the science fiction sense. Rather, I'm here from the future in this sense. So I really like this idea. The future is already here. It's just not evenly distributed. So this is an invitation to the first meeting of the Homebrew Computer Club. Gordon French invited people to hang out in his garage in March of 1975 with the goal of making computers more accessible to everyone. In 1975, digital computers had been around for a long time, but what was relatively new was personal computers. This is one of the first personal computers, the Altair 8800. The way you booted an Altair 8800 is you toggled those switches on the front to encode the 16-bit address of a bootloader, and then you toggled the execute switch to get the thing running. This is comically primitive by our modern standards, but the people building their own computers from mail-order kits in 1975 were at the leading edge of the personal computer revolution. They were glimpsing the future that you and I live in today. In fact, Steve Wozniak was at the very first meeting of the Homebrew Computer Club, and he credits that meeting with inspiring him to design the Apple I. And so in a very real sense, there is a direct line between the Homebrew Computer Club and this device, which hundreds of millions of people carry around in their pockets every day. So that's what William Gibson means when he says that the future is already here. Those enthusiasts in 1975 were living in a microcosm of ubiquitous personal computing. Okay, when I say that I'm from the future, who the heck am I? Well, first, I'm a member of your tribe. I spent the first half of my career as a software engineer, including 8 years at Amazon. While I was at Amazon, I spent a long time working on website performance. That work culminated in running Amazon's worldwide website performance program. While I was running that program, the very first thing I did every morning and the very last thing I did every night was look at a set of about 80 graphs, which told me if the site was performing acceptably. If I saw something wrong, I figured out a likely cause and paged people to get it fixed. So I am of your tribe, the people who care about monitoring and metrics and observability. To the extent that I was any good at managing web perf, it was because I loved data. And that's what led me eventually to become what people today call a data scientist. But really, I was a data scientist back then when I was looking at my web performance charts every day and night. I was just looking at data and trying to make sense of it. And you too are data scientists, all of you, though perhaps you don't know it yet. And what I've learned, having made the leap to full-blown data scientist from web perf nerd, is that the data science tool chain is really pretty spectacular. And it's hard for me to say the same is true for the monitoring and alerting toolchain, at least the open source part of that toolchain. I use Graphite and Grafana in my current job, and while they are sufficient, they pale in comparison to what's available to me as a data scientist. And so what I want to do today is I want to talk through some of the aspects of the data science toolchain, how it's changed recently, and why I think it's so fantastically powerful. Specifically, I want to talk about R and the tidyverse. Probably a lot of you have at least heard of R before. If you haven't, R is a programming language designed for data analysis tasks. And R is also a larger statistical computing environment with an extremely diverse library of add-on packages. R has a reputation, somewhat well-deserved, for being a very difficult language to learn. And that's a big part of that difficulty is that while the core of the R language is very small and beautiful, the base R library has what I call PHP disease. There are just a million functions with absolutely no consistency. This is the opening of a book called the R Inferno, which is modeled after Dante's Inferno. So this book tries to explain all of the little gotchas in R. It is 126 pages long, and I have to say it was tremendously useful to me as I was learning R, but things have really changed. R isn't nearly so difficult as it used to be, and that's largely thanks to one person, this fellow, Hadley Wickham. Hadley's a professor of statistics at Rice University and chief scientist at RStudio, a company that makes a really nice IDE for R programming. Hadley is the driving force behind the tidyverse, which is a set of R packages that share a single, thoughtful philosophy and are designed to work together. In Hadley's words, the heart of the tidyverse is a set of consistent shared principles that every package in the tidyverse adheres to. So I'm only going to talk about two of these packages, but for people who care about monitoring and operational tasks, they're the most important ones. So the first is ggplot2, which is a package for plotting data. Even if you have never heard of ggplot2 before, you've almost certainly seen plots that were made with it. If the gray background with the white grid lines in this plot looks familiar, that's the signature of a graphic that's made with ggplot2's default settings. And then the other package I want to talk about is dplyr, which is a package for querying and manipulating data. So development on these packages started in 2005 when ggplot2 was released, but it's really accelerated in the past 3 years. And it's in those 3 years that I've really started to feel like I'm living in the future. And so here we come to my thesis. These tools have already had a tremendous impact on how a huge number of data scientists do their work, but it isn't going to stop there. I believe that the ideas in the tidyverse, not the tools themselves perhaps, but the fundamental ideas that they are built upon, those ideas are going to have profound impact on everything having to do with data manipulation and visualization, or data analysis more generally. And that obviously includes things like monitoring and metrics and analytics, the things that you folks all care about. Okay, so I want to talk about these ideas in the context of a real problem. So we're going to look at some sunspot data. Sunspots are a result of the fact that the sun is a giant ball of plasma, and that plasma is flowing around in super complex ways. People have been observing sunspots for hundreds of years, and so I downloaded a daily sunspot dataset, cleaned it up, made a first stab at a visualization, which looked pretty crappy. The series I downloaded had daily observations, and the lines I used to plot this data are really heavy, and so there's a lot of overplotting. You can't really see the data very well. This sort of problem is super common in dashboards with fine-grained telemetry data. There are lots of ways to address this problem. Here's one. All I've done here is to draw the data as points with no line adjoining them, and then I muted each individual point by making it mostly transparent. And now you can actually start to see the data. So for example, you can see that in the 1850s, the data never takes on values between 1 and 20. In more recent times, it never takes on values between 1 and 10. So it turns out that I'm plotting a metric called sunspot number, which today is defined as the total number of observed spots plus 10 times the number of groups of spots. But it looks like in the past it was different somehow. This is the kind of thing that a visualization makes obvious. Okay, so let's talk about tools. In particular, I want to talk about code versus clicking. So let's go look at some code. So remember this plot. Here's the code that made it. What ggplot2 offers is a domain-specific language hosted in R for making plots. And that language is based on something called the grammar of graphics. That's what the GG stands for in ggplot2, the grammar of graphics. So just to explain briefly what's happening, that ggplot function call is essentially setting up the frame of the plot. I'm saying I want to plot some data that's stored in a variable named sunspots, and then comes something called an aesthetic mapping. That's what that AES function call is. And what I'm saying here is that there's a variable named dt for date in my data set, and I want to put that on the x-axis, and then there's another variable named sunspot number, and I want to put that on the y-axis. Okay, so far so good. I haven't yet said how to draw the data. The way I do that is to add, using the plus operator, a layer where I'm drawing the data as a line. And this code results in this plot. And so something kind of remarkable just happened, and so I'm going to go over that again really briefly. To make this plot, all I needed to do is to specify two things. First, I needed to say what was the mapping between variables in my data and aesthetic features of the graphical elements of the plot. And now here I'm only mapping variables to x and y position, but I could map variables to things like color of points or the size of points or shape or alpha transparency or lots of other things. And second, after declaring that mapping, I need to say what kind of geometric objects should encode the data. Here I chose a line, but I could have chosen points or bars or a surprising number of other geographic elements. And this is the power of the grammar of graphics put into a domain-specific language. This little bit of code, easily small enough to fit in a tweet, this little bit of code completely specifies a plot. But once I saw it, I didn't like the line plot. I wanted to try something different. And so I changed the geometric object representing the data from a line to points. And then to mute the visual impact of each point, I added some parameters to make them small and mostly transparent. And so you can now see something only when there's lots of points that stack up. And so now I have this nice plot with less overplotting. And so far, you might not be very impressed. You might be saying, well, why is this any better than a tool like Grafana, right? Where if I want to change from showing the data with points instead of lines, all I need to do is click a checkbox. In fact, you might say it seems worse because I have to do all that typing and I have to remember the syntax, and that's really annoying. But what about when you have 5 or 50 plots and you want to make the same change to all of them or to all but one of them, right? Now you're in an endless hell of clicking so painful that you probably just won't do it. You'll just suffer with whatever you've got so far. But recall that ggplot2 is a domain-specific language hosted in R, and so I've got all of the features of a general-purpose programming language available to me. And that means I can give those constants names, and then use those names not just in this plot, but in lots of plots. And if I ever change my mind about those values, then I change them in one place and not in dozens. But it gets better. A plot like this is an object in the language, and so I can give that plot a name, like P, and then I can take a shot at guessing the structure of the cycle. If we eyeball this, it looks like maybe there's a cycle that lasts about 11 years, and there's a minimum in roughly 1954. So here's a really grody line of our code that computes an array of dates. You can see that 1954 and the 11 years lurking in there. And now because I'm working with composable objects in a programming language, I can add a layer of vertical lines to the plot and get this, where the blue lines are equally spaced every 11 years and they kind of sort of line up with the troughs. So the first thing that I want you to take away from the data science toolchain is that what ggplot2 offers is the ability to express visualizations completely in code, no clicking. But completeness isn't enough. Right? A library like D3 in JavaScript is complete, but the equivalent code for this line plot in D3 looks like this, right? So I had to shrink the font size down to 6 points to get it all to fit. And so not only is ggplot2 complete, it is also compact and expressive, which makes it extremely powerful. I've only shown you the simplest possible plots, but for almost any plot you can imagine, including plots that don't have names today, you can go from an idea to a realized image in a handful of code faster than in any other language I'm aware of. And because of this, ggplot2 has already transformed the workflows of many data scientists, and it's not going to stop there. I believe that the ideas in ggplot2 and in its successor, ggviz, are going to transform every tool that deals in statistical graphics, monitoring tools included. If you want to learn more about ggplot2, you can take a look at Hadley's book, R for Data Science, which is available online for free at that link right there, or you can buy a copy from the nice folks at O'Reilly. Okay, the next idea I want to talk about is another idea from R, the data frame. So the data frame is this fantastically useful idea that hasn't been copied nearly as widely as it deserves. At its core, a data frame is just a table-like structure. You can think of it like a spreadsheet in Excel or a table in a database. A data frame is a structure where there's one row per observation and a column for each variable. And you might wonder why this is such a great idea. After all, you might say, well, hey, my language has two-dimensional arrays, or my language has lists, and I can make lists of lists. The power of a data frame is really in the interface. The key idea in a data frame interface is that data alignment is intrinsic to the object. And that mainly means that a row of data will remain intact through any operation. And to see why that matters, maybe you've had this happen to you in Excel, where you go to sort your data, but oops, you've accidentally selected a single column instead of the entire table, and now you've wrecked the alignment of your data. Another nice feature of a data frame is that columns and optionally rows have names, which allows for very natural indexing and filtering, and it also makes it super easy to support joins. But the killer feature of a data frame is that they are a very flexible structure that can accommodate the needs of the vast majority of analytical problems. And what that means is that people writing libraries in R can assume that you'll pass in a data frame and that they can return results back in a data frame. And the power of that is it allows you, in Hadley's words, to solve complex problems by combining simple, uniform pieces. A data frame is the uniform medium of communication between tools in R. In this way, you can compare data frames to Legos, right? What Lego provides is this consistent interface, and perhaps surprisingly, that simple interface allows the expression of fantastically complex ideas. You see these ideas show up in monitoring tools, right? In Graphite, functions usually take and return a series or a series list, and that makes it easy to chain together a bunch of functions like this. I think that this one feature of Graphite, of its design, is a major reason for its popularity. And in a way, a series list is a bit like a data frame, but R goes one further. R supports something called a nested data frame. So you're used to tables containing atomic data types, like numbers or strings or Boolean values. But in R, a data frame can be a list, and an R list can contain any object you like, including another data frame. So to see how that works, it's probably easiest just to look at an example. So here's a data set from the Gapminder tool. It has demographic data for different countries over time. And what I can do with this in R is group that data by country and continent, and then ask it to nest the remaining columns. The demographic data. And so now what I get is one row for each country, and the last column contains tibbles, which are a special kind of a data frame. Each one is 12 rows long and 4 columns wide. And so what's happened is we've nested little data frames in each row of the larger data frame. And you can find something like this idea in some monitoring tools, like in Cakewolf from Circonus, where they have the notion of a histogram data point, which feels, I have no idea how it's implemented, but it feels to me like a data frame where one column is a timestamp and another is a histogram object. But if you go all out and allow the nesting of data frames inside data frames, then you take an already very flexible structure and you make it even more flexible and useful. And so I think that nested data frames is an idea that monitoring folks should just steal outright from the data science community. Okay, next I want to talk about calling functions. So I mentioned that since Graphite has this uniform structure of a series list, and because each function takes a series and returns a series, it allows the chaining together of functions like this. But chains of functions like this are hard to read because you have to read them inside out. You have to spend a lot of time carefully matching up your parentheses. I want to talk about two different ways of calling functions. And the first is to just give a name to every intermediate result. But naming is hard, and so we usually end up with something awful like temp or foo. The truth is that often these intermediate results aren't actually very interesting, and it's not worth coming up with good names for them. But there's another way, but this way is much more readable than the first way, than those nested function calls. But there's another way to call a series of functions, and that's with a pipe operator. So that funny % greater than % operator in R is the pipe operator. The R language has really nice metaprogramming features, and so that operator is just a function that calls the function on its right-hand side with the result of evaluating its left-hand side. In other words, these two snippets of code are identical, but the first is just a lot easier to read. You can read the pipe operator like the word then. So the first we say, please scale the data, and then compute a percentage, and then take a moving average, and then alias it. You're probably all familiar with the pipe operator in one of my favorite data analysis environments of all time, the Unix command line, right? It's worth noting again that this works so well because every tool in the system reads and writes a flexible common format, the text file. And so you can combine simple tools to solve complex problems. The Grafana UI emulates a pipe on top of Graphite's language, so you can read these left to right. First scale to seconds, then take a moving average, then apply an alias. Circonus's Cakewell language has a pipe operator as a first-class citizen. So let me show you a realistic example of using the pipe operator in R. Remember that we had the sunspot data where we had a guess at this 11-year cycle. Let's try to fit a real time series model to this data. To do that, the first thing I might want to do is to reduce the granularity of the data set. The raw series is daily, which is way more data than we need for a signal that moves as slowly as this. And so let's transform the daily series into a monthly series. Here's code that does that using dplyr. Dplyr is another part of the tidyverse. It's a domain-specific language for data manipulation. So like ggplot2, it's expressive and powerful, and I can only give you a tiny taste for it here. But if we read through this, we see that what we're doing is we're starting off with the raw daily sunspots data, and then the first thing we do is mutate it, adding a column named month, which just holds a string representing the month that the day fell in. And then we group by that new month column and apply the summarize function to each group. Summarize will return a data frame with one row per group and add a new column, which is the average sunspot number for that month. And if you know SQL, this all sounds very familiar. This is exactly like a group by with an aggregate. But it's worth noting that unlike SQL, I don't have to aggregate a group, each group into a single row. The functions that I apply to each group can return one row or 0 rows or more than one. In fact, dplyr can do anything that SQL can do and a whole lot more. Dplyr is so powerful and expressive that in the fullness of time, I expect the ideas in dplyr to displace SQL-like languages for analytic work. So here's a plot of that new monthly data with a smoother laid over it. It's worth noting that ggplot2 has really nice smoothing features built in, and so to add that smoothed line, all I did was add another layer, again with the plus operator, with a couple parameters specifying the smoothing algorithm and how much to smooth the data. Okay, and then just to finish up, I said we wanted to fit a proper seasonal time series model to this data, so here's code that does that. The details of this model are not very important. What I'm doing here is I'm pulling out that mean sunspot number from my data frame, and then I'm fitting a TBATS model to it with a seasonal period of 11 years. TBATS is like a fancy version of Holt Winters, if you're familiar with that. And then I can take that model and I can plot it like this. And so at the top, you can see the original data. At the bottom, you can see the model's estimate of the regular 11-year pattern. And in the middle is a sort of a seasonally adjusted level of sunspot activity. This is not a good model. It turns out that the solar cycle is actually super, super complicated. It's not like a clock running on an 11-year cycle. But this was just the fun first shot at like taking a look. Okay, so to recap, at the core of what makes modern R such a great data science environment are a couple of fundamental ideas. First, the data frame, which is a very flexible container for data that allows nesting of data to arbitrary depth. And second is this tool called dplyr, which is a domain-specific language for data manipulation hosted in R that, on top of being expressive and powerful, lets you write very readable code because of its support for the pipe operator. Together, these tools help achieve Hadley's goal of allowing you to solve complex problems by combining simple, uniform pieces. Okay, so at this point, I hope I have some of you thinking, hey, I want to live in the future too. If you want to start playing around with these tools and the larger ideas, I'd say it's really worth it to teach yourself to use R in the tidyverse. It is a fantastic tool for data-intensive problems like capacity planning or modeling dependencies in complex systems. There's also a thing called Shiny, which is a web application framework that you can probably use to replace your existing dashboards with something a lot more powerful and flexible. I should say here, I don't work for RStudio. I'm just a super happy customer of their products. But my real goal with this talk is to inspire tool makers as much as users. I want to end by looking at how Hadley did what he has done with the tidyverse. I want to talk about programming as a way of thinking. So I got started thinking about this after I read this really great piece by Alan Downey in Scientific American. It wasn't until after I read this piece that I began to understand what Hadley had done with the tidyverse. So the argument that Alan Downey makes is that modern programming languages are so powerful because they are very close to both the way that you might describe the concept in natural language and in formal, more mathematical notation. So there are really three different languages, he argues, when you work, that you work in when you work with computers. There's the ideas that are running around in your head in natural human language, and then there's something akin to math, a formal algorithm or a description of the problem, and then there's code in the programming language. And Downey points out that we are limited to the subset of programs that we can express in all three of these languages. And he takes pains to point out that it's what we can express, not what can be expressed. Like, theoretically, you can express any idea in a general purpose programming language. But we, it turns out, are the weakest link. We are limited by our ability to handle complexity. And how do we handle complexity? We break the program into pieces, and the larger the program, the more it has to be divided. In this essay, Graham talks about two different ways to do this. You can design either top-down or bottom-up. Top-down, you are certainly familiar with. You say, hey, my program has to do 4 things, and so it'll have 4 subroutines. Then you look at each one of those subroutines, and you split them up into some smaller pieces, and you keep doing that until you get a tractable idea that you can implement in a handful of lines of code. So bottom-up design is different. In languages like Lisp and in R, you don't just do top-down design. You also have the power to build the language up toward your program. You think, I wish R had a pipe operator, and then you just go and write one. You can do this because Lisp and R have strong metaprogramming features. The language allows you to operate on the language itself. And when you do this, Graham uses this lovely metaphor to describe the result. Like the border between 2 warring states, the boundary between language and program is drawn and redrawn until eventually it comes to rest along the mountains and rivers, the natural frontiers of your problem. In the end, your program will look as if the language had been designed for it. With ggplot2 and dplyr, Hadley has built the language up to the problems of data visualization and manipulation to the point that you can do practically anything you desire with small and beautiful code. And the ideas in the tidyverse are so good that I can't imagine them not leaking out into other tool chains. And so you should look at the tidyverse because Hadley is thinking more clearly about tooling around data than anyone else. And if you do look at the tidyverse, I think you'll be inspired to make the monitoring toolchain better. That's all I have. Thanks for your time.
All right, thank you, John. Up next, we have Alice Goldfuss.
Hello, hello, hello. I have a lot to get through and not too much time. So I'm going to start talking as I set up AV, learning to innovate and iterate here with you on the holodeck. At any point, Riker's going to load a program and, oh God. So let's get this over here. And then we hit that. Oh, it tried. It tried. That's going to come over here. Anyway, so this talk is called Martyrs on Film, Learning to Hate the On-Call Selfie. It is a talk about Twitter. It is a talk about on-call, and it is a talk about how Twitter saved me from on-call, and how I hope it can save some of you. So, who am I? I am Alice. I like systems, and Twitter, and tea, and not getting paged. But it didn't always used to be that way. Oh, I used to love getting paged. Absolutely loved it. When I first went on call, it was several years ago, and I was put in charge of my company's local data center. And by local data center, we meant 2 racks of servers that literally no one else cared about but me. But I was in charge of them. I was the parent of these little server babies. And I felt so good about being on call for them and getting paged. Because it was a sense of duty and responsibility, and I felt trusted and competent, and I loved getting paged, and I thought on-call was really good. Several years later, I still think on-call is good and has some benefits. It hones your troubleshooting skills. It forces you to identify the weak points in your system, and it teaches you what is and isn't production ready. Nothing teaches you about your systems like watching them break. Breaking at 3 a.m. repeatedly for the same problem every time. And so the next time something comes along your way on its way out the door to Pride and it looks a bit similar to something that you remember breaking repeatedly at 3 a.m., you can be like, hello, no, not that ever again. And it really does bring some benefits to it. On-call also helps with team bonding. You're in there looking at this horrific inferno with your coworkers by your side, trading off every week, and you come through understanding each other better and fostering a sense of community. And it was this sense of community that led me to start a game. The rules were simple. Every time you get paged, take a selfie and post it on Twitter with the hashtag #OnCallSelfie. Now, don't take a selfie as soon as you get paged, okay? Fix it first, okay? And, it doesn't even have to be fully fixed, but it's like, oh, I'm running a migration script that's gonna take 15 minutes. Selfie that and post it online and do it every time you get paged. And in the beginning, I was the only one playing. But I did play. I was paged in meetings. I was paged at night. I was paged while trying to just live my life. And slowly but surely, other people started to play too. People who followed me on Twitter started posting on-call selfies, including a very early contender for perhaps the best on-call selfie of all time, the restarting servers in my minivan selfie. So over time, I saw the on-call selfie pick up pace. In the beginning, in November, when it was just me, not so much. But then some key events happened to help pick up the pace. The first being that in early December, PagerDuty added an integration into its app to take it on-call selfie. Which was awesome because now people could take on-call selfies directly from the PagerDuty app. And people could complain about taking on-call selfies directly from the PagerDuty app. It was great. And when they added that integration, you could see that more people started to participate, and then we started to get our first spike, and that was during the holidays, during New Year's Eve. Some people took selfies to celebrate with their families, and they posted online. Some people took selfies to commiserate without their families because they were paged. And some people took selfies to celebrate the nerdiest holiday possible, the leap second. So that was New Year's Eve. And as you can see, it kind of went on this trend of like bumps up and down until we hit that peak over there. That brought us all together as scared computer children. The Amazon S3 outage. People were a bit shocked. Yep. People reacted in different ways. Some were right on it. They were like, mitigation skills, I'm gonna move over our site, and bam, we failed over, don't even need Amazon. Awesome, post a selfie. Others were a bit busier. And as on-call selfie grew in popularity, I continued to participate and post my own. In the beginning, it was equal because, again, I was the only one doing it, but I still posted mine. But there was a bit of a different trend. Like, I posted, but eventually I stopped. And it wasn't because I stopped getting paged. Oh, no, no. It was because I started to hate the on-call selfie. I started to be ashamed whenever I posted one. And that's because whenever I posted an on-call selfie, this happened. Why do you get paged so much? I hear it's bad when you're paged a lot. Seriously, how much do you get paged? Oh, you get paged a lot, like way, way too much. You definitely get paged a lot. And by the way, you get paged a lot. Frowny face. This gave me pause. I mean, isn't getting paged what on-call's all about? Getting paged a lot. I mean, isn't that what on-call is? On-call's just hell on earth to prepare us for the real one? Like, that's what it is, right? I mean, stop me if I'm wrong, but we've all been here. Preparing for on-call. You don't leave the house unless you're commuting to work. You clear all your non-work appointments. Can't even meet someone for lunch because you might get paged. Cook all of your meals beforehand because you're not going to have time. Oh, but also have soup on hand in case, like, the stress gets to your stomach and you can't actually eat the food you prepared. Oh, and never, ever plan on getting sleep. That's normal, right? I thought it was. In fact, I was so sure that this was normal that I started a repo called the On-Call Handbook, because I was like, man, on-call kind of, woo, we should all get together and share some tips and tricks about how difficult that is, because, again, it's normal. Ops has a military culture. I was milk-fed on it. Perhaps so were many of you. We have all of these military terms to describe how we do things because it makes us feel cool. I mean, we're not answering pages, we're fighting fires. We don't have an on-call kit, we have a go bag. Oh, and by the way, that really bad outage, yeah, that's now a war story. We use these terms and they make us feel important, they make us feel like we're battling the fray, and I understand why. I mean, it's exciting. A few months ago, GitLab had a pretty big outage involving their databases and their database backups. And they did something really interesting in that they actually put up a live stream so that people online could watch their engineers fixing the issue. And people tuned in and people are still talking about it because it was super cool. It was exciting. It was exciting to be a part of that outage. It made you feel like a hero. And for many ops professionals, that is the only time you get to feel like you're a hero. Developers get to feel like heroes when they're building things, but for many ops engineers, you only get to feel like a hero when you're saving those things. And so you want to be doing that because that's the only way you get any sense of validation. But that means we are always preparing for battle, always. Get your musket and your bayonet and go, it's Antonov all over again, and our enemy is the pager, and it's paging all the time, and we are going to ride into battle come hell or high water. When I was in film school, I had the absolute pleasure of being taught by a woman named Naomi Orwin. She was a screenwriter, worked on some Lifetime shows, and every time this amazing woman would sit there and look at freshman script after freshman script, she would say the same exact thing. Action scenes stop the plot. Think about your favorite action movie. I like The Matrix, I like The Dark Knight. Think about all of those action scenes, what they actually do to move the plot forward. Not the story, the plot. If Neo comes in from that end, and Mr. Smith comes in from this end, and Neo has to get Mr. Smith's Hello Kitty cell phone, what are the various ways that could happen? He could ask for it, he could tap him on the shoulder and do like a fast one and take it out of his pocket, or they could have a 20-minute garden battle. Remember that triangle you had to know, like English class, where it was like rising action, climax, denouement? There is no part on that triangle for 20-minute garden battle. I mean, there is in my life, like hell yeah. But not in a plot, and action scenes stop that plot. And pages stop the plot of your career, and sometimes your life. Think about it. Think about it. If you're trying to get a new job, what's going to look better on a resume? Building things, fixing problems, or 3 years of pages? 3 years of fighting fires. That's going to get you nowhere. You're not going to progress in anything. And if you're getting paged all the time, you're going to miss your kid's birthday party. You're going to miss hanging out with your friends. You're going to miss sleep, and it's going to impact your well-being. It stops the plot of your career and your life. VictorOps has started doing this state of on-call survey, which I signed up for so you don't have to. And this most recent year, they talked about the identifying qualities of miserable on-call professionals. And those qualities are, they have a terrible work-life balance, they are supporting poorly designed systems, they feel powerless to solve problems, and they generally hate the role. Fascinating. Now, I'm not disagreeing that these things are true, but they seem more like symptoms to me, and I'm kind of more of a root cause gal. So I put up my own survey on Twitter, and I combined the responses, I got about 100 of them, with engineers that I'd interviewed at other companies about their on-call practices. And I came up with 3 red flags that lead to bad on-call rotations. The first one is too few owning too much. This can be anything from being the lone IT professional in a law firm to being the 4-person ops team that owns literally everything for your tech company, but too few owning too much. And this leads to what I like to call Centralia infrastructure. For those of you who don't know, Centralia was a small mining town in Pennsylvania founded in the 1800s, and in 1962, the planned burning of some waste accidentally got into the mine shafts and started a mine fire underneath the town. And it is burning to this day. Experts believe it will burn another 250 years. The town is utterly abandoned. But if you were visiting it, you'd be like, all right, it's abandoned. It's kind of like, you know, Gone Home or something. That's kind of cool. Until you realize that, no, it's actually Silent Hill, and there are fissures opened up to hell in the pavement, and there's literally a dumpster fire underneath your feet. That is Centralia, and that is Centralia infrastructure. When you have too few owning too much, that is what happens, because they can't keep up. If something breaks, they can't actually put out the fire. They can't build a new town. All they can do is run from fissure to hell and slap some asphalt on top and go, ah, and then run to the other one. And so things will keep breaking, and they will get paged all the time, and on-call will continue to be horrible. The next red flag is Band-Aids, which I believe we are all familiar with. And you might think, no, that's like a symptom, okay? Like, that's a symptom, it's not actually the problem, but it becomes the problem as you use them. Band-Aids being that thing where you wake up at 3 a.m. and you're like, all right, I am a good engineer and a good person, and I know that if I try to fix this right now, it's not gonna work. So I will just slap a Band-Aid on it, and then tomorrow morning, oh, you betcha, I will be fixing it correctly. Except you get paid for something else. And then you put a Band-Aid on that, and you get paid for something else, and you put a Band-Aid on. So you just have like a stack of Band-Aids on your arm, and you just have to amputate the whole thing. I'm pretty sure that's how medicine works, and that's what Band-Aids do. And if you need specific examples, if you are bumping your thresholds, if you are snoozing pages, if you're like, oh, I don't have like 24 hours, just why? Why is it paging you to begin with if you can wait 24 hours? If you're putting delays into PagerDuty, if you're like, okay, all right, PagerDuty, if that's gonna page me, just wait like 2 minutes, because it probably will resolve. That's bad, that's flapping services. Those are Band-Aids, and that is pointing you to the problem in your on-call. That is a bad on-call rotation. The third red flag is no visibility. And this can work 2 ways. The first way is having no visibility in your systems, which I think we're all familiar with, right? You're like, okay, so something breaks and you don't have appropriate monitoring or alerting or troubleshooting abilities on the team. You don't have that expertise, and so problems fester and they continue and they get worse, and real problems go unaddressed because you don't have the visibility you need. The other way it goes is team visibility, going up towards your company. If your company doesn't know about your problems, if they don't know that you have Centralia infrastructure, if they don't know that you have a bad on-call, and if they know and they don't care, you're not gonna get anywhere. You need that visibility upwards. You need to be like, my burden is your burden, or you're gonna continue having terrible on-call. I think the obviously largest red flag of a bad on-call is too many pages. So in that survey I sent out, I asked people to tell me the number of pages they got per week on average for their worst and best on-calls. So here's the spread of the weekly pages during the worst on-call. The largest group, 27.8%, or like the biggest chunk, said that on average during their worst on-call, they got between 10 and 25 pages per week. The second largest group, 25.8%, said they got between 0 and 10 per week. First of all, who are you? Can I come live inside you like you're a tauntaun and you can just take me to work with your like 0 pages a week bad on-call? And still, 17% of us said that we got over 100 pages per week in our worst on-call. And that, my friends, was me. I blew away 100 pages a week every time. So yes, I was getting paged too much. As for get on call, the spread is more like what you would hope. About 90% said they got between 0 and 10 pages per week, but we still have 8% of people saying they got between 10 and 25, and there's still 1% of respondents said they got between 25 and 50 pages per week during their best on-call. That's not a good on-call. Spoiler alert. But how do we get there? How do we improve a bad on-call to a good on-call? I'm just going to talk about 2 key things that if you did them today would make your on-call rotation better. Just 2. The first thing is notification cleanup, starting with actionable alerts. And you're going to sit there and be like, yeah, I know, actionable alerts. And yet, 17% of us get 100 of them a week. So yeah, we're going to talk about actionable alerts. There are 4 factors to making an actionable alert. Something breaks. The customers notice. I am the best person to fix it, and I need to fix it immediately. If all 4 of these factors are not satisfied, do not page me. I do not give a shit. That is not an actionable alert. Send me an email. Send me an email. I'll get to it later. Don't wake me up. And while we're at it, let's cluster our alerts. Let's group them together. If I have a 50-node cluster, and the network link goes down, I do not want 50 alerts saying this node went down, this node went down, this node went down. Send me one alert that says, yo dog, the network's down. And for those of you thinking, okay, wait a minute. I need to know when each and every node goes down, okay? Every alert is a possibly actionable alert because it could have customer impact. I need to know when one disk fails in that entire RAID array because single points of failure just litter my life like fallen friends, and like you don't understand, I've got SLAs to satisfy. If you have 3-minute SLAs that you expect to be satisfied by a human, you do not have SLAs. They are already broken. Because no human is going to get paged, wake up, find their laptop, open their laptop, remember to act the page, find the problem, and fix it in 3 minutes. It's not going to happen. Your SLAs are crap. Have a robot do it. Have scripts fix it. Get rid of your single points of failure because 3-minute SLAs satisfied humans, they don't exist. Speaking of humans, the second thing you can do today to make your on-call rotation easier is to put your developers on call. Now, this seems obvious to me, and it apparently seems obvious to many of you. In fact, it was so obvious to me that it was only 4 words in my 1,000-word sysadvent article last year. And yet, developers had some feelings that they shared with me online. This person brought up something that literally no one had ever talked about in on-call whatsoever. You're just going to be fixing other people's problems on a Saturday. This other person wanted me to know how cruel and unusual it was to put developers on call. Also, that I'm a man. Also, they apparently have a cat that walked across their keyboard at the end of that, so good job having a cat. And this other person has the solution to this whole problem. Just have the junior sysadmin do it, yo. dev. I do nothing wrong. Call the junior sysadmin. Okay, now I know that there are developers here who are on call. I know there are developers here who support that practice and believe in it. This section is for the people watching who don't, because they clearly exist. Putting devs on call alongside ops means the people who likely caused the problem are the first to try to fix it. Which, by the way, if you're still dedicated to having 3-minute SLAs satisfied by humans, this is your best shot at that actually happening. Because otherwise you're going to end up with ops people who are 911 operators burning up that 3 minutes going, who the fuck? Okay, like just calling them. Page the devs. And when ops and devs work side by side, or devs and SRE, or SRE ops, whatever, it actually turns out that there aren't that many issues to begin with. They get satisfied before they hit prod because the right people are feeling that pain. I know these aren't new concepts, but if you're out there and you are still unsure about whether to put your developers on call, just do it. It'll make it so much better for you right away. And I know that's kind of glib. I know it's just like, obviously it's not that easy to put devs on call, but we're not talking about things that are easy. We're talking about things that you could do today to make your on-call better. But okay, let's start small. Start with the notification cleanup or better fatigue and on-call handling practices. Like, I got paged 2 times today, I'm gonna hand that off to my teammate because I'm fatigued, that's too much. Start there. And if you get pushback on that, if people are like, no, don't have time for that, then you're not gonna get devs on call and you're not gonna get people on your side. And what you need to do is leave. Leave that team, possibly leave that department, possibly leave that company. And if that seems harsh and difficult, again, this is your career and your life we are talking about. And if they're not going to prioritize it, you need to, and you need to go somewhere else. And this next part, I don't have time. And this next part is for, shut up! And the next part is for the CEOs and the business owners in the audience. Guess what? Your people will burn out before your company does. And 2 things will happen, and both are bad. They will either leave and take their institutional knowledge with them, or worse, they will stay and contribute to the problem and just write mediocre centrality infrastructure and make your problems even worse. Neither are things that you want. And if you're still not convinced, if you're still like, that's hard, I can't do that, I'm not a 15-person startup, well, here are some non-15-person startups who have evaluated their on-call quite recently. Etsy comes up all the time, as they should. They do a lot of work in this space, a lot of articles, a lot of testing. One of my favorite ones is this like creepy opt-in thing they did where they gave on-call employees Fitbits and they monitored their sleep schedules to determine whether or not they were being taxed too much on on-call. It's fascinating. They have done this. Another one is Heroku. Heroku is owned by Salesforce, a giant company, and a lot of their teams are kind of independent. And one of the teams that owns millions of database instances pushed back about 1.5 years ago, 2 years ago, and said, our on-call is too rough. We are not doing any feature shipping until we clean up our on-call. And now, today, robots restart instances, robots respond to issues, and if a human needs to intervene, they do it all on an app. Last but not least, GitHub. GitHub also tackled this about 1.5 years ago in a very GitHub way. Infrastructure was getting pelted a lot with on-call, so they just opened up a pull request and said, we are going to move these alerts, they're not actionable, they're going to go to emails, and these other pages we're going to offload to other teams because they're the ones that should be dealing with it. Got a problem? Leave a comment. 2 days later, they merged it. Full disclosure, I'm at GitHub now, and my team hasn't been paged in months. So, where does that leave the on-call selfie, though? I mean, if I'm up here saying that people shouldn't be paged too often, doesn't that mean we shouldn't have the on-call selfie? Well, yes. But I like it. I like the on-call selfie. I think it's really cool, and I want people to keep using it at least for now, because I don't know if you noticed, but we're still human beings answering pages. I mean, as much as we try, robot overlords are not here yet, except for Russian bots on Twitter. Otherwise, robots aren't here yet. Oh, low blow. It's still humans responding to pages, and like it or not, someone out there is gonna get paged. And I don't want them to get paged, but they're gonna get paged. And when they do get paged, I want them to come online and find a community waiting for them. And the on-call selfie has built a community. We finally get to meet the person on the other side of that 503 for like the first time ever. And it's really cool. There are people from all over the world doing on-call selfies. There are people with different backgrounds and different experiences doing on-call selfies, people getting paged in all sorts of different places doing on-call selfies. Yep. And they're all coming together online with this shared experience, and that is the community I wanted in the first place. I wanted to be able to see people from different backgrounds, different experiences, different views on life, all coming together around this shared frustration in our roles. And that is what I have. And if it wasn't for the on-call selfie, I would have burned out before I even knew I was on fire. That stupid hashtag was the monitoring system for my life and for my sanity, and you all were the alert system, and I thank you for that. It really saved my career and my personal well-being, and I hope it can do that for others too. So, yes, please keep doing on-call selfies. You get paged, put them up there, participate in the hashtag, and if you're not the person on call that week, if you're not the person getting paged, please look through the hashtag, I do. Reach out to those people posting multiple selfies. Give them a tip of your hat. Tell them it's gonna be okay, and ask them, why are you getting paged so much? Thank you very much.
Right on. So up next, we have 3 quick sponsor talks. The sponsors are a big part of what makes this possible. So I'd like to invite out first Signify. You have to clap for them.
Hear me?
Good?
Great. Hi, Monitorama. So my name is Guy, and I'm with Signify. And super excited to tell you all about Signify today. We are actually going into GA today, so we are launching today. Wanted to tell you a little bit about what is predictive machine intelligence for tech ops. And this is kind of like, what is it related to machine intelligence? What is machine intelligence to me? So this is, to me, machine intelligence in the context of DevOps. So it's really being much more proactive and trying to understanding from an issue that we are having in our production systems in a much more insightful way. And how can I prevent that from happening? Being much more proactive to issues than just being reactive to events. So we'll get back to that in a second, but I wanted to do kind of a TED Talk style. It was always my dream. So meet Ted here, and Ted here is actually an SRE like myself and like my team. We started Signify by tech ops engineers, not by vendors or of any kind. So now you're convinced, probably. So Teddy, like all of us, are on call. We know that. Getting paged, getting alerts, which are actually not that bad because those give us insightful information into what's going on in our production. But the main problem that we are all having is to understand what is really going on. It's not just about the alerts, not just by receiving events and correlating them. It's about really understanding in simple, plain English what can go wrong in the future, what's happening right now. So we got this page, not really happy about it, in the middle of the night. For me, I got tons of pages during Sunday morning, which really interrupts my coffee break, but that's just me. So we go, Teddy here goes into his laptop and start to use all the great tools that we're all using. Open source tools, time series based, log based, great vendors out there. It's all great, but something is missing, right? Like I cannot really tell you in a very simple, plain English what is wrong, or what is going on right now. So Teddy is not really happy about that, and so were we. So about over a year ago, me and my co-founder JP here, with a bunch of tech ops engineers started Signify. And because we are coming from this tribe, actually, we are here every year in Monitorama. We thought about how can we make it better? How can we make our life better as a community as well? So we started Signify by combining all the advancements in machine intelligence and machine learning throughout the last years, and combining that with our own expertise and with our own knowledge. And not trying to replace human, but on the opposite, trying to embrace all of our knowledge into infusing the system. So Signify is exactly that. You integrate all the different monitoring platforms that you're already using into Signify, and that can be open source, that can be third-party vendors. We have over 60 different integration points to offer. We also offer integration into anything that we cannot support through an open source agent based on Snap. So you might be familiar with Snap. We contribute to Snap as well. And that's another way to extend the integration point. And it's not really about getting different types of integration. It's about getting the data into a single place. It's looking into logs and events and time series data all in a single place that you can process. Once you have that, we're trying to give you a much faster answer into what's going on. And we do that by combining your expertise and the community expertise. So obviously, we do have some automated correlations, and obviously, we do look into events and try to get a sense out of it. But most of our differentiation comes from being a lot more active, going after the black holes of information where we cannot see or foreseen in advance. So it's really tech ops people working with machine intelligence together and providing that capability to all of us. And that's really our deepest belief, right? You can see John here mentioned that in his blog post, and really admiring that, because we truly believe that we cannot replace the human. We truly believe that the machine cannot know better what is going on in our production system, but machine can be pretty good into outlier detection, can be pretty good into statistical analysis, etc., and have unlimited memory and logic, but it's up to you to define the logic. It's up to you to basically combine those capabilities with your own expertise. And because of that, we put a lot of emphasis on reinforcement in the system. So you can give feedback to the system when it's doing something right or when it's doing something wrong. We open up a huge interface related to your decision. We call it decisions. So you have access to infuse the system with your own logic. You have access to things like outlier detection, correlation logic. It's a complete expert type system that you're in control and applying those logic to your own environment on top of all the automation that we already provide, on top of all the best practices with active monitoring that we provide. So getting back to this error that you see here, this is an actual downtime that Instapaper had a few months ago. It took them over 24 hours to recover and over 3 days to kind of fully recover from that. And the main problem here is that this is an unknown. They wrote a really nice postmortem about that. And eventually, the understanding is that they could have not foreseen this issue. And that's exactly what Signify is all about. For that specific use case, we are actually catching that, because one of the best practices that we have is related to MySQL, InnoDB, and files. So we are actively trying to find those needles in the haystacks, trying to be much more proactive about monitoring and not just waiting for events to come and just correlating them and just display, just doing noise reduction. So it's really the combination between being proactive and try to foresee the unknown versus just being reactive. So I hope that with Signify, Teddy now is much happier. And if you want to know more about it, please give us your lab, come next to the vendors area, talk to us. We have live demo we just launched today. You can see all about it live, and it's not just slides. And if you want to get grab of coffee, also please register. And if you're really interested about machine intelligence and tech ops, we are also hiring, especially for that. So thank you very much.
Thank you, Signify. And up next, Netzel.
Yep. Can you guys hear me? Yeah, no? I don't want to give this talk mute. That's going to defeat the purpose. Oh, this is your adapter, I guess. Well, I figured out the adapter. Okay, my name is Arvind Soni. I work for Netzel. Today we're going to talk about application mapping. How many of you guys have application maps? Raise your hand. Nobody. Oh, no projection. I don't have map either. Do I need to do something? Maybe that helps. Not mirror. Whoa. Perfect. So I gotta keep looking that side and keep talking this side. Okay. So application maps. Seems like not many people have it. I didn't have it a few seconds ago. It's simply put a bunch of nodes where your stuff is running, containers, lambdas, old VMs, bare metal, if you have some of those. So nodes are essentially where your code is running, and the edges are who is this node talking to, right? External services, DNS, load balancer, or that service that you don't know it should be talking to, yeah? So maps are essentially nodes and edges. Nodes are your things where your compute instances, where your stuff is running. Edges are network communications. Pretty simple definition, yet we don't have it. Why do we need it? Well, because nowadays things change pretty fast. All those toys that developers have, CI/CD, containers, Packer, Vagrant, they spin things up pretty fast and they come and go. Incident response becomes pretty hard in this kind of environment, as you can imagine, right? It's like going to a new city, you have no map and you have to go to that Armory theater or something, right? It's pretty hard. So you need maps for a lot of reasons: capacity planning, what is critical, what is not, incident response, understanding the dependency chain and stuff like that. And if you don't trust me that you need application maps, here I have as evidence Netflix, they have application maps, and they're a good company to follow about in terms of monitoring. So with that said, I'm not going to beat around the bush. There are a lot of advantages of having a map. I mean, the basic thing is it gives you visibility. What is running in your data center at any given point in time? What all things is it talking to? And how does it affect your business? That's a good thing to know if you are operations or SRE or anybody who cares about your applications, right? So there are multiple techniques for getting maps. APM techniques have been around for quite some time. Bytecode instrumentation, you wrap some magic inside Java and it starts telling you stuff, right? Open tracing is pretty hot and heavy nowadays. It's essentially SDKs. You insert headers and you pass the transaction IDs and stuff like that. Proxies, the good old proxies, they have become smarter. They insert the headers for you, right? Linkerd, Envoy. They call it service mesh. It's a good name. Operating system tracing has been around also for quite some time. dtrace, if you have followed Brendan Gregg around, he has a lot of information on tracing. So operating system-based traces like TCP dump, most of you would be familiar, is a good example. An extended Berkeley packet filter that's coming up is a good example, right? Of all the mechanisms, we're going to talk about PCAP a little bit because it's a non-intrusive way of generating a map. PCAP is readily available. It's a package which runs both on Linux as well as Windows, right? And if you can, imagine taking the L3 packets, the TCP dump packets, and somehow figuring out the application level protocol based on those packets, then you have hit a jackpot. Sort of, right? Without instrumenting anything, based just on those packets, now you know that you are talking HTTP, MySQL, DNS, and stuff like that. So you can see the HTTP URI, you can see the status code, you can see MySQL queries, and stuff like that. So all you need to do is take those packets, right, the TCP IP packets, and reconstruct the application level state machine, the application level protocol state machine, and you will get insights into the app. And then you dump it into a time series database, put a chart on top of it, right? So the third part is relatively easy. The second part is the tricky one, because different protocols, there are a finite number of them, but each one of them has their own state machine, so you have to do the work to take the packets, sample the packets, and reconstruct the application. But the hard work pays off because the result is a pretty neat map without going through all the hassle of instrumenting, without going through the hassle of SDKs, chasing your developers, hey, put this code over there, put this transaction ID over here and there. And honestly, not everything can be instrumented. We all know about DNS, load balancers, database servers that are like holy things that nobody touches, right? So there are a lot of things that can't be instrumented, and they become blind spot in your maps. Relying on a TCP fabric is a good way to get insights into those, right? So if you can use those packets, reconstruct into application maps, then you are golden. You will, be set for containers, lambdas, or whatever new fancy thing comes along. Yeah. So the last benefit that you get is all those golden signals that we talk about, latency, throughput, error rates, they are readily available because you're looking and listening at the network packets, right? You don't need to do extra hard work. And here I'm showing the MySQL-based insights on the queries and error rates and stuff like that. So if you want, you can go get your Google Map for your cloud app, is what I call. Like everybody loves Google Maps, so you can go get your cloud map today using Netzel or any of the other techniques. We prefer Netzel, right? So thank you for listening.
And our last sponsor has been with us, I think, from the beginning. Please welcome Jason from Datadog.
Hey everyone, so I'm Jason. I'm an evangelist at Datadog. Datadog's thrilled to sponsor Monitorama for yet another year. And personally, I was actually super thrilled because I didn't have to race like many of you to get a ticket before they sold out, because they did again this year. But as popular as this conference is, we all know that it's exactly the opposite when it comes to finding people to fill roles on our teams. Datadog's hiring. I know that almost every other sponsor is hiring. Quick show of hands if your company is hiring for engineers. Yeah, just like I thought. That's pretty much everybody here. So we have to talk about the whys of this, right? Why are we having this problem finding junior engineers, new grads to fill our recruiting pipelines? And when you look at job posts, they generally have three main parts: knowledge, tools, and experience. So on the first issue of knowledge, if we're trying to build the next generation of engineers, we have to think about how to provide them with the information that we think they ought to have. If you've ever sat in on an interview, it's pretty obvious that a lot of people don't have this basic knowledge. So we have to think about that. The second issue is the tools. When we think about traditional CS programs, or even those motivated self-starters who are out there teaching themselves, we have to ask ourselves, do they have access to the tools that we're using? And traditionally, those programs that are running CS programs, they don't have access to modern tools just because our tools that we're building are evolving so quickly that they can't keep pace. And the third issue is experience. I like to think of experience as the application of knowledge and tools and putting it all into practice. And if the lack of information and the lack of access to tools aren't big enough hurdles, getting experience of building systems that scale certainly is. But the great thing is that I think it's our responsibility to fix this, and I think that we can do it. So let's talk about some quick ways that we can actually do that. Now, as mentioned, I'm an evangelist, so my main two job responsibilities are docs and talks. And I think they should be part of everybody's job. Documentation doesn't have to be super formal. So first off, I'd like to encourage you all to just blog. Blog about the issues that you face, blog about how you came up with solutions. It really is that simple. There's plenty of platforms that you can do it on, for example, like Medium. Talks don't have to be super formal either. You don't have to give a talk here at Monitorama. You don't have to give a talk at conferences. But every single meetup organizer out there is struggling to find people to speak. So go there. Go to your local meetup. Offer to talk. Talk about something that you solved, some issue that you faced. Just share that information. And it doesn't really matter your presentation skills. They're perfectly happy to have you just come and talk, whether you have crappy slides or not. When it comes to access to tools, I think there's a ton of great open source tools out there, but there's also a lot of stuff that you're building or that you've built that could be open source. So consider the tools that you have and consider open sourcing them. And if you can't share the code, then go back to blogging. Share that information about how you built a solution. At Datadog, we've open sourced a bunch of our tools. We've also open sourced our agent. That doesn't really help students a whole lot because our agent's designed to work with our service. So one of my first tasks after joining Datadog was actually to put our product into GitHub's student pack to provide access to students. So simple way, start making your tools freely available. Consider joining the GitHub student program or consider starting your own student program. And then it comes to experience. So a lot of companies have internship programs. Most of them have problems. The good ones are super challenging because they're actually harder to land than actually getting a real job because there's just so many, there are many fewer spots to get in there. The bad ones are obvious when you have a bad internship program. They're just more interested in the free labor than they are in actually building experience or giving away education. But whether those internship programs are good or bad, they all face the problem of scaling. Companies that value interns are great, but there's always that tension between getting your own job done and helping an intern. And so we've really got to start considering as a community of engineers how we can step outside of that and stepping outside of our own work lives and starting to volunteer as mentors. There's a fantastic tech mentorship meetup here in Portland that happens on Saturdays. Check in your local area if there are mentorship opportunities or consider starting one. Because really when it comes down to fixing our shortage with engineers, it's up to us. So share your knowledge, share your tools, share your experience. It's really all I've got. Speaking of sharing, we do have socks up at the Datadog table, so drop by and grab some socks. Thanks.
I thought we were the ones who did socks. Let's do a quick round of applause for our speakers this morning. We have John and Alice. The holodeck is still burning after Alice's talk. It's hardcore. And to take us into the break, I'd like to bring out Brian, our final speaker of the morning.
Hello. Am I on? You will be. I will be on. I am on now. So this is kind of an interesting experience for me. I watch all the Monitorama talks, but Portland's far from Baltimore, and I just never really wanted to come. Sorry. I know Jason's somewhere around here, and the funny story is that I was at OSCON last year, and Jason's like, Brian, you're gonna speak at my conference, right? And I'm like, yeah, sure, whatever. And I kind of forgot, but I'm here now, and so let's do this. So I'm gonna talk about monitoring in the enterprise, but I want to be inclusive. Not all of you work at an enterprise, so I want to have a small talk for those of you who do not work in the enterprise. So monitoring things at your day job. Step one, pick a tool. Yeah. Step two, pick another tool. Or we can pick another tool. Another tool. Oh, wow. Another tool. And then here's my favorite one. That one bash script that does all the things, but no one actually knows how to do what it does. And then after you get past that, the next thing is you're going to monitor things. Things that are not important right now. You're just going to monitor things. And this is what always happens. Step three, bicker about the choices. And, you know, we pick these things, and mistakes were made. And what we always do is we end up going back to step one. And this is how it works in a small company. And actually, I'm not here to pass judgment. This is okay. Small companies are great places for new innovation, things that can't happen in big companies. So I say go out there, I'm talking to you, you, and you, make all the mistakes, tweet about them, and then do it again. But now here is something that I really want to talk about, monitoring in the enterprise. And at first this was a concise guide, but then I realized nothing in the enterprise is concise. So this is a slightly longer slide guide. I think we'll have 80 more slides, but it's not really all that bad. I'm Brian Lyles. Until 2 months ago, I was a developer at Capital One. I guess I developed too well, so they developed me into a director. But I fought back, and I directed myself into writing software and managing teams and owning a product. Don't ask me how I do it, but that's what I do. But my disclaimer here is I am not here to officially endorse anything. Anything I say may be wrong. Actually, it's probably right, but if you ask me about it, I will say that it's wrong. I am not here representing my employer. My employer paid for this trip. The ideas that are contained in this talk are my own. They do not represent anything that we are bringing to the market in the past, the future, or whenever. And then I have a whole bunch of other disclaimers here, but those aren't important. So on to the talk. I'm sure you have an enterprise monitoring team, and I can actually, by a show of hands, who here is on an enterprise monitoring team? I know a few people are because I had a meeting about it last week. I'm not kidding. So how do they know what to monitor? Well, of course, they monitor the enterprise, right? That's what it's in the title of the team. I'm going to monitor the enterprise, of course. But, you know, as a development team, and at my place of employment, we have an awful lot of development teams. Do they have access? Do we have access as a development team to your tools? Maybe, maybe not. Or actually we could, but we really can't find them because we have an intranet with 10 bajillion pages on there, a Confluence and a GitHub, and this custom site that someone stood up, and we just can't find them. Does your enterprise team know who to monitor or who to notify when something bad breaks? I don't know. Another question. Do they even know what's important? It is not what they tell you is important, but actually, really, what's important for your product? I work at a bank, and believe it or not, we write software that does more than just move money around. And, you know, it was a culture shock to me as well, but we actually do that. We have a pretty crazy machine learning group here at the company. Another question is, how does your enterprise monitoring team know when changes happen? Software's not static. New development teams are coming. Old development teams are shipping new things. How does your team know? Well, what did they do? Did they send an email? Do they go to a Jira board? Some people still use version 1. Do they go to a version 1 board? Do they just sit and pray and hope that something happens? I don't know. But I do know this. Whatever your enterprise monitoring team is doing right now, it's not good enough. So what do we do as smart people? Smart people. What do we do? And you all already know what the next slide is going to be. Well, you know what? They can't help me. Screw it. I'll do it myself. And thank you for coming to my talk today. This has been nice. I do want to talk about something, just a little sidebar. Can I walk over here? Because as a speaker, you're given a box, and it's kind of confining here, and my ideas are more expressive than this little box. But I broke my clicker, so I don't really think I can walk over there, but I really do, because it's a really nice, it's nice. I actually want to break dance right now, but I'm not going to. But, all right, sidebar over. So now that you're monitoring, what do you monitor? And what you're seeing here is the absolute ultimate ability of mine to add things to slides. So what we have here is we have a service foo, and everyone needs a service foo. It's a triangle. You know why? Because it's pointy. I don't know why. And then you have a service bar, rounded rectangle. And I only put rounded rectangles in there because somehow they're soothing to me. There's no points, but it's still kind of a square. And then everyone else has this, they have a Snowflake apps. Everyone has a Snowflake app. And of course, Keynote has no snowflakes in their little clip art here. So this is a star, but for this talk, it's a snowflake. So we have these three apps, Foobar and Baz. And what should you monitor in those? Well, I don't know. There's certain characteristics of all three of these that need to be monitored. So who knows those better than anyone? Your team knows these. And then here's the next problem. Now that we know that we're going to monitor, what should we alert on? Well, you know, the first answer is, well, everything. I don't know. Just if it moves, alert. We get a request, alert. If we don't get a request, alert. Figure that one out. Which gets into the next problem. Who should you alert? You know, I'm starting to realize after I wrote these slides, but after putting them on in front of a group, wow, this really sucks. Who wants to do this? But you know, this is all the questions that we should ask ourselves. And then we have one more new problem here is, what tools should I use? Before I talked about I just named Prometheus and Senzu and Zabbix. And if you're in AWS, you can use CloudWatch and whatever. Or you can use Datadog and SignalFX. But realize that you're in an enterprise. Believe it or not, if you're in an enterprise, and this is the greatest part about enterprise, what tools do we run? All of them. Why not? This team is running SignalFX. This team is running Datadog. It costs whatever, because you know what? At the point when you are in a large organization, the cost of an individual service is actually not a problem anymore. So what happens is when money is not your constraint, you just do everything. So I'm saying, as a team, you need to figure out what tools are you going to use. I said I wasn't going to actually talk about any tools before, but it's my show, so I'm going to actually change that. I like Prometheus. Why do I like Prometheus? You know what? I like the guys who created it. And I like how they think. I like that it is abstracted from something that was way bigger. And in my mind, it's just pretty nice. And I actually got to see it in production. I have a friend here in the audience who actually took it from a little thing to like a huge thing. And then he did what any great open source author did and just dropped it on the floor. I'm not going to tell anyone who you are, Ian. And then we have another problem. How do you monitor your monitoring tools? I think there's actually a talk about this later on, about monitoring your monitoring tools. But something I think about, so if we figure this one out, well, how do you monitor that tool? And then how do you monitor that tool? At a certain point, we're going to need to stop, and we're going to need to figure out, how do we know when things are going correct? So here's the reality that I came into is, I worked at a lot of startups. I've had my own company. I've done things, and I've always been, big fish, little pond. I go to a company with 47,000 people and a 10,000 person tech org, and I realized something very, very quickly. It doesn't matter how smart you are, how good you are competing with everyone else for everyone else's attention. And what you have to really realize quickly is that you are a super small cog in a super big machine. And I'll tell you something else. If you're on NICE or NASDAQ or something else, that CEO doesn't care about what monitoring tool you what you're using. He cares or she cares that, guess what, it's up. And up doesn't mean technically up, it means that it's making money. So let's take a step back. And I will give you another disclaimer. I am not good at searching Google for pictures. When I tweet and I put a little GIF in there, it's only because it's in my Google keyboard on my phone, or they give me the little link. I actually can't go search. I think I was born in the wrong generation or something. I just cannot do this. So let's think about what we have here. What do we want from our monitoring system? Well, we want to know if it works. And what does that mean? Well, that's up to you to decide. You need to figure out what it is that you are serving, and then you can figure out what it is how it works. Because I've seen teams that said, you know what, I'm going to use Nagios to monitor everything. And I'm just looking at them like, and okay. And they're saying, well, we're going to monitor this and we're going to monitor that. And I'm saying, okay. And we're going to monitor this and we're going to monitor that. And I said, okay, so what are you actually doing? Well, we have a static site. Okay. And then here's a more important piece. How do you know if your stack works well for others? We get so engrossed, and this is actually prevalent in larger companies, it's just a people thing, that we get so engrossed in protecting ourselves. Like I deliver widget foo. All I care about is foo kind of works to something. Sometimes I don't think about whether foo works well for others. And that's something that your monitoring system is going to need to expose. Not only does it work well within its scope, but also that it works well for others, because it's useless if it doesn't work well. So I'm going to introduce some slides. And this is interesting. I hesitated putting these slides up here in this room. There's some pretty good monitoring minds in here. I've had some pretty good conversations over the last day or so. But this is not for you. This is for everyone watching this on Vimeo or YouTube later. This is for posterity. I need to define the terms before I use them. So we're going to talk about SLIs, service level indicators. Those are the little points of saying this is one little point. So a good example of an SLI would be the error rates for some web service. And then what we have is our SLO and our service level objectives. These are metrics that we define internally that say this is how we need to operate to be successful. And generally you take a group of SLIs and you combine them together and you get an SLO. Than your customers. This is how you can actually say that something is working correctly. And then everyone's heard of an SLA, a service level agreement. This is what you tell your users or your losers how well you're going to act. And generally in a lot of cases with bigger companies, SLAs have dollar amounts with them, so these are pretty important. Another thing I'm going to talk about is white box versus black box monitoring. This is as technical as I'm going to be in this talk. Remember, a black box is you have garbage going in, you have a service, and then you measure the garbage going out. I like to actually equate it to this. There's some stink over here, there's something happening in the middle. How much stink can I get on the other side? And that's what your tool is actually measuring. So a lot of things like your Nagios checks or some other checks, they're just measuring how much of the stink permeates through whatever you've built. And then you have white box monitoring. And white box monitoring is I get inside, I know what's going on with your memory, your CPU, your secret sauce. I can get in there, I can touch your goodies, and we are very intimate. That was not a woo. This talk is PG, thank you very much. So, how can you know if you're meeting your SLA and your SLO? I don't know. Some people, they just say, well, we are. Or they create a PowerPoint. This is not PowerPoint time. What we really need are logs, metrics, and other things. I should have actually put a TM on other things because I am going to trademark this one. So let's talk about logs. So I have some rules for logs. If you create a log, use a structured log. Do not send me, it is literally sending me, it's a textual middle finger when someone says, here, look at my Apache log file. No. Even Nginx, if you look at what Nginx is doing in their newer versions, they're actually saying that maybe we should have a better defined structured file. I'm not saying you should use JSON all the time, but I'm saying at least I should be able to go in there and parse it out and not have to know the format of the parsing. Logs are useless if they're not aggregated. And what I mean by this is if a log is sitting on your server, it is the most useless log in the entire world. Send your logs off because I assume that, it's 2017. Servers are here, but they're not going to be here forever. So remember, if your log is important, ship it off to somewhere else. I'm not saying use Elasticsearch or Papertrail or any of those other things or CloudWatch logs. All I'm saying is that your log on your server is useless. Get it somewhere else. And then also remember, your log should tell a story. I see logs all the time where it'll be service started up, service is running, service had an oops, stack trace, service is running, service had out of memory. It's a Java app now, but they should tell us, actually, you know what? That's a horrible example because that is a story. It's a sad story. It's called I'm a Java developer. And I know there's Java developers in this room because I was sitting next to one this morning. But I do love everyone. And I do empathize with you. But back to my story. So now the thing about talk about is logs and metrics. Actually, if you can just remember anything from this talk, remember that logs, metrics. Brian said logs, Brian said metrics. So metrics are another simple thing. Is one or more numbers that give details about something. What's that something? It doesn't matter. I can't tell you. I'm not running your app. But like I said before, we can do things like we can have a metric for latency. We can have a metric for how long a web request took. We can have a metric for how much memory am I using right now. And the metrics are combined to create a time series. Just need to know that. And then other things, TM. One of the things I want to talk about is tracing. We talk about logs and metrics now, but tracing is hard. And I noticed that more people are talking about this. There's products out there. There's Zipkin. I know it's JVM based, but it's still pretty nice. But what is tracing? Tracing is I have a request, and it goes through one service, and that service calls another service, and that service calls another service, and that service. How do I know these all go together? Well, you can use tracing. And what's the great thing about tracing is that you can actually track a request through your whole entire microservice stack, because I know everyone here has microservice apps now. But you can also see things like, what is the memory usage? What are the slow points? Where is the hot spots? And we should just know these kinds of things. If you want to know more about this, I'm speaking. Can I talk about other conferences here? I'm going to. That was a rhetorical question. I'm actually giving two iterations of this talk at Velocity. I know Velocity is expensive. Just go to your employer, tell them to buy it. But I'm giving 3 hours on open tracing. And only reason I want to is because I think it is an amazing thing. And I think we've talked about logging. We've talked about metrics. Now it's time to talk about tracing to get that whole stack in order. So that's like next month, and in October, I'm not leaving the country. I might not be able to get back in. So please catch me at one of those two. So another thing I like to talk about and other things is health endpoints. A lot of people do their health endpoints like right now. If you're running in AWS and you have an ELB and you might have a page that you hit it returns back with a 200 okay. But that isn't okay because it doesn't tell you anything. It tells us okay. People ask me how I'm doing, and if I'm doing crappy, I still say I'm okay. So we need to actually understand that piece. So I'm proposing more, and some people do this when it comes to health endpoints. Put some stuff in there. I actually got in a little bit of a tiff with a developer one day. He says, "Why would you want to do that?" I said, if someone's relying on my service and our other backing database goes down, not managed by our team, shouldn't we be able to say, "Hey, it was him"? And I know that the whole stop snitching thing came through, but when it comes to your apps, snitch. If you're relying on something that goes down, tell everyone upstream it was him. So just do this. It's actually not very hard. You can write these health endpoints. Don't go find a framework. Just write it. It's just another couple lines of code. So another thing that we were talking about is observability. And I went out and I've been looking for what does observability mean. I can ask 10 people. I will get 15 responses. So I don't really care about the formal definitions. I want to be able to answer these 3 questions. Why didn't I have an outage at 3 p.m. yesterday? Not because someone pulled out their server or someone didn't pay the bill. What caused the load spike this morning at 11 a.m.? And if I decrease, my service foo capacity, what does that mean for bar? Well, I don't know. Your observability, whenever we combine this all together, we should be able to see these things. And another thing is when I was talking about events earlier, log events. When I was talking about stories, you should log events. You should be able to pull together some kind of weird state machine, and you should be able to actually see how your app is running from its logs. Just think about that. So and for the more visual people, who here likes art? I personally do not like art. But I think this is a great example because I knew there would be people here who did like art. So what is this a painting of? I don't know. I mean, you like art, right? You know art. This is a painting. This is a very famous painting. Well, spoiler alert, it's this one. It's actually the color scheme from this Rembrandt painting. So whenever you have these low fidelity, crappy logs, bad metrics, this is what you are telling people. Whenever you actually put the things together and you actually define observability, this is what you get. I don't know what's going on in this picture, but it had nice colors. All right, so we thought about observability. So now we've listened to Brian, and everyone is monitoring their stacks in isolation. We said, you know what, enterprise monitoring team, it's corporate welfare. You're not doing anything for us. Just go away, collect your paychecks, leave us alone. But I have a question for you. If a tree falls in a forest, will anyone hear it? How do we ensure we have greater visibility? Well, maybe we should have an enterprise monitoring team. But what should they be doing? And this is the rub. They monitor all the SLAs. Someone needs to know how well we should be doing. Someone needs to be there to make sure that we're doing our jobs. Someone actually needs to create a standard for what monitoring is in an organization, especially a large organization. And I know there's people in this room. I'm looking out here. There's probably a few anarchists out here. And that's good. I'm actually, I'm pro you being an anarchist. But here's another thing. When it comes to large groups and large groups of disparate people, anarchy doesn't work, unfortunately. There has to be some kind of order. And really what the enterprise monitoring team is doing is actually putting the order together. And someone has to get someone has to be on there for the central points for getting alerts. Because especially if I work at a bank, and I will give this example, if service XYZ goes down, but service blah, 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 way over there depends on it, and there's a lot of money going through this app, someone needs to know that there's some kind of dependencies going on through here. So you need an enterprise monitoring team to do that. And then here's something else that an enterprise monitoring team should be doing, and everyone should be running to do this. There's a lot of good talks about monitoring here today. The research for those kind of projects should happen in this team. And the reason why is if a development team needs to deliver features for business, they can't really be thinking about monitoring in a great way. So you need a team to actually go out there and figure out what the state of the art is. And then they need to figure out what kind of monitoring tools that we need. I mean, the simple answer is I work in the enterprise, we have all of them. I mean, and every single booth there, I could say, oh wow, oh wow, oh wow, oh wow. Oh, we have 2 of those. So, yeah. So let's talk about what should we be monitoring for. I didn't make this one up. This one actually, this is use. This came from Tom Wilk. How do you say his name? Does anyone here know Tom Wilkie, or is it Tom Wilk? Well, we're talking about whenever you think about monitoring, there's a use metric. It's the use, saturation, and errors. And really, this is what you're looking for from any service. And really, if you have a resource, something that's tangible, something you can touch, you should be able to get these numbers out. And then there is Brendan Gregg, I believe, who came up with RED, which is the error rate, and the durations as a distribution. So if you only have an endpoint where I can monitor this URL or this something or another, then you can actually get these kind of stats out of there. The Google SRE book has this one with the 4 golden signals, latency, traffic, errors, and saturation. I have a little bit of commentary about the Google book. It's really good, but it's really good if you're Google. I say everyone should read it, everyone should take in all the words, and then realize that only a company like Google can run like that. But there's still lots of great lessons in there for all of us to take away. So what should we be doing with our metrics? Or at least what should this team be doing? Well, one thing they should be doing is actually taking our metrics and pulling them up and giving us enterprise-wide visibility to what's going on. Because you know what, my little foo app, how does my foo app affect the org? Well, I might not think it's important, or in a lot of cases, I think it's super important, and the central team can help aggregate that. But realize your enterprise monitoring team doesn't own your monitoring. They shouldn't be telling you how to do your monitoring. They should be telling you ways that you can get it done. And also remember, as a development team, you need to get this. You need to share your stuff. And this is a problem that I have, is that if you, and I know I'm picking on Nagios, and only because I've had lots of years of pain with it, even back when it was NetSaint, lots of years of pain with it. If you're running a tool, remember that your tool is not only for your knowledge, your tool is to be shared with others. There are metrics and stats that you need to share with others. So just remember that. So, problem solved, Tom? Well, what's the most important part of this whole problem is the people, especially in an enterprise. And because it's funny, I love math, but I don't get to talk about math. So I'm going to talk about math for 5 slides. So assume your enterprise is a complete graph. Everyone knows what a complete graph is. For those who are humanities majors, the blue points are vertices. The black lines between them are edges. And this is important. So pop quiz. How many edges are in this graph? I don't know. Good thing that people smarter than us came up with formulas. And really all you need to do is take the number of vertices and you do this little formula on them and you get your number. So if you have one dev team, how many interactions do you have to have with another team? 0, 1. That's pretty obvious. That was just seeing if you were paying attention. Now, what if you have 5? Well, now you have 5 teams all talking to each other and they all need to have a conversation. That's 10 conversations. And then 10, wow, 45. And then you get 20. You know, you're not quite a unicorn yet, but you think you're going to be a unicorn. Your CEO was on CNBC once. And then you get to 100 teams. Okay. Now you're up to almost 5,000 communications that need to go back and forth. 500. All right, now you're a tiny enterprise. Oh, now 1,000. You're at 500K. And you know what? This is not even a large enterprise. Graphs for people who like graphs. The y-axis is exponential, just in case someone wants to tap me on the shoulder when we get out of here. Like, how do we go to 1,000 to 1 million? All I wanted to do is show you that everyone can't communicate with everyone else. This is what your central team can help you do. Your central team helps define hierarchies. I'm from the South. I can't say a lot of words. Hierarchies. But I'm not country. Remember that. I'm Southern, not country. They help define boundaries and hierarchies, and which I said before can help lead to just everyone having a better time. So, I know is it almost lunchtime? All right, well, hold on. So this isn't the end game. We can actually do more, and realizing that coming to conferences like this helps me understand how much more we need to do. I actually looked over the program. There's some great talks here talking about things that are state of the art. There's things that we don't have right now. So let's talk about this. When we think about tooling, we need to think that applications must actually start supporting metrics. Metrics don't start, or your actual monitoring doesn't start at your monitoring platform looking down. Your monitoring starts with your applications teams writing metrics that says that whenever I'm getting placed out there, you can ask me how I'm doing and I will tell you. And just remember that. I love how Prometheus allows that with their client. Datadog actually has that in their client, and we just needed to have that. So I'm going to leave you with one of my favorite XKCDs. So remember, this is how it is versus how it looks. So this is what we think monitoring looks like. You know, we're here, oh no, I got this crazy problem here. I got to analyze, 1 million time series per second every day. So we go in there, we're in the lab, we have a laser for some reason, and guess what? And then it's all amazing. But really, this is how it is in the real life. In the real life, we just go to work. We work hard. We try not to talk to people because that's annoying. And then we come up with something that is marginally better than what we had before. And realize that really that's how we have progressed. Think about how we got to here. No one came and said, hey, here's this shiny MacBook Pro that's already outdated. It'll make you do amazing things. No, we got a whole bunch of crappy computers before this one. And then we're going to get a whole bunch of crappy computers after this one, but we're constantly improving. And remember, constant improvement is all I'm asking for. And I want to leave you with a little bit of stank face, a little more stank face, and a little more stank face. Thank you very much. It's break time.
Yeah, so good news, bad news. Bad news first. If you think it's lunchtime, it's not. Good news, it's a coffee break, and there's coffee, including iced coffee, out back. But we need to start promptly in about 12 and a half minutes. So have your coffee and come right back. Okay, so hopefully you had coffee. Yeah. And hopefully you're ready for 2 more talks before lunch. And your attention will be rewarded because there are plenty of great places to eat here in Portland, and it's nice out. So please stay focused. We have 2 talks to go, and first is Roy.
Hi, I'm Roy, and I pace. And before I start this presentation, there are 2 notes that I wanted to make. One, I think this is literally going to be the first time I've ever been the least funny presenter in a day. It's an awkward and uncomfortable position for me, so hopefully you'll bear with me. The other one is I timed this talk for about 20 minutes. We're supposed to have 30, in the hopes that we'll have about 10 minutes of Q&A. So as you see things here, and you have questions about them, I have every expectation I'll be able to answer at least a few questions. So, I'm Roy. I work at inside engineering at Netflix. I'm here to talk about monitoring systems. So obviously what I want to actually start with is Joseph Campbell. Joseph Campbell was a mythologist, lecturer, writer, and in 1949 he came up with the idea of the hero's journey as what's been described as the monomyth. So the idea is that every myth out there is based on essentially some common elements. It's kind of like from a software engineering perspective, kind of like the pattern, like factory or bridge or whatever. And he proposed that basically all of those myths had some common elements. So it starts with an ordinary person who is just going about doing their own business. And at some point they receive some sort of call to action. And they might be relatively dubious about this call to action. They might be comfortable with their current life, or this call to action seems kind of silly. But eventually they take on the task and they embark on their journey. On their journey, they encounter a bunch of enemies and they vanquish them. They undergo some sort of terrible ordeal where they start questioning some of their choices. And eventually, they emerge from their ordeal successful and transformed and able to help their fellow human beings. I've gotten really good at searching the internet for pictures of my coulter for this presentation. So that's the end of the hero's journey, and that's actually the beginning of this talk. Because sometime around the beginning of 2013, we finished our hero's journey of building the next generation monitoring system for Netflix. It went into full production in our most busy region in Q1 of 2013. And that's where we started having some interesting challenges, because it turns out that if you build a system for real-time operational insight for a large, reasonably successful company, a system that's used both to know whether or not everything's working, but also to actually drive a bunch of automation like scale up and scale down, it's kind of important to know whether or not it works. And so it turns out that figuring out how to monitor monitoring systems mostly involves just, getting a bunch of turtles. So to talk a little about how we actually do this, I want to first disambiguate monitoring from alerting. For us, those are 2 very different functions. In fact, there are 2 completely different teams responsible for each of these. Monitoring, we think of as essentially sort of like specialized databases holding sort of like specialized kind of data. So monitoring systems are platforms that get a bunch of data in and make that data available for querying from other systems. Unopinionated is an important facet here, right? So they don't care, they don't have any opinions, there's no meaning to this data. Separately from that, however, alerting systems functionally basically output decisions and opinions. They may not be the right opinions or decisions. They quite often aren't, but we can talk about alert tuning in another time. But generally speaking, they take a bunch of data and they output opinions. So how do we figure out if this thing is actually on? So let's talk about alerting first, and let's talk a little about the alerting ecosystem at a very high level. Mostly involving rounded boxes, because much like Brian, rounded boxes make me comfortable, which is important when you're standing in front of 500 people. So we have an alerting cluster. The alerting cluster knows how to query our time series database, Atlas. And so basically a query that evaluates to true means that an alert is fired. A query that evaluates to false means that you're okay and you can continue sleeping. When an alert is in fact evaluated to be true, then we send the alert to an action service and tell the action service to do something about this. The action service can do a bunch of things. It can actually act on AWS to reboot an instance or terminate it or take it out of load balancer or, spend a bunch of money on, a new SG. Or we can send an email, or we can send a page, or a bunch of other things. Or we could actually send the alert into SQS, Amazon's simple queuing service. So that was sort of like the first version of this. We've now added the ability to have individual servers in our environment actually check alerts on themselves. There are some nice things about that we like a lot. One, it means that the latency of figuring out whether or not there's a problem in a given server goes down a lot. Instead of basically going through the whole publishing pipeline of our metrics, which I'll go into in a few minutes, you basically check on the local server, and so latency basically drops to nothing. It's also far more reliable, right? So if you're just checking for server conditions on the server, then you don't have to worry about the health of the overall sort of publishing pipeline for metrics. That's what our customers, Netflix engineers who have to actually operate their service for a living, like. From our perspective, every alert that is evaluated on an individual server is an alert that's not evaluated against Atlas. And given that Atlas can basically be thought of as a specialized database, we care deeply about the query load on Atlas. So this is good for everybody. The other thing that we now have actually is a stream processing system. Everybody needs one of these, or thinks they do. And you can actually define a job on the stream processing system that says, based on the ongoing sort of stream of events, you can actually fire an alert into the action service. And so figuring out whether or not this stuff works ends up being kind of relatively simple. Does everybody see the arrow sort of throbbing here? Thank you, Keynote, for animations. So basically, we have configured alerts on some long-running servers. And by the way, it's worth noting, it doesn't matter if you configure this kind of alert on one server or many, because all you need is just an ongoing stream. So the servers launch an ongoing stream of alerts against the action service. There's an alert configured here as well that sends alerts ongoingly to the action service and from the stream processing system. And then there is a checking server that basically checks for the ongoing existence of messages going to SQS and lets my team know when we start seeing one of these channels essentially not ongoingly sending alerts. One might ask, Roy, but what happens if the hot checker goes down? That'll probably never happen. So what happens is we actually have a cold checker. And the cold checker checks the hot checker. And one might ask, what happens if the cold checker goes down? The good news is that'll probably never happen either. But more realistically, the hot checker and the cold checker actually check each other. And that's how we know that alerting works. The other way we know alerting works is because probably, and we'll talk a little about volume, somebody's getting alerted at any given moment anyway. So let's talk about monitoring. And to talk about monitoring, let's start with a brief description of sort of like the overall sort of ecosystem of a, let's call it an Atlas deployment pod. So we have a published cluster into which metrics are sent at remarkably high volume. That published cluster sends metrics into what we call the 6-hour tier. We call it the 6-hour tier because this is the tier of servers that holds the last 6 hours of metrics for us, and we're not very imaginative when it comes to naming things. So the 6-hour tier then also flushes all metrics into S3. And there's a map reduce job that basically takes all the metrics in S3 and basically does a bunch of aggregation based on config parameters and sends those metrics into the 3-day tier. I'd like a volunteer to guess at what the 3-day tier does.
It stores it for 3 days.
Give this guy a reward. The audience participation part is not quite over yet. The MapReduce job also does basically different kinds of aggregation. and sends them to the 18-day tier. Anybody want to tell me why the 18-day tier is named that way? No players, huh? Okay, good. So, and then there is basically a query cluster, and you can send queries into the query cluster, and it maps out those queries to the 6-hour, 3-day, and 18-day tier, and takes back the results and gives them to you in large chunks of data or potentially graphs. So let's call this an Atlas deployment group. Sorry. So this is the box. Okay, so we currently run in a few production regions at AWS, and in any one of them, basically we have a bunch of servers who send their metrics into a proxy cluster. And that proxy cluster actually sends metrics into 2 deployment groups, one in US West 2, one in EU West 1. So basically all of our global metrics end up in 2 different regions, separated by a few thousand miles. And from our customers' perspective, and when I say our customers, I mean Netflix engineers who are operating, that's really all you need to know, because all of your queries and everything we do will end up going against one of these 2 deployment groups. So how do we know how well this works? Well, in a sort of feat of yo-dogging and sort of recursive engineering, we've actually deployed Atlas deployment groups in each region for our own use. And so all of our infrastructure, the proxy layer and the sort of customer visible deployment groups, send inside engineering private metrics, IEP is inside engineering private, we're not good at naming things, into these deployment groups where we actually do the monitoring. And you might ask, Roy, but how do you monitor the IEP deployment groups? Well, the good news is they're unlikely to go down. I'm surprised at the laughter because most of you don't actually see how we operate. It's almost as though you know what our daily life is like. And so it turns out that actually we have also built a critical stack which monitors the deployment group in the given region. It's worth noting, by the way, that for our own monitoring, all of the monitoring is happening in region. So we have opted to not deal with inter-region traffic for this really critical monitoring. And if your question is, how does a critical stack get monitored? The good news is, frankly, again, the IP deployment groups and the critical clusters monitor each other. And that works, and that's generally speaking how we know that things work, except that there's another way we know how things work, which is this. If you design a monitoring system with some important philosophical opinions, like for example, we should fail loud rather than quiet, and we should ongoingly strive to lower the time to detect for alerting. That essentially means that when your monitoring system has a sufficiently significant failure, you're going to find out about it. For example, this is a piece, this is the beginning of an email that was sent around like 9 a.m. or so on February 9th, 2017. It's sort of the beginning of a postmortem process we had from the last significant monitoring failure we've had. This morning, around 5:04 US Pacific, the active primary region hosting Atlas metrics data began experiencing issues, and a number of alerts were triggered across the board. So a significant enough failure will in fact trigger a whole lot of alerting in our system. This would be really, really terrible if we had significant monitoring failures on an ongoing basis. Thankfully, we don't. We typically see something like this happen, I don't know, every 18, 24 months, something like that. So we have so far basically decided that that's a reasonable trade-off for us. If at some point we start really, really pissing off our engineers, they'll let us know about it, one way or another, and we'll figure out a better way to fix that. So that's operational monitoring. So let's talk a little about cost for a second. So the good news is I work at a company that basically tells engineers that generally speaking, cost doesn't really matter. It's not exactly true, but it's actually the third priority behind speed of innovation first and availability second. So if you're running some sort of small service, we don't want you to worry about cost. Worry about serving our members. By the way, any Netflix members here? Oh, awesome. By the way, I work for you, so you can basically tell me what to do. So, generally speaking, don't worry about cost. And that's true, except that, well, let's talk about metrics growth, because we essentially, the cost of our system scales as a function of metrics. So this is basically from around May of 2011 when we started counting. We were at the time storing about 2 million metrics, which seems, I don't know, to me, I think at the time that seemed a little high. But you can see that over the next, gosh, like year and a half, we went from 2 million to 75 million, which is like a 37.5 times increase. So here's the bad news. This is the graph for the first year and a half. And then that high point is this point. And you can see that basically in the 3 years since we went live with Atlas, we actually grew by 3 orders of magnitude. Pop quiz. Does anybody know which thought leader said this? Thank you. So we don't pay that much per metric, but when you have billions of metrics, it turns out that they kind of add up. And the reason you end up with billions of metrics is because unlike in the old days, I remember running NetSaint at home back before it was Nagios. In the old days, metrics were basically just some sort of vector of ASCII characters, right? But if you look at the Metrics 2.0 manifesto and most modern telemetry systems, I would argue, most people these days believe that metrics should actually be basically sort of an arbitrary key value pair, right? An arbitrary list of key value pairs. So for example, this is a metric in our environment. You have the name CPU, NF region, US East 1, NF zone, US East 1A, NF app API, NF cluster, etc. NF node, device operational name, Roku, is supplemental video false? By the way, I have no idea what these last two mean, on complete operations, etc. So if you think about metrics cardinality as basically being the multiplier of every tag time every tag value, you can see how you might have rapidly increasing metric counts. There are 2 kinds of rapidly increasing metric counts that we care about. The first one is what we think of as an oops. In our environment, every engineer basically figures out what metrics they want to send into our system. And so you might be tempted as an engineer, especially if you're debugging something in test, to add some metric tags that might be kind of useful to you. Like for example, hey, maybe I should log the source IP address of the request originator. And if you're at the edge of our system, so actual customers talk to you, it turns out that our customers come from a very wide variety of, IPv4 addresses. I don't mean to be bigoted here. This is just IPv4. IPv6 has like dozens more IP addresses. By the way, just to be clear, this is a true story, and I'll show you in a second. Another example of what might seem useful is, hey, I'm going to log the account ID for the account holder of this request. And we recently celebrated having 100 million members. It turns out that 100 million is like it's a big number. It's like 10 to the 9th, thereabouts. And, or you might want to log customer ID. Customer ID actually maps relatively closely. Basically, if you're multiple profiles, then each profile has a different customer ID. If you're only one profile, then the primary profile is the same, the customer ID is the same account ID, but basically, large number. And then the other fun stuff is people who want to know how long a request took might reasonably add a tag that says, hey, execution time. And log it in like milliseconds. And most requests time out within about 30 seconds, which turns out that you've got like 30,000 potential tag values. By the way, remember that graph earlier? This graph, this little spike here was when our, one of our edge systems started logging IP addresses as a factor of metrics. And we're like, oh my God, 1.2 billion metrics, that's huge. And thankfully we got them to cut it down for a while. So what do we do about this? Well, it turns out that we actually have pretty good monitoring for both the number of metrics being received by us, so you can see this being a diurnal pattern, and also the number of metrics in our actual data stores, and we can, anything in our environment that you can graph, you can easily alert on, so we can get alerted pretty easily. And then we send people nice little emails going, hey, we are seeing 100 million increase in Atlas metrics over the past day, with the most dramatic increases occurring within the individual whatever applications. This translates to a specific dollar amount increase in Atlas cost capacity, with a nice little link to this report that we've created that actually lets you basically look at any given aspect of your environment and see basically the increase. Like overall, we went from 38 million to 138 million, and then each of these apps grew by some sort of ridiculous amount. And then people do the reasonable thing and we go back to normalcy. But that's the acute problem. For longer term problems, we go back to, in fact, the same song by Depeche Mode. Most people don't remember that that song includes the phrase, the graph on the wall tells the story of it all, which is like, boy, monitoring, if there was ever, like, I don't know a better like pop song about monitoring than that song by Depeche Mode. And if you do, I don't know, tweet it and hashtag Monitorama or something. So what we did was we ended up spending some of our resources as a software engineering team actually building a system that lets us visualize metrics volume over a longer period. So this is about actually 6 months. And what we did was we figured that if we just gave people the tools to know how many metrics they're using and how much it costs, they would just magically do the right thing. Quick hands up, who would imagine that that would actually just naturally work? Yeah, the Netflix. Wait, you're at Netflix. How could you possibly raise your hand? So it turns out that if you just give people numbers, that doesn't really do much. So what we ended up doing was we work closely with the application teams responsible for the top 10 apps here. The good news is, frankly, the app teams for the top 10 apps today are probably about 90% identical to the app teams for the top 10 apps a year ago. And we basically don't worry about everybody else, and we tell them not to worry about it. So we work with these teams closely. We've gotten them to agree to try to not grow their metric count by a factor larger than any business KPI they care about. We don't even specify it. That's worked reasonably well for us. You can see that basically we were relatively flat for 2016, which was a remarkable achievement for us. And in fact, about a month or two ago, we worked with one of the teams to effect about a 700 million metric reduction, which in our world actually translates to real money. So those are the two aspects of this that I really wanted to talk about. I actually wanted to talk about a third, but I'm not going to spend too much time on that, which is around monitoring how people actually use our system for two purposes. One, from a product perspective, we think of this as a real product with about 1,200 customers, all of whom know where we sit. And we're interested in figuring out how they use the product so we can make it better. The other one is we think that we might be able to actually get meta signals about the health of our overall system if we can understand sort of like correlation of alert volumes, for example. So there's a bunch of new graphs that we've got, and we're working on this project. This is, for example, email. This is just alert emails over the last month or so. You can see that there was one day where we got up to about 25,000. So we're basically running a small-scale spam operation, except that instead of telling you that there's a few $1 million reserved for you if you send us your social security number and bank routing number, we're just telling you that you've got a problem in your system. So there's a bunch of these things that we're working on. So this is, for example, breakup of alert volumes per group and per system. And this is something we're working on. And in fact, Swaroop, do you want to stand up for a second? This is Swaroop. Everybody say hi, Swaroop. Swaroop is working on this project. And last week we were talking about hey, how can I get the most value out of Monitorama? He said, and I was like, well, what do you want to do at Monitorama and why are you going? And he was like, I want to talk to other people who are interested in this field. And I was like, you know what? I can actually tell people, hey, everybody, meet Swaroop, and if you're interested in this field, find him. He'd love to talk to you. And that is the end of the presentation and the beginning of the questions. I've got about 6 minutes. So I'm happy to answer any questions. Meanwhile, by the way, inspired by Alice, hi Alice, I've put up a graph of the number of high urgency incidents since the beginning of the year for my team. We've had 23 incidents like that, actually 24, sorry, in the last 6 months or so. So, yes, well, so they're actionable. You'll notice mean time to action is between 3 minutes and 4 minutes. This is the stuff that wakes us up, and we tend to be relatively aggressive about that. But on any other note, what shall we talk about for the next 6 minutes before Will pulls me off? Yes?
Could you talk about the inputs that went into deciding in the periods that you have for the metric storage, the 6-hour, 3 days, was it, and 18 days?
We basically looked at the...
Question, please.
Yes.
Thank you.
Sorry, did you say could I or should I? Or would he? The question was, how did we decide between 6 hours, 3 days, and 18 days? First of all, the 6-hour thing, originally we had no way to do any sort of metrics aggregation before it hits the first tier. And so the question was basically how long, and by the way, the first tier was also the most critical one. We think that most problems should be able to be solved via the 6-hour tier. And so it was like, how long does it need to, how big does it need to be in order for you to be able to solve most problems, one. How small can it be while helping you solve that? Because of course that's like that's like thousands of servers. We hold all of this in memory. And then also, if you think about the MapReduce job, moving metrics into the 3-day tier and the 18-day tier, we've got to make sure that MapReduce job actually finishes. So the 6-hour tier allows that MapReduce job to actually fail once or twice and still go into the 3-day and 18-day tier. Nodes typically are still maintained within the 3-day tier, so you can actually see on a per node basis your metrics. But we think that given the average lifespan of nodes in our environment, which is shorter than 3 days, the 18-day tier actually drops node information for most of that. So it's an ongoing sort of like analysis of the kind of queries we have and balancing size and cost. Did I answer your question? Good. Yes? How many engineers does it take to operate this? Good question. It's hard to define operate, right? Because I don't actually have any operator people. I don't have any ops people, really. I have about an 18-person team of software engineers who also happen to operate this because, as Alice noted, if you build it, you really should monitor and operate it. It feels like the operational load is not that big. I would say that I could probably get away with 1 or 2 ops people, except that if I separated dev and ops people, I think terrible things might happen. Am I out of time?
I mean, if you don't mind giving it back, I take it.
Okay, tell you what, I'll take one more question and then I'll give you the rest of the time back. Who has a great question that they're going to be dismayed if I don't get to answer? High stakes. Who has a terrible, silly question that they'd like to answer? Bridget.
No way, because Alice had her hand up and I want to hear her question.
Very well. Alice.
Is there a certain television show or film on Netflix that causes more outages?
The question was, is there a certain television show or film at Netflix that causes more outages? I want to actually answer that in a more serious way. I've been at Netflix for about 8 years, which in like Roy time is, forever, and actually Netflix time is a long time. One of the things that I really appreciate actually is the sort of increasing maturity and stability of our system. When I joined Netflix, every time we had a new device launching, for example, the PlayStation 3, I remember this, we had a bunch of war rooms and we had a bunch of people paying close attention to graphs because every device launched could potentially take us down and cause problems. And then at some point, device launches became kind of normal and ordinary and we don't pay attention to them anymore. And then at some point, we started releasing new original content, like for example, House of Cards or Luke Cage or whatever, though this was way before Luke Cage. And in the beginning, every new original series launched, every new season was like a big deal and we were nervous about it and there would be war rooms, which is a problem because we would launch at midnight and there'd be people sort of like sitting there with food to watch graphs to make sure everything was fine. And then at some point, like original content became kind of like a non-issue. We release it and the people who care about the content watch it, but from an availability perspective, there's no impact. And then we started launching in different countries. We went into like, Canada, which is practically a different country. And we went into Latin America, and each one of those was like a really big deal. I mean, I remember we were going to Latin America, and it was over Labor Day weekend. And we had a bunch of people there, and I actually like brought in like a smoker and did a bunch of ribs. And then like we went into the UK, and that was a big deal. And then, you know, every new country ended up not being a big deal. We are at the point today where basically I would argue that other than the global launch in the beginning of 2016, which was like, let's go into 200 new countries, thank you. None of that stuff ends up having a material availability impact. None of that stuff is something we worry about, and none of that stuff is something that we, generally speaking, pay attention to, except for like the business people who care about that. So the good news is, no. Watch all you want. You're not going to take us down. Thanks for your time. I'm happy to answer questions later. Catch me around.
Well, Netflix sounds cool. Who knew? All right, we have a sponsor talk, then a talk, and then it's lunchtime. So that's cool. Almost as cool as Netflix. So let's welcome up logs.io.
Good. Okay, so. Hi, everyone. So thanks for inviting us. It's an honor to be here. Definitely a very interesting conference. We're Logs.io. We're, if you go out of this and you climb upstairs, we're on the right there. And I want to talk for a couple of minutes about what we do. So we offer the ELK, Elasticsearch Logstash Kibana, as a cloud service, powering it by artificial intelligence. We have a bunch of pretty cool features that are not part of the open source ELK, like live tail, like different data parsing, alerts, sub-accounts, multiple users, single sign-on, and so forth. When we present it and we say, okay, we're doing AI-driven ELK as a service, the generic question is like, so what's AI about it? So are you going to tell us you're doing anomaly detection, which are going to detect a lot of anomalies, and then it's going to be a lot of noise, and then we have to install some system to deal with the noise and give us all the alerts that we need. And we actually took a different approach of doing this, and started with the story of like why we develop it. And when we first started out the company, almost 3 years ago, today we run probably some of the world's largest ELK cluster. In the beginning, we didn't. We just ran like normal sized clusters, and we used to have a lot of cluster disconnects. Every few hours, the cluster would go down. Usually it happened during the night. I'm sure all of you that run ELK know how fun it is to when a cluster gets disconnected and it turns red and you can't update it, and by the time it takes it to recover, just a lot of work. We run our infrastructure on Amazon. We double, we triple, we quadruple our infrastructure. Didn't help. We complain about to Amazon that they're disconnecting our server. Didn't help. We complain to Elasticsearch that the thing doesn't work. Didn't help. Eventually, we spent about a month trying to analyze what's going on, and we discovered that there is one log line in the log when the servers go up, and it says SKB rides the rocket. You probably don't believe me, but if you were going to search for it, you're going to find it. There's more than 100,000 different mentions of it, and it has to do with the scatter-gather protocol of a specific kernel on Ubuntu that AWS were using. So that was unfortunate because we really wanted to be someone else and not our fault of not upgrading kernels on AWS. But it got us to develop our cognitive insight. And what our cognitive insight is that instead of looking at the data, we're looking at how people interact with the data. So what we do is every day we scan millions and millions of threads in different forums. We isolate different discussion threads. We know, is there a problem in the thread? There is a solution in the thread. Is the person who read it like the solution? If he read the solution, which product is he talking to? Which versions of product is he talking to? And all of this we're using, basically combining the human intelligence, that knowing all the questions to ask, with machine power to be able to process such a kind of large amount of data in real time. And we are searching all that data on your data or the data that is shipped to us in real time. So today we have more than 60,000 different insights. They come from a range of mainly IT operation and security, but basically think about it that you're limited today when you're installing a log analytic to asking the question that you know to ask, which is great. But what we give is the ability to ask all the questions anyone has ever asked this data in real time. So 20 seconds. So this is what we do. If you want to hear more about the feature, our compliance, want to see this in action, upstairs. And thank you very much. Thanks.
All right, please express your excitement for lunch with a very warm round of applause for Megan Anctil, our final speaker of the morning.
Let's see if I can get this set up. Damn it, how do I get my notes? Shit. I'm just gonna dance here while I try to figure this out. Give me a second.
I'll distract him.
You have it set up to not mirror displays?
Oh.
Who? Oh, you. Oh. Who knows where they're going to go to lunch? You do? Okay, follow him for lunch. Who doesn't know where they're going to go to lunch? Great, excellent. Even better.
All right. Yay. Now we have stuff. Sweet. I will try to keep this fast since I imagine there are plenty of people who are pretty hungry right now, including myself. So this is our many monsters. So to start off, maybe I won't use this. To start off, who am I? So my name is Megan. I'm currently an engineer at Slack, and I'm an engineer on our operations team, more specifically our visibility operations team. And I'll explain what that means later since, as someone mentioned earlier, what the hell visibility means different things at every single place. I've been at Slack for just over 2 years now. If you want to find me on Twitter, I'm Megsa _. The underscore is important. Someone stole just plain Megsa, so I'm Megsa _. But most of my tweets are really boring, so don't worry about it if you don't look. So what is this talk going to be about? I want to talk first about what this talk is not going to be. This is definitely not a how-to. This is not even a recommendation. And it's not going to be the best way to use tool X because the way that we use particular tools is probably going to be very different from how it works for you. This is basically what we've done at Slack, why we've done it, some things that we've learned while we've been building out these different systems, and hopefully it'll help some of you, you'll be able to find sort of comrades in arms for some of these tools. I also want to add the caveat that if you're using a vendored solution, this might not help you much, but hopefully it'll be interesting to some extent. So our agenda for today. First, why? Why anything? After that, we'll get on to each of the tools, or each of the systems that we have and the tools that we're using to build those out. In particular, metrics, logging, and alerting. Why are we using open source tools? And all of the tools that I'll be talking about today are open source tools. I want to start off and say that vendored solutions are actually pretty awesome. This is not a talk to shit on vendors. They are fantastic. They are a little expensive, and I'll explain some more on that later. Personally, I think that if you can afford them, vendored solutions make a lot of sense.
it makes sense to pay a team of people whose entire job is building good business-grade monitoring software. Those of us who work in companies, we have other obligations. They are able to take the time to put in a lot of work to give you a really good product. You kind of have to evaluate trade-offs and figure out if they make sense for you. It didn't for us, it might for you, and if it does, definitely look into vendors. That said, for us, with the scale of the things that we are monitoring right now, our yearly cost would be extremely high. I'm going to go into specific details on this later. I'll kind of anonymize some of the vendors to be polite. But basically, with a lot of the well-known solutions, we would be burning absurd amounts of cash. Unlike Brian, I don't work somewhere that practically mints money, so we have to be a little bit more frugal in how we choose what we're using. An alternate title for this talk, I've realized as I've been going through it, is basically technical things Slack has done to save us a crap ton of money. So one of the other reasons is that we also don't have enough people right now to build our own awesome in-house solutions. There are a bunch of teams doing really cool things at Twitter and at Facebook where they're building out things like Gorilla and Barenge, and those are cool, but we are a pretty small team of people. We've ranged at times from about 1 to 5 full-time engineers for our visibility operations team. What that team is, we are responsible for running and presenting metrics, logging, alerting. We're also responsible for a bunch of data warehouse infrastructure, and we also have our usual ops and on-call duties in addition to all of that. So when we're looking for solutions, we're looking for things that are well-documented, that have large communities, basically things where we can draw on the knowledge of people who came before us and who are able to help us out if we have questions. Eventually, we'll go off and test things on our own, but for now, we're going to stick to what is known to work. So why the particular tools that I'm about to talk about? I really wish I could say that we had started, we'd tested all of these things intensely and that we'd done really good bake-offs and we'd analyzed the pros and the cons. But the fact of the matter is we're human, we're all human. How many of you have used something here because you used it at your last place and you're like, I know this tool. Don't be ashamed. We can all be ashamed together. Pick your, in any case, what we did is we used a lot of tools that we had either used at old companies or that we were familiar with and decided to grow from there. In some cases, that's actually worked out pretty well for us because having that knowledge in advance was helpful. In other cases, the old knowledge and tools haven't really meshed entirely with the form that they've taken at our company now. So I'm going to dive deeper in a few particular cases. So let's start off with metrics. So some stats, and I will be showing some diagrams later for each of these things. We're using a kind of modified graphite stack for background. So we currently store up to 30 days of data, and we found that to be sufficient for most of our common debugging and investigation use. There is, as mentioned earlier, an additional data warehouse where we store logs and metrics for much longer, and you can perform all sorts of intense analysis and queries on those. That's an entirely different talk. We have a data team, they are awesome. This is gonna focus specifically on the things that we use as a base kind of for alerting and as well as debugging or looking for perf improvements, that sort of thing. We have 160 hosts, and really it's about 80 hosts worth of unique data with a replication factor of 2. Some of our metrics serve as the base, as I mentioned, for alerts, and we value high availability here because of this. So given the long time to restore from a backup for each of our hosts, we basically want to be able to swap a new one in as soon as possible if something goes down. We currently store 90 terabytes of data for those 30 days, and we persist about 1.5 million metrics per second to disk on the graphite side of things. So before we get into the details of what we've built, let's go through some anonymized pricing schemes. I apologize to all of the vendors that are here in advance. So first up, a vendor that charges per host. There's a couple different people that do this sort of thing. They range in price. Some of them charge you per host, but they have limitations, such as a couple hundred unique metrics per host. For us, we have some hosts that do on the order of thousands of unique custom metrics. So there's already restrictions in place that don't allow us to use them. Other ones, they scale based on the type of host that you're using in Amazon. And I think that the listed cost, and I'll get into the list versus actual cost in a second, the listed cost goes up to $200 for a particular host because of it's just that much more intense. That doesn't really work well for us. Another common pricing scheme that you see is we get charged per metric that you store at a particular resolution. We store it at a 10-second resolution, so for one particular vendor, it would cost us 25 cents per unique metric stored at a 10-second resolution. And the best one I could find was about 10 cents per metric that we'd store at a 10-second resolution. So for us, total unique metrics we send, not including aggregations. Aggregations are something separate, but basically things that get sent to our relays. We have about 9 million unique metrics. If you multiply that by 10 seconds per metric, and you get 50% off because it's not enterprise software if you're not having to haggle for what you're paying for. In our best case scenario here, we are paying $450,000, this is per month, with our current setup. And I don't know about you, but that's a bit expensive. Maybe not for Brian, wherever you are. Good job. I wish I were you. But for the rest of us who still live in startup land, that's a bit expensive. And it's for something that we have very little control over, and that's going to increase linearly as we increase our metrics, which is something that is pretty much guaranteed for us. We could try to do all sorts of tricks to try to save at a lower resolution to basically make it a little bit cheaper, but that doesn't really help. So let's take a look at what we built instead. Let's see if I can get this to point. Yes. Okay. So to start off, we have clients. Basically, our clients send metrics using Collectd, StatSite, and a bunch of other agents, sometimes just directly to the Graphite agent itself. That goes through an ELB, which goes to our Graphite relays. Another thing I didn't put in this is that there's an additional set of relays that are doing aggregations. Those are kind of specific to us, and it's not like I'm trying to hide them from you all. It's just that we could go pretty deep in the weeds of the weird side project we're doing there. The important thing to note, if you're using multiple relays, you need to make sure that your metrics are consistently separated and sent to the same relay for aggregation. If you have your relays separate from your storage layer, basically what happens is you have you have metrics going to multiple places, you're gonna end up with competing aggregations trying to go to the same storage location, and your aggregations are just gonna be completely bunk. But yeah, those live off on the side. Basically, they go to these relays, which go to Graphite Carbon. I'm going to zoom in a second. On the front end side of things, we have Grafana for visualization. That queries Graphite API, or we call it Graphite API is the host name that we use. And that also goes down to the Graphite Carbon boxes. So originally, we started off with pretty out-of-the-box things for our relays and for the Graphite Web, which is now the Graphite API components. On the client receiving side, we switched to using Carbon C Relay. This is an enhanced C implementation of Carbon Relay, and we found it to be a lot faster for what we're doing, and it provides some pretty good aggregations. This is zoomed in view, so we're going from here to here. Cool. On the Carbon hosts themselves, we've replaced a number of things. We've replaced Carbon Relay and Carbon Cache with GoCarbon. Again, that's kind of in the name, it's Go-based. It's a lot faster, and it maintains a write-through cache, which helps us when we're doing queries over here. And then on basically what is normally Graphite Web, we call it now Graphite API. We replaced everything with Carbon API and Carbon Zipper. These are, again, Go-based, and they, again, give us a lot of speed benefits. Given the size of our cluster and the number of metrics we have, basically all of the tweaks that we make are trying to make query performance as fast as possible for all of our users. There's other things we've done to try to sort of improve the user experience. So on the front end, we've added a couple things to Grafana by hacking into the code that the folks at BrainTank made, and also using custom dashboards. If you're not using custom dashboards, I highly, highly, highly recommend it. They can do pretty awesome things. So these three things right here are things that we added in ourselves. These are not things that you get with Grafana. The first one, while we try to think of things at sort of a higher level herd view, occasionally there's someone who wants to see every single metric for this one particular host. And this is kind of a hangover from our old Ganglia days. And if you want to see me cry, talk to me about Ganglia after this. TLDR, it's stuck in 1997 and it makes me want to vomit. Basically, But yeah, so basically what we've done is we have built a custom dashboard, and we've built a page that sits on top of that where you can put in the name of the host that you want to see, and it will just spit out graphs for all of the things for that particular host. Another thing we've done is this explore feature. People don't necessarily know where to find their metrics. Since we're using Graphite, there's this namespace of doom, which is kind of horrific. We want to make it easier for them to find their metric as soon as possible, so we just built in a little search feature. Under the hood, we're kind of aggregating and indexing all of the metrics that exist ourselves and storing those on the Grafana host so that they can query them, as opposed to fanning out that query to all of the carbon boxes and saying, like, tell me every metric that exists. We just do that in advance for them. And then finally, the ad hoc graph feature. If you're not familiar with Grafana or you're using it for the first time, like understanding how to make a graph, you're just like, you come in, you're like, I have this metric I want to see, and then it's like, how do I see it? We just kind of like stripped out that whole thing where you have to like go to make a new dashboard and then click like the graph panel. Like it's just like, here's a panel, put in your metric. And again, all of these things are basically to make it as fast as possible for people to answer any questions that they might have. So what are some of the lessons we've learned for this particular system? There's a lot more than here, but here's some of the key takeaways. The first one, tagging. This is Graphite specific. Not having tags is pretty hard, and your workarounds get to be pretty messy as you try to extract things from that static Graphite namespace of doom. Dot delimiting really sucks. It's like not intuitive. Metric metadata, like metrics 2.0 and the idea of metadata with your metrics is like the future. Just get on the bandwagon if you're not on it already. Aggregations. If you can aggregate it, people will want to aggregate it. We're going to have some audience participation here. I want you all to repeat something with me. You cannot aggregate percentiles. All together now. No, I mean it. Come on. 1, 2, 3. You cannot aggregate percentiles. Sorry. Well, actually, you can, but you should not. Basically, there's a fun secret. People will want you to make these aggregations even when the resulting data is complete and utter garbage. And even if you tell them this data is garbage, they'll still be like, this data looks great. And you're like, nah, it's jank. There's nothing in there that is real or honest. So yeah, aggregations. Be aware of what you're doing. Make sure your users know what you're doing when you're aggregating things, and make sure they understand what they're asking for when they want to aggregate things. And finally, forking things. Sometimes, like we've done with Grafana, we'll fork something for a very particular use case for us. As mentioned earlier, there's that host name, or the host view. That's pretty particular to us. Sorry, Mike. You don't always need to try to push it back upstream. And if you do try to push things upstream, make sure that you abstract them as much as possible so that it's actually useful for everyone else using the tool. What's next for us? We currently have plans to experiment with some other backends, specifically so we can get some of that tagging metadata that I talked about earlier. We also have plans to try some more Grafana hacking. Specifically, we want to get some versioning for dashboards, and we want to be able to do sort of team groupings around dashboards so that a particular team can go in and have like their own view, and they don't have to like query by the tag that's on the dashboard. We want to make it a more user-friendly experience for very large teams. So let's move on to our next monster, logging. So we're running a fairly standard elk stack. We store 2 weeks of data. Again, we found this to be fairly reasonable for most of the debugging purposes that people have. We index by day right now, and we're looking to start indexing by size to increase some of our throughput when we're writing. We have 450 nodes in our cluster. We store 250 terabytes of data. We have 140 billion documents, and we currently index 225,000 events per second to disk. And each of those indexes I mentioned is sharded across multiple nodes, and we again have a replication factor of 2. So some logging pricing. This is a little bit weirder to do estimates for because there's a bunch of different conventions. Generally, you're paying on the order of how many gigabytes you're storing per day instead of total, so that it varies. And the largest listed pricing volume I could find was for 100 gigabytes stored per day, which is almost 2 orders of magnitude off of our current daily storage of 16 terabytes. And again, with all of these things, these are like estimated pricing. As the volume goes up, usually you get more and more discounts, but we're just going to go with what's listed for now because that's what I could find. So the first, an anonymized offender, you're paying $50 per gigabyte. This is again monthly. $50 per gigabyte that you store daily, and this is for a license. You have to host it yourself. So yeah, you're basically paying for your own upkeep. Another one is going to be $150 per month per gigabyte that you store daily. They store it all for you. It's handled. And another is about 40 gigabytes per month that you store total. This is one of the few that basically gives you, here's how much data you're storing for the long term, and they just charge you per that. So again, if we assume a nice 50% discount for just the license, which is not this, we're at about $400,000 a month just for the license to run on top of the cost for having the hardware and labor ourselves. Or with our 16 terabytes stored daily, $150 per gig that we've stored daily with our nice discount, we're at $1.2 million per month for our logs. That's a lot of money. Again, Brian, so jealous. But here's what we decided to build instead with our handful of engineers. Again, this is fairly standard. All of our logs are submitted through, and from up here, these are just clients. Imagine this blows out into each of these. Each of these is a host. Basically, all logs are submitted through a local rsyslog client. They connect to the syncs, and I'll explain what a sync is in a second, via a long-lived TCP connection through the ELB, and they send all the logs using the REL protocol. We chose these syncs as an extra step where we use our syslog kind of as like a back-off mechanism. Basically, if indexing slows down here for any reason, we don't want it to basically push back up the pipe and start affecting our clients, which is something that you need to keep in mind when you have all of your logs going to a single location. Originally, we also had queuing, which is these sync boxes, and the filtering mechanism in Logstash all on a single host. But we found that they're bound on completely different things, so separating them out made a lot of sense. Right now, we've separated out Logstash into its own auto-scaling group that's basically bound on CPU triggers, so Logstash is able to scale up when it needs to, when it has more work to do. And the queues, if they exist, are not affected. Woo, zooming in. Basically, after Logstash, it goes to a bunch of client nodes, which then write to the data nodes. Again, writing first to the clients instead of the data nodes, just give the data nodes a little bit of a break. We have a bunch of read-only client nodes that we have as well, one of which currently has Kibana running on it for people that want to see the actual logs themselves and do searches. And then we have a pool that are queried by Grafana, again, for alerts, graphing, that sort of thing. And this thing that we've built in-house called Sieve, which is kind of a replacement for ElastAlert. Sieve is interesting in that it was built by one of our developer teams. Basically, they found that ElastAlert wasn't quite doing what they needed to do to see alerts for the web app itself. So they're like, we're going to build our own thing in true engineering style. But it's awesome, it works, and it's great. So lessons learned for logging. If you can structure it, do it. This is very similar to the metrics. We're talking about metadata. Parsing is not just expensive for the machine work for Logstash. It's also pretty expensive for engineering overhead for fighting with Grok. Like, how many of you have been like trying to figure out how to take this thing? You go to whatever that, I don't even know the website because it's bookmarked for me, because it's like, here, let's translate this. If you can structure it, do it. It'll make your life a lot better. Importance, similar to metrics, if you can understand what queries are being made and what log types are most important, it'll save you a lot of money and stress because you can figure out what logs you just don't need to keep around for as long or at all. And ABT, always be tuning. While you're tuning things, don't always trust what it says on the tin. While we were tuning parts of the stack, we found our syslog, Logstash plugins, and other things doing kind of funky things, and sometimes doing really funky things that they even explicitly said they would not do. So while tuning, don't be afraid to dive deep in the code if things look a little bit different from what you're expecting it to look like. As far as what's next on the horizon for some of the things we're building, we're currently playing with the idea of multiple clusters. We've trialed splitting out to multiple clusters that are fronted by tribe nodes. We might be switching to cross-cluster search nodes because tribe nodes might be getting deprecated. But ultimately, the idea is to isolate different log types and be able to better tune clusters based on the needs. Again, this is going back to hey, maybe there's a particular log type that we want to have always available because our developers are looking at this like every few seconds to debug things. Whereas like this like sad little log type that's looked at once can go live over here. We don't worry quite as much about like how fast it's being written to disk. Like we just don't care. We also might play around with replacing our syslog at some point in time for the courier and queuing mechanism, but we don't know yet. We have lots of ideas. So let's go to our last monster, alerting. So some stats around this. We have 140,000 services that we check. We monitor 6.3 thousand hosts. And impressively, at least I think so, our largest check latency is about 3 seconds. We have some auto remediation defined for our alerts because, like Alice said, basically if it can't fix itself, if it can fix itself, we don't want to get paged about it. But we do still like having a record of those like blips that happen where they were fixed. With auto remediation, you really need to be important that you aren't just silently fixing a problem, because sometimes that just bites you in the ass when you discover, hey, this thing has been having a problem for a month, but it thought it was fixing itself. So auto remediate where you can, but also make sure to keep track of those remediations that are happening. I don't have pricing estimates for this next part. As far as I can tell, most folks kind of do their own monitoring systems internally and then just push out to like PagerDuty or VictorOps. So instead, I'm just going to jump straight into what we have. So we currently use Icinga. Seems like there's not quite a lot of Nagios love today, but I'm going to show some love. Basically, we have too many services for a single Icinga host, so instead we have a federated setup across a bunch of hosts. There's a one-to-one mapping between clients and Icinga backends. We use Chef internally for our config management. Basically, we use Chef attributes. Those build out active and passive checks for each backend based on attributes that are defined on the node. We're about to zoom in. I'll show you in advance from here. Woo! On the back end, Icinga hosts themselves. We're running a couple things. There's xinetd, which basically exposes this live status API to Thruk, which is back here, and I'll talk about in a second. Thruk is basically a catch-all to see all of the things. I'll explain that. It also runs Icinga, which issues active checks and basically processes the results of passive checks. Those passive checks are sent from the clients using this thing we have called NSCA wrapper. And they send to NSCA server on the Icinga backends themselves. And once all those things are processed, Thruk basically sits on top and visualizes the state of Icinga's service results across all of the backend hosts. We also have CloudWatch to watch some things for like ELB spillovers. We have Thousand Eyes, which monitors uptime from agents for things across the world for Slack, like Slack.com. Interestingly, it is also our monitor that watches the monitors. It's the thing that lets us know if Icinga is having issues and is down. And finally, all of these three things pipe into Slack or PagerDuty when there is an actual problem. So some lessons learned here. This is, again, fairly Icinga specific. But if you have a lot of hosts, active checks get very resource intensive. It's very, that's the first thing we had to basically cut out. We started a few years ago with a fairly healthy mix, and we've since moved to nearly 95% passive checks. That means that hosts are sort of checking themselves, trying to see what's up, and then going to Icinga and saying like, hey, I'm cool, or hey, I'm like pretty fucked up right now. Usability. Alerts need to be usable. This is, I assume, a theme that we will continue to see for the next few days. To make sure alerts in Slack make more sense for whoever gets paged, what we've done is make it so the Slack message can unfurl a Grafana graph where applicable. The titles have links to runbooks, which we have fairly rich runbooks that, again, have links to applicable graphs. Here's the things that you need to do to fix it. Here's who you can escalate to in the event of an emergency, what's happening, who's affected, do you need to update the site, those sorts of things. The most important thing for us with alerts, similar to logging and metrics, is making sure that whoever needs to can find their answer as fast as they possibly can. And similarly, we want to have making alerts be very, very easy and frictionless for developers. We've experimented with Grafana alerting. We're currently on Grafana 4. This way, developers can just make a graph, say, hey, I want to alert on this thing, and go from there. They don't need to worry about understanding Chef. They don't need to understand like who to issue the query to. They just will have it happen. Not being able to do this in the past has kind of slowed us down, and so we're trying to speed that up. What's next? Icinga 2. It is the future. It requires us to make a bunch of changes to the infrastructure that we currently have. And while it's likely we're going to go down this route, basically we haven't done it because we've been following the old adage, don't fix what's not broken. Isinga has worked fairly well for us. Like every now and again, there's something that could be done better, but like it's been a pretty good workhorse for us. So we haven't wanted to invest the time and effort to completely append it and just put a new thing in its place. And the last thing is that given that we have multiple systems that currently alert, it would be really nice to have a single unified interface. And actually, I can't remember who, there's like the vendor earlier who was talking about that. And I was like, tell me more. But basically, being able to summarize the state of all things, not having to know that you need to look in Throop or look in Thousand Eyes or look in CloudWatch would be really nice. Slack and PagerDuty let us know when things are broken and aggregate across those, but it would be nice to just be able to say, what is the state of this cluster across the board right now? So the question that I think pretty much everybody wants to know, the question that Missy Elliott likes to ask, is it worth it? Do I think it's been worth it? So as mentioned before, we started with very few and we're currently up to 5 full-time engineers. And we're all working on a combination of these systems and the data warehouse infra and our ops stuff at various points in time. But money-wise, hosting and running these solutions ourselves versus the hypothetical vendor solutions is saving us more than $1 million a month, which is pretty good in my opinion. It also doesn't even take into account the cost of egress, of data egress if we sent our logs or metrics to an external vendor, since we're doing everything in Amazon right now. So that's even more cost that I could probably calculate. But yeah, saving money. Money's awesome. Also running these solutions ourselves has allowed us to customize flexibly as strange needs or problems have come up. If a particular concept isn't available for a vendor solution, you kind of have to wait and hope that it comes on their roadmap. Running it ourselves, we can just build these concepts into the tools ourselves, and we don't end up being that like big bully who's like, we're paying you this much money, build it for us right now. Like that's no fun. Like I don't want to take over someone's company just because we have a lot of data. I mean, maybe you want to, that's cool, do your thing, but it's not what we want to do. The flip side, these systems do require a fair investment of time from our team, particularly making sure that they are stable, reliable, and performant at all times. And that's a trade-off that's really hard to evaluate up front when we're making all of these considerations, and it's something that you'll need to keep in mind too if you're doing something similar. So at the end of the day, the only constants in life are life, death, taxes, and the fact that if you build a storage system for metrics, your developers will basically be calling a wrapper as fast as they possibly can to store things in it. You can try to calculate what your inputs are going to be using things like number of hosts, number of engineers, number of lines of code, number of users you expect. But the only thing that is guaranteed is that those numbers are going to keep growing and in ways that are hard to estimate. I was watching backstage, I think I saw Roy's graph of where they just like grew by an order of magnitude of the number of metrics they have. And it's like, it's kind of hard to predict. Like you know that you're going to be growing, but like how fast? Who can say? You can't, literally. The main thing you need to figure out is what your priorities are. Before you try to fit solutions in place, you need to decide how much you're willing to invest in each of those 3 areas that I mentioned earlier. For us, we value flexibility, money, and time spent, probably in that order. For you, it may be very different. So I think I'm just at time and just in time for lunch. If you have any questions, if you want to commiserate about any of these technologies in particular, if you want to slay some of these beasts with us in the technical, D&D, or Beyonce sense, our whole team is here this week, minus Tom. Shout out to Tom in Australia. Basically, I want to thank all of you for your time. Thanks for watching, and hope you have a good rest of the conference.
Hello, real quick. Thank you, everybody. I hope everybody had a great first morning of talks. That was pretty amazing. So we're going to take a quick break for lunch. We would hope everybody can get back by 2:30. Ideally, 5 to 10 minutes before then. Next talk starts promptly at 2:30. If you're looking for lunch places, there's Little Big Burger. There's Conveyor Belt Sushi right behind us. Lots of places in a very close, tight walking radius. 2 blocks south, 2 blocks east is the Washington and 10th Street block of food trucks. Amazing stuff out there. I especially recommend Whole Bowl. So everybody have a great lunch. I'll see you afterwards.
Welcome back. I hope everybody had a good lunch. Is anybody still hungry? Good, okay. Hungry for talks. Hungry for knowledge. Who's hungry for knowledge? Nerds. So we're not going to do lunch again today, but we will tomorrow. I mean, it makes sense. There is coffee that will be continuing, I think, through the afternoon break. So grab it if you have not yet had enough coffee, although be careful. So we're going to be starting off with a couple talks for the afternoon before we finish up and then go to the cool after party at Pips and Bounce. You'll get to see from a few more speakers, a few more sponsors, and then we'll be done for the day. Before we do, let's just give a huge round of applause to the venue. This place is basically the coolest place to have a conference. They're awesome professionals and they make it easy. And the music is great, despite what Corey thinks. Corey. So, please take a seat and then we'll begin our first talk in just a minute. I'd like to welcome out to the stage Aditya Mukherjee.
All right, good afternoon, everyone. I'm excited because I'm here today and I get to talk about one of my my all-time favorite topic. My name is Aditya and I work on the observability team at Stripe, primarily on our open source monitoring tools, and you'll see one of those in a moment. At Stripe, we provide a simple, unified API that enables businesses of all sizes to accept payments online. And last year at Monitorama, you heard from one of my colleagues, Corey Watson, on how we built a culture of observability at Stripe. Today, I'm going to tell you about how we've built and are continuing to build the infrastructure of observability at Stripe. So you've been told that this talk is about tracing, and it is, but when I say tracing, it might not just be the kind of tracing you're thinking of. When I talk about tracing, I mean full cross-sectional visibility into all aspects of your production systems, complete with context and continuations of state, whether or not that's tied to an HTTP request response lifecycle. And if you're a big company like Google or Twitter, you can create your own integrated tool that handles all of that for you. And Google has done that. But for the rest of us, we're probably relying on open source or third-party vendors for at least some portion of our monitoring stack. And it's hard to get fully integrated cross-sectional visibility into your code if you're using multiple tools because there are always going to be gaps in between them. But fortunately, there's a way that companies smaller than Google can get this same level of visibility without writing their whole stack from scratch in-house. And the secret there is all in the metrics pipeline. So I'm here today with one goal, to inspire you all to take ownership of your metrics pipeline. And not just any kind of metrics pipeline, but an intelligent and context-aware pipeline that can help you achieve the pinnacle of system observability. So some of the stuff that I'm going to talk about today already exists in our open source tool called Veneur. Veneur is our take on an intelligent metrics pipeline. But some of it, that's what we'd like Veneur to become. And that's the exciting part. That's what you can help us out with. We want to make intelligent metrics pipelines like Veneur the gold standard of monitoring in our industry and make that accessible to companies of all sizes. We built the first version of Veneur ourselves at Stripe, but we're not the only ones using it or even contributing to it. Sentry and Bluecore are two other companies that have monitoring and runtime data right at the core of their products, and they both rely on Veneur for their metric pipelines. So let's start with the story. It's 3:07 in the morning, you're in bed, you're asleep and dreaming, and suddenly your pager goes off. Now I know this has never happened to you, but let's just imagine. So you're a little bit annoyed that you want to get back to sleep as soon as possible, but you need to figure out if there's a problem. What's the first thing that you do to diagnose it? Well, you probably pull up a dashboard. And here you can see, all right, the API success rate has dropped just below a threshold. You might be able to see the red dotted line. Okay, so some requests are failing. But why are they failing? Now, for all we know, someone's written just a bad web crawler and it's generating a ton of 404s. Like, no one really needs to get paged for that, right? So how do we test that hypothesis? Well, we look at another dashboard. And on this one, we see, okay, there are some 404s, but there are also some sporadic 500s. So some requests are clearly actually failing in a way that's problematic for us, in a way that we do need to address. But why? We don't have any more information about those requests here on this dashboard. So we look at another dashboard. And here you can see, okay, we've got hundreds of boxes that are involved in these requests. And of those, only 4 are actually causing problems. And in fact, not for all requests. Notice that these are orange, they're not bright red. So that means that it's only some requests that are failing. But why? Is it, what is it about those requests? Is it the users? Is it the country that they're from? Is it the HTTP methods that they're using? We can't keep track of all of those factors because the cardinality of the data is too high. There are too many axes to keep track of, both at an implementation level and also to present in this dashboard. So there's no context here, and that's a problem. We want to de-anonymize our dashboard data. So to de-anonymize it, we might look at another tool, another dashboard, which are our logs. The problem with logs is that even when given access to structured logging, most people use them as literal log line, just text that logs just a pure chronological log. And it's possible to extract that information into something like, say, a histogram, but even with the absolute best of search tools, that's a lot more thought than you really want to have to put into it at 3 in the morning. Remember, you want to get back to bed as soon as possible. And oftentimes, you're just going to be poking at individual log lines anyway. Because how many of you have written log lines that look like this? Yeah, I see a few people raising their hands, and I think, and I heard some more laughter, so I'm assuming there are even more than that. Like, I'm making it look a little silly here, but when you think about it, most uses of logs follow this overall pattern. You don't actually even care about you don't even actually care about the text of this string right here. About to query object, that doesn't mean anything. It's just the name of the log, and it's a way of disambiguating that line from other log lines to confirm that, yes, that particular line of code was run on that particular object ID. So when you think about it in this light, you realize you're just using logs like a runtime debugger. It's GDB, but by human. And so reading through the logs to find a bug, that's really just one step away from actually pulling up your source code, not looking at your tools at all, and just running through that, loading that into your head, and trying to analyze it. Well, why might my code be failing right now, in theory? I would go so far as to say, and in fact, I have said this, I've written about it, you can check out my feed if you're curious, that you should never have to look at logs. If you have to look at logs, something is wrong. It means that there is a gap in your system's observability tools. And one other tool for filling in that gap is request tracing. So, okay, fine, we go to another tool now. So if you're lucky, yes, you've got request tracing implemented around the part of the code that's breaking. But you might not. Like, you might have tracing implemented at a function level, and in this case, you really need visibility into a certain block because you know that that hot loop is causing problems. And even if you do, it's not wholly integrated with the dashboards that you were just looking at. You have to go to another tool, you have to come up with another query that matches that corresponds to the data that you were just looking at. And so now you've looked at 5 dashboards on 3 separate tools just to evaluate the problem. It's 3:30 in the morning, you still don't even know what's going on, and at this point, for all you know, you could be up all night. So in physics, all matter is built off of certain fundamental particles. We have protons, we have electrons, we have neutrons. And all matter in existence, everything that we can see, is built using these fundamental particles. And in monitoring work, everything we see is also built from certain fundamental particles. We have metrics, we have logs, and we have traces. The challenge with metrics is that there's no context, as we saw. And the problem with logs is that they're too granular, there's too much context, and they're hard to aggregate in a useful and meaningful way. And the problem with request traces is that they require planning to use effectively. And that's actually not something that's limited just to request traces, it's a problem that's shared with all monitoring and observability tools. Because monitoring information is only going to be useful if developers have put in the time and the effort to predict, and not just to predict, but to successfully predict which parts of the code are the most likely to break and what information would be needed to debug that code from a broken state. You can think of this like the problem that we have with tests. It's relatively easy to write a test case for a bug that you've discovered. But it's a lot harder when you're writing the code the first time around to figure out all the potential edge cases and exactly what you need to write for full coverage in your tests. And metrics are like tests, but the stakes are even higher because by definition, you're almost only ever interested in your metrics when things are already going wrong and going wrong in production. So this is one of the main reasons why they always say that the people who write a service should be the ones who are on call for that service. It's not really a punitive statement like, if you don't instrument your code, then you're going to suffer for it. No, it's just a practical observation that those are the people who have the context necessary to parse that information quickly at 3 in the morning, and they're also the ones who have the context to instrument their code at the time they're writing it. They can put themselves in their own shoes. So let's imagine for a moment, what do other engineering fields do? What if we built houses this way? If we built houses the way that we built software, the builders would never be able to leave your house. They would have to stay there and operate every single door and window for you. If your light bulb went out in the middle of the night, you'd have to call them. They would have to run over and take a look and say, yeah, it looks like your light bulb has fused. I mean, we don't do this for any other kind of engineering, so we shouldn't do it for software engineering either. And this is what observability means. It means designing the interfaces to facilitate visibility into your systems for whomever is actually going to be operating them at runtime. So let's wind the clock back by 12 hours. It's not 3:07 in the morning now, it's 3:07 p.m. the day before. And we're not the developer who just got paged, now we're the developer who wrote the code that caused the page. And it's okay, we're not here to point fingers. Raise your hand if you've ever written code that caused someone else to get paged. Okay, yeah. That's 80% of the people are raising their hands, the other 20% are total liars. So in this case, we're writing a really basic web app. We just need to fetch and return objects from a database. There's no ACL, no transformation, nothing fancy going on. But it's an important endpoint, so we need to monitor it. We want logs, and we want metrics, and we want traces. Let's say our database client is tracing a where. How might we instrument this code to get all of that? If you want all three, you'll end up with something like this. So first, we set up a trace for the stuff. Then we actually do the database call. Then we report the thing that we did, and we track the status. Then we log the thing that we did, or the thing that caused us to do the thing we did, and we log the query parameters. And then we set the state on the trace. Who wants to write code that looks like this? Yeah, not a single hand. I really hope not. This is incredibly boring. Do you know how boring this was to write? This is so boring that I almost didn't even finish putting together this slide for the talk. It's so boring that, in fact, I was looking through it and I noticed there's actually a typo. The object, it doesn't get assigned anywhere. But I just couldn't be bothered to go back and fix it a second time around. I was like, no, it's all right. This is just an example. That's how boring this is. And it's for a slide demonstrating how tedious this is. So there's no way that we can expect developers to go through this whole song and dance every single place in their code anytime they do absolutely anything that might break, which means absolutely anything, just in the vague hopes that that data might be useful at 3 in the morning. So at most, what we can hope is that developers remember to write one line to instrument their code for observability. And even that's not enough, because if they have to sit and think about which one is going to be useful, then we failed them. We can't have them thinking, well, all right, this request, I need to emit a metric, because I need to monitor this, and I need to know the success. So, okay, I'll tag that. And, oh, it could be helpful to know the country, so we'll put that there. And also the IP address. So, oh, wait, nope, the cardinality, that's going to be too high, so I guess we'll just have to put a log. No, if they've gone through that whole process, they've long forgotten about it. They're not instrumenting it at all. And that's because we have failed to design a system that's architected for observability. So let's think, why is it that these three are separate libraries in the first place? Well, they're separate libraries because the data is actually going to 3 different places. And it's going to 3 different places because the storage and the query infrastructure is radically different for each of them. And it's different because of performance. Because the performance requirements for efficiently emitting, storing, and then querying those types of data are completely different. StatsD or Graphite, it's not capable of handling the kind of load that we need to send it if we wanted to give it our log volume. But Elasticsearch, it's not set up to index data the way that we need in order to get request level traces out of it. And even if you're using a product that combines 2 or more of these in a single interface, like the way Grafana will allow you to see both metrics and tracing products, they still have different backends that are powering all of this. But we're engineers. we know that implementation details should never dictate the interface that we use to interact with something. If we do, then that's a recipe for bad usability, which we just saw a couple slides ago. So let's look at the high level. I mean, there are 3 particles of data that we're sending. We're sending logs and metrics and traces. But if you squint, they're really not all that different, are they? Like, we could literally emit all of our log lines as statsd metrics, just using the log text as the metric name. And when we structure our logs, we're just creating key value pairs, and that's essentially what metric tags are in the first place. So if we didn't have to worry about the performance requirements of it, the load, the data itself is actually shaped the same way. And traces are also pretty similar to metrics as well. The difference in traces is how we expect to be able to aggregate them. With traces, we're adding a few special fields as our tags. We're adding the span ID, the trace ID, the parent ID, and we want to be able to do an inner join on individual spans, individual metrics that we're emitting. And that's not something that statsd is capable of. Like statsd, it treats metrics anonymously. It does the aggregation in bulk. But again, the data itself is pretty much shaped that way. The difference is just how we handle it downstream, how we're aggregating it, or how we're interacting with it at a performance level. So what if we then just had a single interface for emitting all of these types of data, and we could then decide later on how we wanted to handle and represent them? So this here is my I want a pony slide. And I was so happy, by the way, because when I looked for images of ponies online that were freely available, the first thing I saw had 3 ponies on it. And it's perfect, because I don't just want 1 pony. I want 3. I want metrics, I want traces, and I want logs. I want all 3 of these. Well, it turns out we can do this, because at Stripe, we're in the business of making simple, unified APIs across legacy systems. And we're in control of our data ingress. So we can have an intelligent pipeline that operates on that full fire hose of data. So from our service, we just have to then emit a single particle of data, and that particle contains the union of all of the information necessary to construct a trace or a metric or a log line. And at Stripe, we've dubbed this the SSF, the standard sensor format. So then all we would have to do is make it easy and convenient for the developer to emit all of that information, that particle, with one short line. And then our pipeline determines how best to aggregate and synthesize that particle. So you might wonder, like, what might this look like? Well, this is just an example. It'll look different in different languages, but hypothetically, this is what we could do. You'll notice, I mean, I don't even remember how many lines we had in the previous slide to instrument it, but we've collapsed that all now into one single call, one single function, and it's a pretty easy one to write. We've combined the metric name and the log name because they serve basically the same purpose. And before, we tagged the success status on the metric, and we logged the query parameters. So we sent them to different places. But here, we're putting all of that in the same piece of information. And we know that our pipeline is going to figure out how to split that up and handle it downstream. So Veneur will take a stream of these SSF particles, and it decides not just where to route the particles, but actually what to make out of them and how to do it. Each particle here contains the full amount of information, but each icon represents what Veneur might use it to build. You might just barely be able to see that red line there. So like this one, Veneur, it sees that particle and it turns it into both a log and a metric. They both get emitted and sent downstream. And this one here, well, Veneur started doing the same thing as well, but creating both a log and a metric. But then it noticed that, nope, the cardinality on that is going to get too high. So it dropped the metric and it just sent the log, a log line downstream. And then here it sent a log and a trace instead. You can imagine, it might send a trace and a metric or just a trace span. And then these 3 are kind of interesting, right? Well, Veneur is going to look at each of those, and it's going to create a log line and a metric for each of those individually. But then it also notices that they're actually shaped pretty similarly, and there's some more information that we can glean out of this. So it will actually extract that and pull that into a histogram, which is yet one other piece of data that also gets sent downstream to our tools from these particles. So the key thing here is that we're not going to send, our full log data to Datadog, for example. But, let's see. Yeah, we're not going to send like our full log data to Datadog, but we know which SSF particles were used to build that histogram because we were the ones building it. We're doing that ourselves in the pipeline. So if we want, we can record that relationship. And that allows us to integrate our monitoring tools more effectively, however we want. And that's the crux of it. Veneur isn't a replacement for any of these tools. Veneur is a pipeline that lets you integrate and leverage your tools better together. Veneur uses the SSF particles to build the data that tools like Zipkin or Open Tracing, Grafana, Elasticsearch, and all those tools will then present in a usable form to developers who need to operate and run the code. So the developer who writes the code no longer has to decide at the time they're writing it how they think that they will want that information represented ultimately later on when they get paged. They just have to make the decision to instrument their code in the first place, and then the pipeline will do the heavy lifting for them. So let's see some examples of what it looks like and what we mean when you say that we can leverage these tools better. Well, when processing data, just in general, we always have a trade-off we have to think about between accuracy, precision, and performance. And we can't get rid of the need for that trade-off. It's always going to exist. But we can ensure that that trade-off will work in our favor at each step. You can think of it like going to Vegas. Like, the house isn't going to win on every single hand, every single spin of the wheel, but ultimately, the house is going to get what they need. And aggregation is a good example of this. So like, let's say we're analyzing API latency. We can't just send and store everything. Like, we're not going to send and store the latency associated with every single request because aside from the load that that would cause in our systems, it's not useful. As a developer, you can't look at all of those pieces of data individually and make any reasonable decisions about it. So we use aggregates. We'll use something like the average or the median or the maximum. And those statistics will capture some of the qualities of the data, but it's lossy. If you know those exact statistics, you can't reconstruct the full data set, but you have an idea of the general shape. You have maybe what you need. Or another example, we might want to count the number of unique IP addresses that are logging in during a particular interval. So and we might not just want to do that during discrete and mutually exclusive intervals, but we might want to say like these 10 seconds and these 10 seconds and these 10 seconds, but then also this minute and also this entire hour. And if we want to be able to stack it like that, we don't want to use potentially unbounded memory to hold all of that. So even if we have a trade-off, though, the point of an intelligent pipeline is that we can stack the deck in our favor. We can make that trade-off at a point where we have the information available to us, and we can ensure that if we're ever going to, we have to drop some of that data, we can ensure that we're only ever dropping parts of the data that we don't need. So let's see an example of how that works in practice. Well, for starters, if our monitoring pipeline goes down, you're hosed. I mean, if your monitoring pipeline goes down, you can't see anything into your systems. So our pipeline needs to be highly available. And to do this, we use an architecture that's distributed, but also one that's tiered to manage the trade-offs there. So to start off with, we run Veneur on every single box in our fleet, and that gives us a nice property. It means that as long as the box itself is up and running, any services that are running on that host, they can report metrics, and those get sent directly downstream to our many. I drew one here, but there ultimately be actually multiple downstream tools. But that gives us an aggregation problem because if we want something like the maximum latency, that's easy. We can calculate the maximum on each box individually, and then look at all those maximums and take the maximum of that. But we can't do that with all aggregates. Not all aggregates work that way. For example, medians or any percentiles. We can't combine medians. They're not monoids. There's no mathematical operation that will take the median of 50 different subsets of the data and then give you the full global median afterwards. It's just not mathematically possible. So we'd have to keep all of the full data set and still send that to a single global aggregator box. And that defeats the whole point because we've now introduced a single point of failure, and we've also reintroduced the load problem where we're actually sending all of our metrics still to a single aggregator, even through these even through these multiple sources. To give you an example, like way back, we tried this with Graphite. This is before we even had Veneer. And we just sent heartbeat metrics from every box we had to a central Graphite instance. And we found that we could drop anywhere from 30 to 50% of those metrics on the floor, the heartbeats, just because the load was so high and Graphite couldn't handle that. So we need something that will actually properly horizontally scale. So instead of doing that, we use a ring buffer and we consistently hash our metrics when we aggregate them. So let's say host 1, it emits red, blue, green, or red, blue, purple, and green metrics. It will always send the red metric to the first box, first aggregator box, the blue one to the second, and so on. But we consistently hash it. So all the other hosts will also send the red metrics always to that first box. And they don't need to communicate with each other and coordinate beforehand which box they're going to send it to. We use a consistent hashing scheme, and it happens for us automatically. And this gets us the best of both worlds, because now if any one of those aggregator boxes goes offline, well, that's fine. I mean, we'll lose 1 in n of our aggregates, but we won't lose all of them. The other boxes will still continue reporting aggregates and sending them downstream. And in fact, we'll only lose then the aggregated data, because remember, these hosts also have the ability to send non-aggregate data downstream to tools as well when appropriate. And so we'll still preserve those, and we don't lose it forever, because even if we don't immediately spin up a new box to replace it, well, these hosts, they now know that they only need to consistently hash across 3 hosts instead of 4, and they'll still use the same scheme to communicate, and they will still send all the data for each particular metric to the same place to be aggregated. So now, my background's actually as a statistician, so this is the part that I could easily talk about for like an hour. If you want the full picture, come find me at the breaks, and I'll tell you all about this in much more detail. But I just want to give you a taste of what it means when we say managing those trade-offs in a statistical sense. So I did say a moment ago that there is no mathematical operation that will let you take medians of medians in a mathematically valid way. And that is true if you're dealing with exact operations. But we don't have to. We could use an approximation as long as we're confident that this probabilistic algorithm will have the properties that we need. And t-digests really fit the bill for us here. T-digests are a great way for us to recursively calculate probabilistic approximate percentiles in an online fashion. So we can calculate our percentiles in an approximated way on each host locally, and then send those approximations downstream, and we could then run the t-digest algorithm again on those percentiles, and it is actually mathematically valid. Again, it's an approximation, but as long as it has the properties we need, we're fine with that. And it turns out they do. Because the way that t-digests work is they trade off variance in the center of the distributions for precision at the tails. So in this case, the variance on the median of any metric is actually relatively large. It's not actually huge, but it's much larger. But on the 99th percentile or even the 99.9th percentile, it's tiny. In fact, by the time you get all the way out to the 99.9th percentile, you might be dealing with the exact value right there. And that's what we care about, because as long as the variance in the median is bounded by the stuff in the tails, those are the ones we care about. We care about the requests that are slow, that are problematic, the ones that we actually need to look at and piece apart individually. So it's not about getting rid of and eliminating these trade-offs entirely. It's about making those trade-offs work for us and making those decisions in a more dynamic and customizable way. So once the pipeline is intelligent, we now just need to build our interfaces to work with all of this. And what does that look like? Well, you can help us figure that out. We have some ideas, and we've started building some of it, but there's a whole lot left to be done, both with the pipeline and with the downstream tools. So now that we've defined the subatomic particles and we've contained them in the SSF, our grand unified monitoring particle, we can build the monitoring universe that we want to see. So let's go back to the story at the beginning. It's 3:07 in the morning, you just got paged. You're still not thrilled about being woken up, but that's okay. You know that your systems have an intelligent metrics pipeline, and that will do the heavy lifting for you. You pull up your dashboard. You notice that API requests have dipped below a threshold. Okay, fine. But you have context there. You could actually pick apart some of those individual requests because, in a way that is connected back to the corresponding trace spans or log lines, and you can see the individual status codes. You can see, yes, there are actually some requests that are giving us 500s, and you can look at the relevant pieces of data. It will pull apart for you a histogram. You can look at the latency. All right, the latency is fine. Latency is definitely not an issue, but you notice something else interesting, another part that it highlights, and that's the IP addresses. Now, it doesn't keep track of all the IP addresses for you. The IPv4 address space is way too high, but all we need is the /24 subnet, and that is actually a manageable space for our tools to handle. And there, we notice that all the failing requests come from the same 3 subnets. And then you realize that this traces back to a configuration change that was rolled out earlier in the day that only affects one certain data center. So all you have to do is flip the switch and you're good to go. So you got paged at 309. By 308, you figured out the problem, and by 309, it's fixed, and you're back asleep, dreaming about this better monitoring universe. So in 2018, I want to come back to Monitorama and hear a whole slew of talks with people excited about the things that they are building using their intelligent metric pipelines, the things that this enables them to do, the ways that intelligent metric pipelines let them integrate tools together the way they couldn't before, or the way that intelligent metric pipelines let them record relationships between their monitoring data that previously they had no way of structuring, or the way that intelligent metric pipelines make it easier for developers to write and instrument observable systems in the first place. So let's do that. Let's make intelligent metric pipelines like Veneur the gold standard of monitoring, both at your company and across the industry, for companies of all sizes. Thank you. Thanks.
All right, and up next we have Julia Evans.
Hello! All right, so I'm Julia, and today we're going to talk about one of my favorite things, which is debugging tools. I was thinking a while ago about how I got better at debugging, because I was like, I used to find debugging really hard and boring, and now I find it interesting, and also I think I can solve harder bugs. And I wanted to, and I was like, okay, how did I get better at this, right? Like, what happened? So some things that happened include, I think I got, oh wow, this is exciting. Great. Oh, I know how to debug this. Or I have debugged this before. Okay, I think that's it. By which I mean my audience has helped me debug it before. So one thing that helps is remembering that your bug is happening for a logical reason, even if it seems to make more sense. Someone at lunch told me about a bug that was happening because of solar flares, which is very surprising but still logical, right? So even if things have no obvious external cause. Anyway, there's still reasons. Another thing that's helped me is to be more confident that I can fix my bugs. Sometimes I'll spend 3 weeks debugging something, and I'll be like, I really hope I fix this, because if I don't, it'll be kind of embarrassing. And I think these days it's easier for me to be confident, because I'm like, well, I fixed a bunch of hard bugs, so I can probably make it through this one too, even if I have no idea what's happening right now. But the two most important things, I think, have been to know my debugging toolkit and be able to answer the questions that I have about my programs, right? I'm like, okay, is this a problem with this server, or is it a problem with that server? Or is this a problem just in Go, or is it also a program in other programming languages? And I've gotten a lot better at that over time, and I feel like it's making a really big difference to my ability to debug software, and that's what I'm here to talk about today. The other thing that has helped me is I really like debugging now, but I'm not sure I can convince you to like it, although I might try. All right, so the scenario we're going to work on here is that you log into a computer and something has maybe gone terribly wrong, right? So it's exploding, or what's happening? to this program right now. Usually for me, it is actually more like 3 p.m. and 3 a.m. when I'm debugging, which is good. You can be less upset and more excited. So when I started out debugging programs, I would often do things like maybe try to read the code, or I'd like print statements, and like I thought it was maybe important to know the programming language, and I like don't believe in this as much anymore. I found some alternative methods, which I really enjoy, and we're going to talk about some like wizard tools. But like wizard tools are not really a thing. I just told you that like computers aren't magic and we use logic. So by wizardry, I mean like asking your operating systems what your programs are doing, right? So instead of being like, I'm going to use like a Python debugger, you're like, yo, what file was my program opening? And the operating system is like, it was the wrong file. And you kind of just get the operating system to like tell on the program, right? You'd be like, yo, what's it doing really though? And the operating system will generally tell you the truth, unlike your program, which might like lie to you because like you wrote it, right? All right, so we're gonna solve 3 mysteries because I like mysteries. And we're gonna have the case of the missing configuration file, the case of the slow program, and the case of the French website, because I'm from Quebec, and we do bonjour. And then we might have more time for more cool stuff, we'll see. So we're gonna start out with the case of the mystery configuration file. Does this happen to you? Where you like write a configuration file, and then you start your program, and it's like, oh, no, didn't work. So I frequently like might edit the wrong file. This is partly because I don't always like reading documentation, so I'll just like try a file that seems right. But like I didn't want to fix this problem necessarily by reading documentation, because why would you do that? I wanted to show you how to figure out the configuration for a program without reading the documentation. So we're going to use the example of bash, right? It's like, does bash use like .bashrc or .bash profile when it starts? And you can figure this out by reading Stack Overflow, the documentation or something, but we're not going to do that. We're going to use strace, which is my favorite program. I have an strace sticker on my phone. So what strace is it traces system calls. So system calls were like this really big revelation to me a long time ago. A few years ago, when I started learning about operating systems, and what system calls are like kind of the API for your operating system, right? So when every time any program opens a file, it's like, please, can you open this file? And your operating system will be like, yes, here it is. And your program is like, please read these bytes from it. And the operating system is like, yes, here they are. Or sometimes there'll be an error, but hopefully you handle those errors too. So strace output is very exciting. It kind of looks like this. At first I used to find this kind of intimidating, but I've gotten better at not finding it so intimidating. Oh wow, this is exciting. Okay, cool. So what we're going to do, what we're going to do is we're going to figure out what configuration file bash uses by stracing it. We're going to run strace -f-e open -o out. Oops. Okay. And then we're going to find things that mention bash in the name. And we're going to find all the files. Okay, cool. So there were a bunch of files that it opened. It opened .bash history, it opened .bashrc, and it opened some weird files to do with TensorFlow completions. Cool. So I think this is awesome because it's like, it opened .bashrc. And then that's it. I know that it didn't open the bash profile file at all, so it can't have been using that to configure itself. Otherwise it would have opened it. And I didn't need to read the bash source code or documentation at all. So we won. Something to know about strace is it can make your programs run 50 times slower, so you shouldn't run it on your production databases. You shouldn't. But I like it, well, at least for like safe programs. It's good to run on programs which are already broken because you can't really make them that much worse. That's one of my favorite places to run it. But it's a good way to just be like, what is this program even doing, right? Like, what's happening? So you can check to see if it's like reading a file or making network requests or like waiting for a mutex. I had a fun time once where someone was like, Julia, I have a bug in an Erlang program. And I was like, I don't know what Erlang is. But I just like S-traced it. And I was like, there's a lot of mutex stuff going on. Maybe it's waiting on a lock. And he was like, oh yeah, that's totally it. And I still don't know Erlang. But I was like able to help. Just by running strace, and I felt really proud of myself. You can also check to see if it's writing logs. I wrote a zine about strace, which we'll go into later. But there are also some faster system call tracing tools, which I've been using more recently. My favorite one of these is perftrace, because it's like generally available on Linux. Recently, I had a weird like Docker issue where Docker PS was taking forever, and I ran perftrace, and I was like, oh, Docker is opening 200,000 files. Cool. I guess that's why like it's kind of slow. And it turns out that if you ask it for the size of to measure the size of your containers, it does that by running stat on all the files and then adding all those up, which like takes a second. Yeah. And then there's also dtrust on OS X, and there are some eBPF-based tools like OpenSnoop on Linux. And I'm pretty into these tools. Perftrace like doesn't give you as much information as strace does, but it won't slow down your programs, which is very exciting to me. Okay, we're gonna solve another mystery, which is the case of the slow program. Also the case of the projector. We're gonna try this again. Cool. I think what I'm learning here is I should have screwed in my VGA cable. Okay, cool. Great. Okay, so we're gonna have 3 slow programs. One of them is slow because it's just like spending too much time on the CPU. One of them is slow because it's writing too much to disk, and one of them is slow because it's waiting for a slow server. And we're gonna debug all of them without like reading their code or anything. And it'll be really exciting. So the first one, mystery program number 1, I ran time on it to start. Time is a cool thing because it'll tell you like how much of the time when you ran that program it spent on the CPU. So this one spent 5% of its time on the CPU. And what that means is that the other 95% of the time was spent like waiting for something, right? Because if you're not calculating, you're like chilling and being like, okay. So like, what was it waiting for? Exciting question. So let's find out. We're going to look into the kernel soul because often when a program is waiting, it's waiting for the operating system to do something. So we'll just be like, okay, what you doing? What's up, Linux? So we're going to run Python mystery1.py. Cool. And -f. Cool. So I found its PID. And we're going to look in /proc, which is this magical directory, which has all kinds of interesting information about the program, like the command line that it, oops. Nope. Anyway, we're going to look at stack. So this is what? Oh, I wrote it twice. Okay, cool. So this is the kernel stack right now for that program. So what is this program doing? Someone whispered, waiting for a network. It's waiting for a network reply, right? And this is kind of cool. We just can like see what this program is doing. And it's a Python program, right? It's not like a fancy systems program, just a regular Python program, but we can see what it's doing. And so I'm like, sounds like networking to me. Now I know what's happening. And so I think it's cool that like you don't need to be a kernel hacker to read a kernel stack trace. You can just look at it and be like, oh yeah, I know what that means. Sweet. So we won. We solved that mystery. It was the network. And this is what the program is secretly doing behind the scenes. It's just like, I'm going to wait forever before returning. Then next up, there's the mystery program number 2. And this is a Ruby program. And it's using like 93% CPU. And last time I gave this talk, I just kind of ended this with like, just like use a Ruby profiler. The operating system doesn't have anything to say about this. But this time I was like, no, maybe the operating system has something to say about this. So we can actually find out And we're going to use my other favorite program. I have a number of favorite programs. My second favorite program called perftop. Called perf, and the top subcommand of perf. So perftop is a fun thing to run. It's kind of like, so top tells you like which programs are taking all the CPU on your computer, and perftop tells you like what C functions are taking all the CPU on your computer. So I like to kind of like run top, and then if something is taking a lot of CPU, I'll just like run perftop and then see what happens, and if it tells me anything useful. And it turns out that with this program, it does. RBNV. Okay, so I'm gonna run this program a bunch of times, and then we're gonna run perftop and see if it tells us anything useful. Okay, so these are the programs. You can see there's some things like libcomposite.so composite window. I don't know what that is. It's like probably related to Chrome somehow. But the thing at the top here is forward search range from Ruby. So like, what could that be, right? So we can like go to our Ruby source code of the Ruby interpreter and see what we find. And we're like, oh, that's somewhere in the regular expression code. So like the reason this is useful is that like it won't tell you like what Ruby function is being run, but it will show you like where it is in the Ruby interpreter, which is normally not useful, but in this case it is useful. And like the other day I like SSH into a machine and it was like using a bajillion CPU and it was in like a regular expression function, and then I could just tell that was happening within 10 seconds, which was useful. So we kind of like know something about what's going on already, and we just had to run one command, which is exciting to me. So we blame regular expressions. Don't do it. Cool. Mystery program number 3. If you remember the 3 things from the beginning, you could guess what it is by process of elimination. I have bad memory. So this one is using 94% CPU. And you might be like, okay, this is the same as before. This is just using a lot of CPU. It's not like interacting with the operating system at all, right? But, however, you see where it says like user mode and system mode? So it's actually, there's a ton of CPU, but it's all in the kernel. What's up with that? What are you doing, program? Why are you making, what is the kernel calculating, right? So I'm going to start out by telling you about dstat, because I happen to know what this program does, surprise. Okay, so Python mystery 3. And we're going to run dstat, because I love dstat a lot. Whoa. Okay, cool. And then we're going to run our program. So dstat, what it does is it just like prints out everything that's happening, like all the CPU and disk and network activity every second, which is kind of fun to like stare at if you have a computer which is like misbehaving, and then you're like, I see that spike in writes. What was that? I mean, it's kind of like looking at a graph, but I guess on the command line. So if we run our mystery3.py program, you can see that suddenly like a lot of writes appear in the writes column, and it's like, I'm writing 300 megabytes to disk. And then there's a pause, actually, and then it writes a whole bunch more after the program exits, which is like, at first, like it gets written to the file system cache, and the program exits, and it's like, okay, I wrote it, no problem, but it actually hasn't been written to disk yet, and then the operating system writes it later, which is what that gap is about. Anyway, what is going on, right? Like what is all the CPU about? Because writing just normally shouldn't take that much CPU. So we're gonna run this in a loop somehow. Okay, yeah, there's our loop. And then we're gonna run perftop again, because I love it a lot. And then we start to see some stuff. Really? Why not more of that? Okay, that's fine, I guess. Oh yeah, there we go. Okay, so up here at the top, you see a thing that says AES. What does AES mean? Yay! Encryption. It's writing to my home directory. My home directory is encrypted. So it takes a lot of CPU, apparently, to write to my home directory. But it takes CPU in the kernel, right? Like it doesn't get encrypted in user space. The program is just like, I would like to write these byte to disk, and the kernel's like, oh my god, I have to encrypt them first, right? So, cool. Great. So perftop has helped us again. And my attitude towards perftop is really like, it's really not always useful, but I just like to look at it, and sometimes it helps. And kernel functions are not just for kernel hackers. Sometimes they just make sense, which is really nice. Another cool thing about perf is, so far all of the uses of perf we've seen are telling you what C function you're running. But there are actually plugins for both Node.js and for the JVM, because those are both JITted. So like you can get Node to tell perf, the perf system, like, hey, this address actually means this JavaScript function, and then you can get the perf tool to report to you what JavaScript function you're in, or like what like JVM function you're in, which I think is really cool. Okay, we have one last mystery, which is the case of the French website. So let's go solve that one. Okay, so I made a website. It says like, hello Monitorama. And if I get it from the command line instead, there we go. Instead it says, bonjour Monitorama. Comment ça va? Great. So like, why do we get different results, right? Like, why is it in English in Chrome and not in English on our command line? So we're going to find out with ngrep, which is like grep for your network, which is the best thing. And then let's see if I have this ngrep incantation somewhere. Yeah, here we go. Okay, so we're going to start just like looking for GET requests on localhost. And so we're basically just like grep get. So I'm going to run this curl command, and I'll run this chrome command. And then we have these two requests here. So you can see the curl one is first, and it's really short. And the Chrome one is second, and it's kind of like longer, right? So it kind of makes sense. You're like, okay, well, you made two different requests, and you got two different responses. That's reasonable. But then down here, if you kind of look at the headers, you're like, oh, there's an accept language header, where it says accept language ENUS. Cool. Maybe that's related, right? To the language that we got the content in. So because Chrome asked for an English website and curl did not ask for an English website. So we can just like try that. And then it's in English instead of being, instead of being in French, which is exciting to me. Cool. Now we're going to see how much time we have left. Cool. We have like 9 minutes. Great. So we're going to talk a little bit more about we're going to talk a little bit about TCP dump, because when I started giving this talk, I would talk about ngrep, and I'd be like, ngrep is great, but TCP dump is really scary, and we're not going to talk about that. But now I love TCP dump, kind of, and so we're going to talk about TCP dump. So I had a problem at work recently where someone was like, hey, there are some DNS queries that are like intermittently failing in this weird way. And it was at a pretty slow rate, like maybe like 5 an hour. So it wasn't really an emergency, but also like we wanted to know what was going on, especially because we'd had a DNS issue in the past. So we're like, okay, we should figure this out. And we had a few different like layers of DNS servers, and it wasn't really clear who to blame. And I was confused about this for a while, right? And there are all these questions like, so we're in AWS, so we're like, is it just a problem in one AZ, or is this a problem with Go? Because like I think Go uses its own DNS library, and like a lot of the problems we were seeing were with like Go clients, or like is this like a weird ARP table problem that we've had before? And so there are all these different theories, right? That we were trying to work out, and it's kind of I think natural to be like. Or like one thing I used to do is like try to like find the smartest person, the most experienced, and be like, which one is it? But this strategy like does not work, right? For a few reasons. One is that the smartest person is like often not like there. Also, like just because they're really smart doesn't mean that they magically know the answer to your DNS problems. And it's like much better to rely on like facts, right? Instead of like just being like, I magically saw this before, so I know the answer. And so no one knew the answer, as is expected, right? As often happens. So at some point, after kind of like thinking about this, I was like, oh, I know what I'm gonna do. And these errors are really infrequent. So I was like, I'll use TCP dump, which is this tool you can use to save network requests into a file, and then I'll analyze them later, right? Because there are only like maybe like 5 errors per hour, so I couldn't like catch them as they were happening. So I started TCP-dump, and we were having these weird DNS failures, which weren't just like an NX domain. It was like the DNS server had just like thrown up. So it was like, I don't even know, man. So I concocted this TCP-dump VPF filter where I was like, okay, take everything on port 53, and then this weird thing is just saying like not an NX domain and not a success, and then save those to a file. And then I let that run for like 12 hours. And I was like, okay, if I have this data, I'll know like everything that happened in the whole system, right? Because I just like ran it on a couple of different DNS servers, and I'll like, I'll know everything. So I'll be able to like confirm or deny all my hypotheses, which was really true. And then I woke up in the morning the next day, and I was like, oh boy, I have packets to analyze. This is so exciting. And it was really cool because it let me like immediately see who I could blame. And this is like, I think the really wonderful thing about like packet analysis and like networking is you have like the clients and the servers, and you can like really easily be like, you sent the bad request, or you were wrong. And then after I did that, I was able to like pretty quickly see that like we had some like upstream DNS requests to an external server, and that those were timing out. And I was like, oh, that was what went wrong. And then we could fix it. And it was all thanks to the power of TCP-dump. And I was really happy. Cool. So maybe, and also shout out to Wireshark, because reading, like, using TCP-dump to like capture packets is pretty great, but often like looking at packets with TCP-dump is not great. And Wireshark is like this like graphical tool where you can just kind of like click on things and be like, oh, okay. Like, that's weird. So yeah, guessing the answer magically is hard, which is I think what this conference is all about. Tools can help you answer the questions without having necessarily seen the exact thing before. And you can learn these tools. Some of you might have seen that I left some zines outside, which Jason very kindly agreed to print, which I was really delighted about. And my goal with some of these zines is to try to explain like the basics of what you need to know in like 16 pages. Because I had this problem where I felt like I would like go give a talk at a conference and I'd be like, here's the stuff. And then someone would come up to me and be like, what was the thing you mentioned again? I'm like, no, I need a way to give it to you so that you can go read it on the bus and remember what I wanted you to know about TCP-dump. So I started writing a few little zines. I started with strace because strace is my favorite program. And I wrote like a little zine which is like, here's how you use strace to solve your problems. And I made one about computer networking because I was really confused about computer networking for so many years. And I made one about TCP-dump just recently, like last month. I have a few with me, /outside, because I didn't know like what command line options to use, and I thought TCP-dump was terrifying, but it's not. It's fine. It's not that big of a deal. And I have some of the things that I talked about in this talk in this zine called Linux Debugging Tools You'll Love, which there are a few hundred of outside. I hope that you learned something. I have a blog and I wrote some more zines there. That's all.
Word. All right, we have 2 quick sponsor talks and then some more talks. Yeah, okay. So please, a round of applause for the next sponsor, who I am blanking on. Wavefront.
Thanks. All right. Are we good? Oh, lovely. Gotta love it when you plug in a new HDMI and it doesn't mirror your stuff. All right, I'm just going to do this off that screen. My name is Pierre Tessier. I'm with Wavefront. Many of you may not know who Wavefront is. We are a full stack metrics monitoring and correlation system for obviously all your metrics monitoring needs. But we're a little different than the other tools out there in the market. We are based on a really very powerful query language inspired by Twitter's Viz, if anybody familiar with what that system is. We have a great UI around it, which allows you to use this query language to its max potential as well. Our alerting system is also based on this exact same query language. It's not a separate black box, it's not something else. Again, inspired by Twitter's Viz. It allows you to really fine tune, so what you can see on the screen is also what you will alert and get notified upon as needed. We'll never roll up your data. And I do mean we'll never roll up your data. You send me data for 10-second resolution, you have that 10-second resolution 3 years later. And we actually have customers who have done that. We're also hyperscale capable. With each release, we test to be able to ingest at well over 4 million data points per second. Why 4 million? Because we just didn't feel like throwing more hardware to generate more data. And on the query side, we could also query at that same performance rate as well. It's very important for us to do that because we do have some customers who actually have this kind of scale, as we'll see later on. When it comes to the tooling to use around our products, we don't really force you down a path either. We embrace the open source community. We embrace what these people in this room have done. You've probably started on a Graphite Grafana stack, or maybe you started using something like maybe Senzu, or maybe you're on Collecti, or Telegraph for getting your metrics into the system. We don't necessarily have a direct agent. But if you do need an agent, we will provide you one, which is Telegraph, with our output driver built in. So, it's whatever you want to use, we'll be able to work with that data pipeline. And behind all this, everything you could do in our platform is backed by a very comprehensive and well-documented API. And it's with this API that we've been able to build some really cool extensions that some of our customers have used. Earlier this morning, we've seen a talk about using R to do some advanced statistical analysis. Well, we have an R plugin, which will bring those data frames down for you to do whatever you need to do with it thereafter. And we've also worked with one of our customers, and we co-developed a Grafana plugin to be able to allow you to do more and visualize the data the way that you are used to visualizing it. So you don't have to use our UI, you can use what you're ready to use with. Okay? So let me show you a little bit here. So this is a Grafana dashboard. And I'm going to go ahead and play with this chart right here and show you guys a little bit of the query language. So what I got here is transactions are following. Now traditional tools, they will tell you this. That tells you the what. What they don't tell you is the why. And that's one thing that's unique to Wavefront that we can do with our query language. We can help you answer those whys. So I've got a bunch of transactions coming in, or I got some transactions coming in, and it's affecting one machine. And this is all the data I have for that machine. So I know this line is going down, and I've got all this, and I need to figure out what to do with this gobbledygook of stuff, and tell me why. Well, I've got that query written down here. It's a moving correlation, and when I do that, I'm going to correlate all that gobbledygook up against that top line and come back with, it's your garbage collection. Fix your code. Okay, so that's the power of Wavefront. Now I'm going to continue on, and I'll show you guys a little bit about our UI itself. So this is our UI. It looks a little bit like Grafana. It might be familiar to you. You'll notice we lazy load all the charts. They're very snappy, very quick, even with the slow Wi-Fi here. And no, actually the Wi-Fi is fine. But so, very traditional kind of system. I'm going to go ahead and just kind of zoom in on that line right there. I'm going to go ahead, I'm going to click on this purple line right there, and everybody's got it all highlighted. And in the bottom right-hand corner, I'm going to click on this little link icon. I got a link. It's good for Slack. It's good for HipChat, whatever you want to do. It's good forever as well. And you don't get an image. You get a fully functional dashboard, pre-zoomed into this time window, pre-selected for those sources. So even if you're working with your team across the country in different time zones, you don't need to worry about it. You could all be rest assured you can be looking at the exact same thing when it's crisis mode, when you don't have time to worry about it. Now we've talked about our alerting system, and that is very important to our platform because it is based on the exact same query language. But more so, when you create alerts, we're going to backtest them for you. We're going to tell you how noisy these alerts are. So here I've got an alert which is based on a standard deviation of request latency across a pool of 40 machines. And here I'm looking if the deviations are ever over 2.5, and maybe a little noisy here. So let's change this guy to maybe be 2.7 instead. And we'll come back and we'll just see how a little less noisy. You probably don't want to create this either. You're going to have people leaving the organization for alert fatigue. But we keep on bumping it up, and surely nothing's going to be over 230 because I fat-fingered it. But you get the idea, right? So we use this exact same query language that we did to try to find the correlation. We could find standard deviations. We could do interquartile ranges, all these cool statistical things. But really, we bring the power to you so that you can do what you need to do. Now, we have a lot of customers that use our platform. And if you know anybody at these companies, ask them about us because they love us. That's something we consistently hear over and over again with every customer who gets on our platform. And even this quote here that from a meeting that we had with Lyft, and I think Lyft, Jan is going to be giving a talk later on. I don't know if he's going to talk about us, but definitely go check out his talk. He's a good dude. He's not the one who said this quote, but if you're using Grafana, you owe it to yourself to try Wavefront as the back end. And we're really serious about that. His team helped us develop that plugin I showed you a few minutes ago, but we also have other great customers like Groupon, Box, Workday's here as well. I think Calvin from Inuit's here. Definitely talk to them if you know them. Sorry. So that's Wavefront. Definitely check us out, wavefront.com. We'll get you hooked up with a free trial. Hit us on Twitter, Wavefront HQ. But if you don't want to get bothered with sales and marketing, I'm Pierre Tessier, also known as Puck Puck, on Twitter or the Slack Monitorama channel. Hit me up and I'll bore you guys. I won't bore you guys with the sales and marketing stuff. Thank you.
And one more sponsor. I'm blanking again. Circonus, yay.
Hey guys. Boop. Just like all the other vendors, so I'm going to get up here and tell you why Circonus is different than all the other monitoring vendors that you've heard from so far. We all have the same basic feature set, right? Data collection, broken displays, visualization, alerting, etc. We're different for a couple of specific reasons, sort of scale, availability, resilience of our platform. Histogram native, it's good to see that our friends at Wavefront released histograms as a feature last week. It's only 7 years later, our analytics platform is bar none, and we do this either on your premise or in SaaS if you don't want to manage your monitoring infrastructure. So I'd like to poll the audience for a second and figure out how big of a monitoring problem you have. If you don't mind, I asked the same question at GrafanaCon, and I was surprised that people don't really collect that many metrics. But how many people here collect 50 million time series? Wow, surprising number. How many collect 100 million? How many collect 300 million? Wow, you got to talk to me after the thing. Cool. There's a couple. That's surprising. It's very rare for me to see someone collect over 10 million time series generally. That's a huge metrics infrastructure, right? So we just signed a deal with AppNexus where we're replacing their graphite infrastructure internally because it became untenable. And their particular footprint is 310 million metrics collected minutely. We can also do billions of measurements per second. This is because we're histogram native. You can decide to collect the latency on every operation that happens on every portion of your stack and store it all in Circonus and get it back out. And this is incredibly powerful going forward because you can actually analyze this data in a useful way because we store the complete distribution. So on the availability side, everything that we do internally at Circonus is backed by IronDB, which is the database that we wrote internally. We also have released it as a standalone platform if you need a time series database to do some cool stuff. It's replicated sort of like Cassandra. You can lose n-1 nodes. You can actually perform maintenance on your database and not lose any visibility on the read or write side to your data. And you can avoid the graphite problem, which people have now, which is where they run 2 copies of their infrastructure. Also, our broker is store and forward, right? So whenever you run our broker inside your own infrastructure or we run it for you, we actually persist every metric that we see to disk before we forward it on so that if there's any network outage or any loss at all, we don't lose data. I talked about this before, but I think it's important to remember that you can't, what was the quote from earlier today? Repeat after me, you can't aggregate percentiles, right? The line on the bottom here, the very, very bottom line, is an aggregated percentile, right? The line at the top is the real measurement because it's an aggregation of the histogram of the full distribution of the data. And you can see how far apart they are. On the bottom, you're looking at 3%. At the top, the real measurement at that time was 13 or 14%, right? They're completely different things. So if you're monitoring data as the aggregation of percentiles, please stop. If you learn nothing else from me today, don't do that. The other thing you can do is avoid spike erosion in general, even outside of aggregating your percentiles. So we do this really cool analytic stuff, find outliers based on historical trends, right? So this particular graph goes and fetches week over week comparisons, builds a histogram out of it, and then overlays an anomaly detection, an outlier score on top, and it pops out immediately what has changed, right? We can also do this automatically on clusters of your metrics. So you can define a set of metrics and say, go find me outliers and draw me a graph, and there it is. You can also do really, really sort of powerful stuff like rolling means, and anything you can think of mathematically that could be applied to your time series could be done. It's way too much to demonstrate, so I just have a few examples up here. We also provide you the option, unlike a lot of vendors, of doing it yourself. If you don't want someone else to own your monitoring data and you want to bring it inside your own environment, we provide you a database to do that. We provide you the full stack to do that if you want to do that, or we'll manage it for you. It's whatever you want. And I would say if you're looking at a monitoring vendor, I would ask these questions before you make a decision, because they're actually really important. And that's it. You can web. We're up on the second floor. If you have any questions for me, I'm happy to talk about it. I really want to talk to you guys about your scale, because that sounds interesting. Thank you.
And one more talk before the break. I'd like to bring to the stage Guy Serino.
Hello. It's the little things from me. All right. Wow, there's a step. How you guys doing? Good, good. Yeah, sweet. I saw there's all sorts of hatred about aggregating histograms, and I'm sorry. But I have some things to say about that. About 3 years ago, actually, no, 2 years ago, 2.5-ish, I was sitting in a room of 300 engineers at Netflix, and Neil Hunt, our head of product development and all of our product, made the mistake of asking us if we have any questions. And I said, oh, yeah, me. And he called on me, which is another big mistake. And I said, Neil, what do you think about Netflix regarding the part of the world where we have never been? At this time, we weren't global. And out in that part of the world, there's 3G connections, and there's cellular, and there's devices that are terrifying. They terrify me. They kept me up at night. And I said, what are we going to do to go after that world? And Neil said, well, yeah, you know, this, that, the other thing. But what you're talking about, that's at least 5 to 7 years off. It's 5 to 7 years before we can build a truly global product that really works kind of everywhere. And I said, Neil, that's great, because I would like to invite you to come to Hack Day in 3 weeks, and I will show it to you. So gauntlet taken, thrown, everyone heard it rattle in the auditorium. Like, what are you doing? Product. I said, don't worry about it, because here it is, 3G in Kazakhstan. I actually went to Kazakhstan. This has the Kazakh plates on it. This is a field in the middle of absolutely nowhere with a TV hooked up to an inverter. Turns out the Russian word for that is inverter. I had a little bit of trouble trying to order that. And Kazakh man here actually doesn't speak a word of English. And he just saw me pop this SIM card in and hook the thing up, and boom. And he goes, well, where do I buy this Netflix SIM card? And I said, well, it's a VPN. Nothing that it's coming soon. It's coming soon. We're working on it, and I want to talk today about how we do that. So I said, look, we're going to have to deal with the internet that you guys have out here and in all of the parts of the world where we did not develop our app. We developed it. We were mostly in the US, and as Roy mentioned earlier today, we even went into Canada, and we called that international, but it was not a scary step from a network perspective. And it's going to take a long time for that to start getting better as we started to get out into the edge, as we started to go out into the different parts of the world. And we saw that the global internet, it's getting faster. People are putting in better links. There's fiber going everywhere, better equipment. But it's also getting slower at the same time, because while all those links are there and these companies are doing a great job selling service, everyone starts using it. And then what do you get? Wonderful congestion and all the other wonders that you get. And so I was taking the attitude with Neil that don't wait for it. Okay, let's just go and build the thing as it stands, and let's deal with it how it's there. But in order to do that, we're going to have to build a pretty good picture of what the internet looks like. We're going to have to understand where it's really bad, where it's bad in regard to our product, and that meant logging all the things. And when you start talking about logging all the things with the global Netflix base, you're talking about a lot of traffic, which is why Adrian Cockcroft once joked that we're actually just a telemetry company. We just log stuff all day. And then occasionally there's media that comes off the CDN. But we need to log this without averages. And we need to be able to see what that distribution looks like. And we need to size it up and build a product that's going to address those markets. So, of course, two things pop up right away, right? The first is you want to go for the average. The average says, that's great, except that it doesn't really let you see what the distribution looks like. You just see where the average happens to be. And you go, well, on average, it looks all right. I don't know. And the outliers that you get in that logging are going to really heavily distort your average. So the stuff that kind of goes into the infinite bucket and takes a really long time, and the stuff that goes into the zero bucket, maybe it's a cache hit or something like that, where times are, in this case, I was logging various network measures. Sometimes I would get negative values from clients, and that would really just blow out the average when I started looking at it. So you can take another approach. You can try to sample everything. And you can say, all right, well, that's pretty good when I happen to hit the issue that I have in that sample, which I may or may not, given how I choose the sampling population. If I just sample a percentage of requests, I might miss some device behavior. If I sample across devices, I mean, there's issues there, especially when you're talking about rare events, which might just blow up the experience. Because something that's rare that happens on a network, if you're running a heavy network application like Netflix, you're running thousands of connections, while you're actually building your product. So rare things seem to be pretty frequent. And the problems aren't sort of equally probable. So instead of that, I said to myself after hearing an inspired talk that why don't we just aggregate the data? Why don't we build a massive MapReduce machine out of all of the clients that are in the world? So the TV devices, the cell phones, everything that wants to run Netflix, let's use it as part of the free compute power that I can take advantage of, as long as I don't get in the way of the user experience, and do some aggregation and send back the aggregated data. So based on that, we went and sized up the internet with all this infinite free computing power, free in the sense that you'd better not bust the app experience, but free in that you're not paying for it on AWS or whatever service you happen to be using. And this is really good because when I've got very fast metrics, so in the case of networking where I was interested in the network performance, or say key responsiveness, like when the user clicks down, how long am I waiting? These things are happening very frequently. And one of the nice side effects about my favorite aggregation technique, the histogram, big surprise, is that it's flat in memory use and it has relatively low insertion time. So I can put that data together sort of in real time. I can filter out the stuff that's not helping me, say I'm getting a bunch of zero counts or whatever, and then I can emit an aggregated log blob. And I say, look, this is what happened. So for those of you who haven't seen it, this is actually measuring curl requests going to a website that happens to be on the far side of the world. And here I'm building the histogram as I go. And I see that most of my times are actually right here, kind of in the beginning, so that this is pretty good on average, but I also start getting a whole bunch of outliers in the distribution. And for any non-trivial set of events, this is probably going to happen to you. And those outliers are really just going to pull the entire thing over. So once I've got that histogram, now I have an idea of what the shape looks like. Then I can do a little bit of not so fancy math, which sounds scarier than it is. I can take the inverse empirical cumulative distribution function of that, and I can calculate all of my percentiles. And that's done by a very simple equation. So we take f of the n to t, and then we multiply, anyway, some stuff. But you can actually just plug it into R, which will do all the work for you in 2 lines of code. And great job, John, for introducing R earlier today. And I can pop out this wonderful function, what I'm calling here the IE-CDF. So based on the histogram, I can say, I've now got a function that I can say, show me where 50 percentile is, where's my median, show me where the 95th percentile is, and this happens to be the numbers for the histogram that you just saw. Which is kind of great, except that I'm wasting all sorts of space there on a part of the graph that I'm not that interested in. I have, in my sort of flat histogram, I've got equal distribution between the buckets. So the buckets are all the same size, and that's great at sort of my area of interest. This blue dotted line is my median, and I just overlaid it for simplicity here, and the red line is my 95th percentile. And I've got a lot of resolution where I'm sort of interested, but I don't have a ton of resolution. Well, I have exactly the same amount of resolution out on my tail, which is a bit of a bummer because these requests, they're slow, but I'm not exactly interested in how slow they are. I just need to know that how many slow requests are kind of happening. So I could afford to have less resolution there if I cut that correctly. So voila, Google gave us the answer. They said, hey, you could use exponentially spaced binning. So again, still a constant binning algorithm, but here I'm putting all of my resolution in sort of the area that I want over here on the left. But as I get out to sort of the extremes, I get out and space my buckets out wider where I don't need as much exact precision about what I'm measuring. And it turns out that I get almost exactly the same 50th percentile and 95th percentile. And there's some math that was shown to you a little bit earlier about why that works. But the quick takeaway is that it's actually very cheap to compute when you're all the way out in your client, and you can measure it everywhere in the world. So I never want to hear from people, oh, we can't log that because it's moving too fast, or there's going to be too much log data for this really important thing that we need to make a decision. BS, okay? Forget it. You can absolutely log all the things. You don't need to emit one log for every network request that you make, but you can actually do it and capture all of the data in a really small chunk. And if you want to get a little fancy, you can wrap that up in a protobuf and save yourself a little bit more space. Which leads to this wonderful amount of data that you now have. And I'm a firm believer that data is better than opinions. I happen to get a lot of opinions when we're having these sorts of debates internally. And these are all actual quotes, but protect the innocent here. But the first one that really got me fired up was, well, Guy, we live in a 50 millisecond world. Does that seem strange to anyone? 50 milliseconds across the world. I mean, your first slide that I showed you, which was somewhere in China, happened to be more than 50 milliseconds on just about every single request. Better to have the data. Well, people that load up the application, they don't really mind if there's a spinner there while we're loading up all the stuff underneath. That's fine. I mean, why should we do that instead of investing in some cool feature that we happen to want to really build? Or there's no way that the client is making that many requests to our servers, which this one actually really baffles me because, I mean, you guys are a monitoring audience, and you've seen the kind of monitoring in which actually Roy gave you a little tease earlier today. You've probably seen some of our tools, and we have tons of metrics. And it baffles me they could look at all the server metrics and say, well, no, there's no way that all those requests are happening. When you just divide the number of requests there by the number of clients, and you go, come on. It stands to reason. But the moral of the story is that it doesn't really matter what you pick. Any architecture that you work with for any sort of interesting problem like this, it's going to be hard. So it helps to make it cheap in order to be able to experiment live in the wild and actually see what the real experience is. And as soon as you do that, you're going to need to aggregate all those histograms. No one's arguing? Oh, that's a surprise. The key there is actually, it's a little bit of a nuance to what I was saying earlier. It's that you don't aggregate the percentiles. You'll get yourself into a little, that's fine for estimating work, and actually it's almost always wrong. So I do actually agree with Megan on that one. But you can actually take the counts, put them together, and come up with some, without really incurring any more error if you're dealing with the same sorts of binning. And you can see kind of what happens. So in the data list dash that I've got here, this is just a view on all of that logging data that I showed earlier. Towards the top, we have requests that finish fast. This is DNS. I just picked one metric to look at. So this is how long the client takes to resolve DNS. no artificial server measures about, oh, our DNS servers answered this quick. No, I want to know when it got to Kazakhstan. Okay? I need to know on that TV how much time was blocking on DNS, because I need to architect based on that. And then as I get kind of slower, you'll notice some banding here, some different resolvers. They show a nice band sort of in the middle. That's by host. That's because we do a few redirects sometimes, some CNAMEs we might not want to do. And then down here at the bottom are sort of timeouts. Our client actually kind of kills this around that period. So this actually looks pretty good. And here I'm showing the histograms for each hour of the day in sort of local time. So that's fine, right? I've got all the I've got multi-dimensional histograms here where I can see how this changes. So if I get to a congested window, I can see, oh man, now that really kind of spiked. But this was really well behaved, except that was the US, which is where we built the product. And it was great until we looked at somewhere else. And magically, the opinions were soaring at work, except there was data. And so I said, well, that's bad. That's the technical mathematical term for that. That's bad. We're going to have to engineer around that. So it helps if you know what that is before you try to engineer around it. But it's actually really cheap to measure. So once again, I can pop out my IECDF, and I can say, great, from these histograms that you already sent up to me, tell me where my 50th, my 95th, my 99th is. If somebody argues with you and they say, no, I want to see the 99th, okay, I can calculate that. I've got a function that gives it to me. I can pick any percentile I want. And then I can cluster that and get some similar experiences based on some automatic clustering. And I get my wondrous bubbles, which are great. So bubbles here, this is actually showing you on, again, DNS time, the 50th percentile of requests versus the 95th percentile of requests per ISP. So if I want to try to get a sense of how are different networks and where do I want to conduct some network tests in the wild with a real product, I can now cluster them and say, okay, well, there's these green guys down here. They're fine. I mean, that looks okay, because what I want to sort of see in this graph visually is how far away is my 95th percentile from my 50th percentile. Because if it's really far away, I got some issues. Okay, that's going to be probably a pretty congested network. If it's relatively close, the latency might be high, but it's consistent. So I know that everything's going to get there, and I don't need to go chasing it. So I call this instability. I'm not the first one. Other people called it that. And I can see way up at the top there in that purple, it's actually so far out that it just blew out my scale, so I couldn't really show you what was going on down here until I blew that up. But it was one of those cases where those ISPs, they're going to be really hard to work with, and it's going to be challenging to figure out how to get the product to work there. Again, I can see this as kind of a blow up of the bottom left, and I've got the green population, and I have to leave these ISPs nameless to protect the innocent. Nick, you're doing a great job wherever you happen to be in the world. And he is down there on the bottom left. And sort of as I kind of go up, I start seeing different network properties of instability into the orange cluster, which might be a little bit better if I want to try to progressively get my application to work in more and more parts of the world. And that's all great, but the data that I just showed you was smart TVs. What's wrong with smart TVs? Well, actually, don't answer that. I used to be an engineer in TV, so I look at any smart TV and I'm like, you have the following 18 bugs. So, but anyway, I do try to actually watch the TV sometimes. I'm just not good at it. And smart TVs have the property of, they typically have a little bit of demographic bias. So people who tend to have a smart TV, they usually have some income, they usually buy a decent internet connection, and things are actually not as scary as, say, when you're on a really low-end brand name you've never heard of Android kind of phone. And it's running over the cheapest cellular plan that you can possibly get. And then these numbers look a lot worse. So this is actually the Android data that I'm showing here. And again, the 95th really runs away from the 50th on some of these networks. So now we know where to look. Now we know where to randomize. Now we know where to study. So now that I know that, I have to make it easy to go there. Right? I can tell you that actually not too many of those networks happen to be in Kazakhstan. So it turned out that wasn't the scariest thing that I was looking at in our data set. So I could jump on a plane and I can head over there and I could bring a TV and get an inverter and I can hook all that up and show the guy and he'll say, great, I want to buy this Netflix SIM card. But that's expensive and that costs a lot for your engineers. I can also abstractly analyze the data the way we were just kind of doing it. And I can get a sense of the numbers, except that that always sort of fails the reality. It never really puts you in the shoes of your consumer. You don't see it. And my last alternative is I can actually take there and I can bring it here. I can actually model the reality based on the experiences that I'm seeing with my customers, and that's what I call a reality lab. Now, this is my version of practical teleportation. I'm still waiting for the physicists and some of our CERN friends who are talking tomorrow to figure this out. But for right now, I can make it possible to, well, I can use one of these services and pay somebody to actually try the app out and look at how their connections are working. Or I can go and I can try to simulate it. And one of the first networks that I tried to simulate was one of our better behaved networks. And I was relatively naive and new at the company, and I said, this is the Orange network in France, and that's great, until I ran into one of my French colleagues who said to me, no, Guy, this is not Orange, this is Orange. And so I fixed the title, and I said, sorry, I spelled it wrong, I just didn't really know. So aside from plugging a display into a router, which is a little bit of kernel fun that I will share with you, I just need to clean up the patches a little bit before I send them upstream. This is actually just a normal, regular router where I started playing around with sort of the network shaping to try to make it match the reality that I've measured from my actual devices. So is anybody here familiar with TC, the traffic cop stack? Well, some people, or DummyNet, the FreeBSD version that it was based on. So this lets you pretty much do anything you want in terms of network shaping, and it's really great at that. It lets you, put packets out of order, it lets you drop packets, it lets you shape them based on correlations. I mean, it's really a very sophisticated tool. But the moral of the story, I'm going to get that to you as soon as I can get it working. I just started that project. But the best thing that I'd love you to take away is don't guess. Don't try to guess what the users are doing. Don't try to build really complicated architectures without trying to measure some of this stuff. And I know you people are not the criminals of that. Some of my developer brethren. Anyway, when we actually base this stuff on real data, then we're going to end up building better software that's going to kind of reflect what happens in reality. So it doesn't need to be scary. Thank you very much, and I appreciate your time. Oh, and I dropped a bunch of stuff for where you can get some more of this data and how to do it. Bother your people, develop it yourself, do whatever you need to do to actually collect the real data. Link to R, and I will get the World WRT code in there, possibly with Orange, if I can talk them into it. Or you can chat with me. Thanks a lot.
About 15 minutes for our final two talks. You should be excited about the last two talks. You're excited about the last two talks. It's 4:24. So sit down. Folks in the side aisle things, can you can stand and kneel if you want, but everybody else has to sit down. A few quick announcements before we get started. First, there is an iPhone that lost its owner. The iPhone is back by the registration booth, and the owner is hopefully somewhere in here. If you're the owner, you should go back there. That's it. So we have two talks, and to start us off is Charity Majors.
Hi. Does this work? Does this work? Okay. Everything works. Awesome. Hi. This is my first time at Monitorama for a pretty good reason, which is that I hate monitoring. Like a lot. In my opinion, there's nothing more depressing than backups and monitoring. They're boring. Nobody needs them until something goes wrong. It's just a terrible way to spend your life. I just recently co-founded a company, which is not a monitoring company, for similarly good reasons. But here I am, and when I was trying to decide about what to talk about, having not been here before, I went and I watched a bunch of talks from last year, and the one that really grabbed me, that I really want to pick up and kind of run with, is Greg's. Monitoring is dead. Rest in peace. I'll give you like the 2-minute recap of Greg's talk. He defined monitoring, he defined observability, and he talked a little bit about all the terrible things. He talked about the inglorious past where everybody was like mailing themselves, the output of CPU stat, and like, oh God, I remember that too. It was terrible, no wonder I hate it. Monitoring, as he defined, I think this is a good definition. It's the action of observing and checking the behavior and outputs of a system and its components over time. And then he defined observability as observability. A system is observable if you can determine the behavior of a system based on its outputs. And it was a great talk, but it really got interesting right towards the end. And I was like, yeah, drive a stake through it. Like, you got it, you're on it. And Greg is just too nice of a guy. He's just like, oh, but the future. And I'm just like, roar. Fortunately, I'm not nice at all. So I'm going to pick up where he left off. But I will point out that if you look at your schedule, like 2016 Monitorama versus 2017 Monitorama, Jason was asking me to talk about this too because there is a seismic shift underway. A substantial percentage, something like 30-40% of the talks that I caught up, that I was tallying up are about how we deal with complex systems. I'll say a little bit more about that. But I did want to put a slight correction. Monitoring is not necessarily part of building software. Instrumentation has to be part of building software. The monitoring part, said right there in the definition, it's checking it. You don't actually have to check it. Maybe you shouldn't. The last couple of slides were the ones I loved. He said, build better tools. We have to build better tools. And I think that a big part of that is shedding a lot of the assumptions, the dead ends that come with monitoring, and thinking about it in much more of an exploratory, a way that we associate with debugging, not that we associate with monitoring. And distributed systems. I love this. I've been thinking about this so much. We have to think about the distributed systems and build our systems like they are distributed systems, whether or not they're distributed, because like the computer science that goes along with distributed systems is all about complex systems and how to fail gracefully, and how to tell if something is not normal and all this stuff. It's awesome. And like look at what we have to deal with. Like the complexity is just it's exploding. Like LAMP stack, cool. You have app, you have a database. Like I remember when the P was Perl. Whoa! And then it was like, okay, Perl or Python or PHP, and the database was like, you got your choice between MySQL and Postgres, things get better. And as they get better, they get way more complicated. Like, look at the proliferation of clients that we have to deal with. Look at the sheer number of combinations of mobile devices times operating systems times firmware times language packs times locations times, and like IoT is just around the corner. You know, it's only going to get better. Job security. Distributed systems failures. Distributed systems failures will help you future-proof your systems. Yeah. So, like, the last thing, I don't want to just get up here and be super pedantic about terms, you know? Language wars are fun. That's not actually what I'm here to do today. I've hired you to start a war, I love that quote. But we do kind of have to pay attention to what they mean so that we have a way of distinguishing between disciplines, right? And I'll define monitoring the way Greg did, and I'll say that observability is how we make complex systems tractable. So let's start with some examples. The kinds of like the familiar questions and problems, and then some of the distinctly newer kinds. Yeah, our tools were designed in the LAMP stack era. Like, we're still using them to this day. They're getting better and better, but they show their roots. Right? They show their roots. Metrics and logs were designed for a very different era. Schemas, indexes, anything that has a schema in it or an index on it that is guessing you trying to get you to guess what data you're going to need a year from now is broken. They have their tells. They show their roots. And this is where silos come from. So like we have these little tools and like metrics and logs, and we build dashboards out of them. Every team has a zillion dashboards, like dashboards of dashboards of dashboards. You know, every postmortem includes I'm going to make a dashboard for that, so I'll find it faster next time. So they're like artifacts of past failures. Every dashboard, you can quote me on that. Dashboards are terrible. They're terrible. Dashboards are where you stop. It's a stopping point. It's a thing that you hang on your wall. And I love that we're now trying to make our dashboards like explorable. But if you're dealing with aggregated data, don't talk to me. You have to have the raw data if you're exploring reality. So here's an example of the kind of problem that you have probably debugged as many times as I have. Photos are loading slowly for some people. What's wrong? You know? And this has traditionally not been too hard to figure out because you got your components, right? Apt here, you know, has very distinct, you know, symptoms, a number of possible causes. So you add some monitoring checks. Cool. Database falling over. Well, you find the bad queries, add some monitoring checks. Cool. A lot of these involve, you know, SSHing into a node. That's an anti-pattern right there. Think about all the different alerts you've written to page you for just this tiny list of problems. And then people wonder why they don't get any sleep. And what happens after this? Like, we have a postmortem and we say things like, you know, we'll find this faster the next time. We're stuck in this pattern of, you know, build a system, look at it, predict how it will fail, or have its failures inflicted upon us, and then try to scramble after the fact to remediate it. So in the future, it looks more like this. You've got 50, 60 services, you've got half a dozen databases, you know, God knows how many different device types. And, like, these are all interesting, sometimes difficult. It's usually not too hard to figure out what the problem is, but it can be, actually that's backwards. It's incredibly hard to figure out what the problem is. Sorry. Last minute notes are wrong, as they often are. It's really hard to figure out what the problem is. The solution is easy once you know the question, right? As soon as you know what the question is, but like figuring out which combination of, you know, so there's this like low-level complaints constantly because users, right? Like sometimes it's like, ooh, I sense a bubble up in the number of complaints that are hitting me. But they can be caused by anything, right? All three of these things can be happening at the same time right now at a low level. And sometimes people will complain about them. Sometimes people will have the same goddamn complaints, but they just didn't turn their Wi-Fi on. You know, it's very hard to work backwards and figure out what the actual problem is. So what do I even monitor for? I cannot pre-generate a dashboard for every combination of every user's iPhone and operating system. I don't even want to try. Your system is never up. All those things, the gremlins are there. They're there whether you know about them or not. Like a check, a paging alert is just an attempt to tell you about something. You know that good feeling that you get when you look at your dashboard and you see all green? It's a lie. You shouldn't believe it. It's false confidence. And it's a lie that turns toxic with distributed systems because you start to believe that if you haven't graphed it, it isn't there, it doesn't exist. At Parse, we had 60,000 mobile apps when we were acquired by Facebook, a million by the time I left. And things would happen where a user would write in and be like, why is Parse down? And I'd be like, Parse is not down. Look at my beautiful fucking wall full of dashboards. It shows how fucking not down Parse is. Well, they don't care. It would be something like, they had deployed a query that only gets hit when their users hit the login endpoint and does 5 full table scans. Parse is down, no one can log in. And the longer that I just argue with them about the nature of reality, the more credibility I lose, right? We needed a system that would let us explore all of those interwoven dependencies in real time. Anything else is just not acceptable. You don't have the detail you need today to answer arbitrary questions, most of you. And you don't have the right tools. And listening to the talks today, which have been spectacular, I keep wanting to say, raise your standards. Dream bigger. I really think that we can do more. And I don't say this just because I'm a vendor who's selling something, but I am a vendor who's selling something. Raise your hands if you're in Honeycomb. Okay, you can get demos from those people, whatever. This is not a sales talk, though. This is like a call for help. This is a cry for help. Because this freight train of complexity is hitting all of you, just like me. You're not sleeping through the night either. I know this because Alice told me. And the problems that you have can mostly not be addressed by metrics and by logs. A little bit better by logs than by metrics. Event-driven debugging systems are the way of the future. Then you get to have nice things like read-time aggregation so that you can have percentiles. God, it blows my mind that this is super key, right? Aggregates disguise problems. They take all that nice event data that you have about what's happening and they smush it together in an interval and then throw everything away. So you can have a dot with some tags that you've intentionally it's in the future, the answers get tougher. 50 tags, 50 bits of detail about what happens to be happening in this incredibly rich system is not enough. 200 isn't enough. Answers get tougher. Monitoring is dead. So let's talk about events. And let me be clear, the future belongs to raw events, not rolled up events, not one event per request, many events fired off over the lifetime of every request through its path. There is no substitute, because you always have to be able to get back to that source of truth. What happened, right? And the more fine-grained you can get, the more you can interactively tease out these really complicated answers. Quit debugging with your eyeballs. Do you ever get tired eyes just from doing this with dashboards and graphs? Just oh, I'm gonna get a bigger monitor so I can correlate that one with that one. Close my eyes, keep the memory in and scroll, or open a 99th tab, it's just, it's bad because not only does it wear out your poor little eyeballs, how do I say this? It's bad to debug with your eyeballs because you're just pattern matching. You're not actually debugging with data, right? You're not actually reasoning about what's happening and asking questions of your system, which makes you a better engineer, makes it replaceable in the awesome sense, meaning you can go to Hawaii, that kind of replaceable, right? I've been this engineer. I was on my honeymoon in Hawaii, and I get this call, Parse is down. I'm on my laptop, on the beach, dude, But I just start asking questions of them, and after a few, I'm like, it's Redis. Like, I can smell it. And they're like, well, we don't see anything about Redis. And I'm like, I know, but I built it. I can smell it, you know? And it feels really good to be the hero once. After that, you're like, I want to go to goddamn Hawaii. It makes you replaceable, which is how you're supposed to build teams, right? It's really depressing, I think, to be a junior engineer and know that you can never catch up because it takes so much intuition about how the system works that you have to have from having it break on you a million times or having built it. Like, we should be able to do a better job of teaching our skills. We should be able to do a better job of learning our systems. And you really have to be able to ask questions and explore. Aggregates destroy precious details. And it's not like you're looking for a needle in a haystack. Well, you are, but it's more like you're looking for a needle in a stack of needles. Like just a big, giant, flaming heap of needles. I don't know, there's fire, but there probably is. A flaming heap of needles, and they're not just sitting there, right? They're all in motion, so it's more like a hurricane of flaming needles. That's your future, hurricanes, flaming needles. You need to tell stories, and events tell stories. Not only are events a more accurate representation of what's happening in your complex system, they map to how our brains work. You know, I've never met an engineer who has used both event-driven systems and metrics and dashboards who would ever go back to using metrics if they have a choice. I know lots of engineers who say, I would rather cut off my left arm than go back to using metrics. And logs, let's be clear, logs are sort of events if they're structured, right? It's like a baby event. Just grow up a little bit more, structure it, and then we've got a great event. Great event. Is somebody giving a rant about structured events here? Well, structuring events is nice. It's 2017. I do not want to see more string parsing. Like parsing strings on the server. String parsing is not getting any faster, right? It's not getting any faster. It's that all those strings are the things that get clogged up all the time and need to turn all the data off so we can catch up and all the regular expressions and all our strings. Okay, if I wanted to grep through my logs, I could do that and not pay millions of dollars. Logs are useless until they're structured. The only time that an unstructured log is even acceptable is if a human is the only person who's only thing is meant to consume it. If you're talking between systems, if you're feeding into another system, it needs to be structured. So I was ranting about this on Twitter the other day, and Joe Beda, who I basically worship, and he wrote Kubernetes, he's super smart, he starts arguing with me about that. And then I figured, I'm like, oh, he's arguing with me about this, interesting, maybe I should reconsider. And then I realized it's because he was talking about his 8-year-old. He's like, no, my 8-year-old. I'm like, okay, that's fine. But by the time she's 10, I want to see it structured. Like, outliers are the entire point, right? Outliers are the point. Events tell a story. Events carry all that context with them. Events capture a lot more of the, and this happened, and then this happened, the ordering. They're easier to reason about. Arbitrarily wide events, yes. It's nice to have arbitrarily wide events because if you can handle the sparse data sets, then you don't have to worry about all those nasty schemas, indexes. So gnarly. You don't know what you don't know. That's why you should capture everything you can, right? Now, obviously, you can't handle infinite data. I think that in the future, we need to get used to capturing everything horizontally and getting used to sampling really intelligently vertically, which is kind of the opposite of how our tools do today, which is they incentivize us to trim, to fit into the server-side schema, and they try to keep everything this way, which is fine if you're building a billing system, but this is observability. Oh, there's that slide I was looking for. Flaming pile of needles. Yeah, when a user has a problem, they don't care about your aggregates. They don't care about what the system looked like for most people at that time. They don't care what the average experience was. They don't even care what the 99.98 percentile was. They care about theirs, right? And our tools don't really deliver that. How many of you still occasionally have to go back to AWS to like download your logs from S3. Oh, I'm with you. It's sad. I mean, not actually with you, but I feel for you. Another thing that I really hate about tools is what's up with the, there's like this segregation between, here's what runs for this vendor's tool. Here's what runs for my software that lets me like explore my own code. And the streams are never to cross. I think that the entire like separation between APM and log aggregators is mostly just shouldn't exist. Like you can't hunt outliers if your tool doesn't hunt outliers. Like even with really good log aggregators, if you can't literally look for like individual events, it's not good enough. The other thing that Gregory was ranting about that I really liked was when he was talking about how if your tools, he's like, none of the tools that I see here today are focused on letting you correlate events across disparate systems as like a first order. And I like literally was like, yes, thank you. It's so important because as systems get bigger and more complicated and more far-flung, like mobile app, half of its brain lives on the device, half of it lives in a database, some of it's in flight. Why are you jumping around like between systems just to try and figure out what's going on for one user or one event? Unknown unknowns are always going to be an engineering problem. The first time you see anything, it's an open-ended question about how long it's going to be until you can figure it out. It's terrifying. It's exciting. It's a rush. I love it. So do you. Don't lie. That's why we got into ops. It's super fun. But it's not fun if it stays that way, right? The second time you see a problem, it's a support problem. All you have to do is map what's happening to like the solution and execute on it, right? And our job as on-call engineers is to move as much as possible from that new terrifying like forest fire engineering problem bucket into the known unknowns, into the, oh, I can identify this. I have a runbook for this. I have a paging alert for this. Your entire goal. Because they're known unknowns. They aren't as mysterious. Debugging by intuition in senior engineers is a great way of obscuring so much of this that's going on. It's like dashboard blindness. And this is where aggregates can't take it. I love Prometheus is awesome. Like it's so cool. It's like the latest, best RRD tool that I think will ever be built. It's terrific. But I don't like that model. Reforming our relationship to on-call. Alice's talk was amazing. It shouldn't impact our lives, you know? It shouldn't be the kind of thing where we have to go, oh, that looks exciting. Oh, let me see if I'm on call that week. You know? This is another place I'm like, our standards need to be so much higher. You know why software engineers don't want to join us in the on-call rotation? Because it's miserable a lot of the time. And I don't blame them. And as soon as I realized I couldn't, you know, ask someone else to join me in the on-call rotation, it was a serious, like, I really like had to reconsider my own values. Like, do I value my time less than theirs? Hell no, I don't. Make it, like, this is the flip side of getting everyone to be on call. It can't be life-destroying. And I think that we can have drastically fewer paging alerts. I don't think this, I know this, I've seen this. At Facebook and elsewhere, you can have so much fewer paging alerts if you have tools that you trust to help you debug, to help you answer any question. And when I want to kill monitoring, like this is where I feel like I'm going with it. We need richer, better tools for debugging, for understanding, for exploring, open-ended, you know? Not ones that are like, is it this solution? Is it this solution? Is it this solution? Is it this solution? Which is what I feel like when I'm just going through the dashboard, you know? It has to be, you start with, and you go, what about this? You know, and what about this? And you're incorporating it into your exploration along the way. Metrics are awesome for certain things. Obviously, counters are terrific. Metrics are good for some things. I do think that you should have dashboards for your KPIs, by the way. But I do believe you can reduce your paging alerts to just KPIs. Just your KPIs. If you trust your ability to answer any question and explore it. We have to stop monitoring things and start instrumenting everything. Software engineers, and all of us, have to get used to. Here's another pathology of like old-fashioned monitoring. You don't look at it unless you get paged or alerted in some way, you know. And we considered that a best practice for a long time. You know, we tell people you shouldn't be having to watch, you know, your dashboard. You should only look at it when you get paged. No. If you're not looking at it when it's normal, you don't know what normal looks like, right? I feel like this is, you know, you run your unit tests. Looking at it on your laptop, that's the last time a lot of software engineers ever look at their systems, right? And if you're not running it while it's talking to real services, while it's using real data, while it's being interacted with by real users, you have no idea what's happening with your code. Yes, you're with me. If you're not observing it in production, yeah. High cardinality is not a nice to have. This is the other thing, and then I'm going to rush through the other because I've been ranting, as one does. High cardinality is not nice to have. This is mandatory. Being able to break down by one user, 1 in 10 million or whatever it is, 1 in 10 million users, and then break down by every combination of percentiles, you know, endpoint, queries, is mandatory. You cannot accurately replicate the experience of a user unless you have this. And there are a couple of approaches out this that I'm aware of. There's ours, and there's the distributed tracing folks. Love their stuff. But like, let's raise the bar. Like this is where it starts. This is not where it ends. The software engineeringifying of operations and the operationalizing of software engineering goes both ways. So this is what I want in every tool that even claims to touch the space from now on. It must be exploratory. Context is everything. It must be based on asking questions, not on muscle memory. It must take, like, as a first-class citizen, the social nature of our jobs. Debugging is a social experience. The mechanics are social, even if it's just you and your past self and your future self. You're still like leaving breadcrumbs for your drunk future self, and like your drunk past self was like leaving breadcrumbs for you. So, like, and solving new problems is cognitively expensive. It is hard. It is taxing. It's time-consuming. Sharing is not. Sharing is not. Losing less of our history, forgetting a little bit less, is not. It's cheap. And the future belongs to software engineers, to generalist software engineers. It really does. And I come from ops and DBA land, and we're not going away. They need us more than ever. But we exist on the other side of an API in the future. We are specialists. We are niche. We exist on the other side of the AWS API. Operational skills for software engineers are table stakes. I feel like you all are totally on board, so I'm just going to skip that. And it doesn't happen by accident. It does not happen by accident. It happens by valuing it. That means paying the same for ops as for software engineers. It means not promoting to senior engineers someone who does not know how to run their own stuff, someone who doesn't value that. Changing your processes and cultures, supporting your engineers. There are no easy problems in the future. There are only hard problems. You know, the known unknowns and the unknown unknowns. There should only be unknown unknowns. You should never get paid to go, oh, that again. Oh, that again. Oh, but why are you getting paid? Like, you know how to fix it. You know, there should only be hard problems. Those are the ones that should page us. The stumpers, you know? If the easy problems just don't page us, and which is not to say that paging is the only kind of alert. It's just the only thing that shouldn't wake us up in the middle of the night, right? Other alerts, you know, you gotta fix, but they don't have to wake you up. Just get used to thinking about your system as though it's a distributed system, and you'll mostly be okay. I love this. Future is coming faster than we think. I didn't even realize until I started looking over the agenda for this year and comparing it to last year, and I was like, oh my God, people are really starting to grapple with these problems, and it's super cool. The future is coming faster than we think. It's time to kill monitoring off for good. Problems are coming. They're not optional. The solution shouldn't be either. Observability, I think you should think of it just like TDD for production. Never accept a pull request if you can't answer, how will we know how this is working? And a lot of that is just shedding the monitoring assumptions. I'll see you next year. Thanks.
All right. 2 sponsors, 1 talk, then some time, and then pips and pounds. Is Raj back there anywhere? Oh, Raj, why don't you come on up?
Excellent.
All right, let's give a round of applause to Raj.
Thanks. Is that working? Let me get this going. There we go. Okay, hello everyone. My name is Raj Dutt. I'm one of the co-founders and the CEO of Grafana Labs. So we've asked this question at almost every Monitorama for the last few years, but who's using Grafana? It's really awesome to see, and I just want to take this moment, even though it's a sponsor talk and I want to talk about some of the stuff we're going to sell, to thank all of you for all of your feedback, pull requests, bug fixes. At this point, Grafana is being developed. The majority of new development of Grafana is happening from the community. So just a big heartfelt thanks from the entire team of Grafana Labs for helping us build better software. So, quick update from last year. Since last Monitorama, we've had 10 new Grafana releases. Big new features like alerting, heat maps, initial histograms, stuff coming down the pipeline like dashboard folders, MySQL support, better access control lists. We've changed the company name. We used to be called Rain Tank. No one knew who the hell Rain Tank was or what Rain Tank meant. So now we're called Grafana Labs. It's a bit clearer. We've doubled our core team. We're now 14 people, and we've about tripled the install base of Grafana. And the thing I really want to talk about right now is Grafana Cloud. So real quick, just backtracking to the releases, the 10 releases we did, the takeaway for us over the last year is there's been like a Cambrian explosion of time series databases. It's crazy. It's like a golden age of new databases for time series. Lots of new ones. Off the top of my head, there's projects like from Yandex, ClickHouse is super impressive. Elasticsearch is doing amazing stuff, and it's getting more time series-like. Crate.io is doing really interesting things. Grafana now supports 30 different time series databases. So we've come a pretty long way to being a graphite-only dashboard. There's been a lot of big reboots of existing time series databases. Influx is doing some really cool work. Prometheus is going under major re-architectural changes. We're working a lot on making graphite kind of brought into the modern century. There's no clear leader. All have trade-offs. So our message to you is bring the data together and keep the data where it makes sense. Most Grafana users at this point are using well above 1 data source with Grafana, and we think that's a really good pattern. So when it comes to Grafana Cloud, we launched it just a couple months ago. This is our main monetization strategy at Grafana Labs. It's a complete stack, basically platform as a service, built around Grafana, managed and supported by us. The thing about it is you can continue to use your existing data sources. So keep using Elasticsearch, InfluxDB, Prometheus, Crate.io, whatever. Keep using, even bring in data from Splunk, Datadog, Wavefront, proprietary data sources with some of our new plugins, and bring together that perfect view. But if you want, you can also use our hosted metrics platform, which is 100% Graphite compatible, and even more interoperability is coming. So we really allow you to piece together kind of the perfect open source monitoring stack, but provide it as a fully SaaS supported offering. And why did we build Grafana Cloud? 3 big reasons. Because we feel that you want the best of both open source and SaaS for your monitoring. We feel it's tragic. I mean, Monitorama is an open source monitoring conference, technically, right, Jason? But there's many SaaS providers that essentially preach lock-in. And we think that's really unfortunate. You should own your data destiny and have open tooling. We also think the idea of paying $15 per server per month is insanity, as is the idea of paying by the server. And most SaaS providers, that's their model. We also think being relegated to a single data source in order to achieve a single pane of glass is also insanity. So this is like the main reason why we created Grafana Cloud, to really change the value proposition with a lot of these SaaS platforms. So I have 3 invites, and I guess I'm actually well under 5 minutes for the first time out of any of my Monitorama talks, which is amazing. I'm sure Jason will be pleased. 3 invites to make. If you'd like $1,000 worth of Grafana Cloud credits to play around with our new platform, the only ask is that you give us some feedback to help make us better. Check out grafana.com/Monitorama. It's every attendee is invited to get $1,000 worth of Grafana Cloud credits. Second invite, if you are using Graphite, we worked with the community, we worked with Jason last year, some of our own engineers have put a lot of effort into this over the last 6 months. With minimal fanfare, we released Graphite 1.0 a few weeks ago, and it has some major performance improvements as well as some major feature improvements. So if you're using Graphite and you thought that there hasn't been a release in a long time, that's true, but 1.0 is out and the cadence is picking up. And lastly, final invite, if you're free Tuesday night, come to our party. We're co-sponsoring it with NS1. It's at Ground Control Classic Arcade, just a short walk from here. All the arcade games will be unlocked, so come join us for pizza, drinks, 6 to 9 p.m. Should be a good time. So once again, thank you everyone for the continued great feedback. Grafana Labs will continue to try to make awesome open source software to help you run your infrastructure better. Thanks again.
And our last sponsor is Senzu.
Saying hi to Raj. So like about an hour ago, I realized I was going to have to come up here, so I thought I should start making some slides. So I have just a few. Maybe they're on the wrong screen here. Yeah, don't really like doing slides. Wait, which way do I go? There we go. Hey, I'm just gonna look over here. Okay. Hello, everyone. My name is Caleb. I work at Senzu. I'm the CEO there, I guess. You might not have met me before. You might not realize that you actually have seen a picture of me online before. There it is. So yeah, I have no idea what I'm doing. But pleased to be following me on the Twitters. And let's talk about Senzu for a minute. And I'm going to use my spectacles. I spectacled the Snapchat guy. Are there? Everybody wave from me. Yay. Okay, now, how many people have heard of Senzu before? Raise of hands. Okay, that's good. Keep them up. How many people who have heard of Senzu have actually tried it? Okay, that's a smaller number. How many people are actually using Senzu today, perhaps in production? Oh, there's some hands upstairs too. This is a good number. So maybe I won't have to explain too much about what it is. Senzu is an open source monitoring framework, belovedly, I'll take these off now, belovedly known as the monitoring router. It is an extremely extensible framework. Some handy things, if you're still stuck back in the Stone Age Nagios days, we're fully compatible with the Nagios specification. We have friends here in the audience who are using Senzu at a scale of upwards of 20, 30,000 servers monitoring. Most recently, in the past few years, we've launched Senzu Enterprise. So there's now commercial support available for Senzu, as well as a number of added value features and functionality, that whole story. What's new at Senzu? So in January of this year, Senzu became a company. It was formerly being incubated by a consulting company called Heavy Water. Many of you may know Heavy Water if you use Chef, seen the Chef cookbooks. So we've kind of changed directions now and are 100% focused on Senzu. It's a very exciting thing. We're growing fast. We are also a team of 14, which we were half that size about 10 weeks ago. So we're moving quickly and we're still hiring. We have more hires to go. But Senzu turns 6 years old in a few weeks. So a few things have changed in that amount of time in our world. So we are heavily, or kind of aggressively working on a next generation Senzu that's coming soon. We're going to have an alpha release available in July. And we want to show it to you. So we're having a little party tomorrow night during the Tuesday Night Lights. We are heavily betting that most of the people in this room are extremely lazy. So we found the closest venue possible to Monitorama. It's basically just across the street. We'll have signs out there and people waving to direct you in that way. And Sean Porter, the founder, co-founder and original author of Senzu, is going to demo next-gen Senzu at the party. So we don't have the exact time yet, but we'll let some people arrive, hand out free t-shirts, there'll be food and drinks and a DJ with like actual vinyl records, if we remember what those things are. So it'll be pretty fun. And we'll get a sneak peek at a fully functional prototype of what we've been working on. And we think that will be exciting. I do want to emphasize again, we are hiring. We have a page up on the website. You can see it there. Please follow us on Twitter. We've moved our blog to Medium, so it'll be easier for us to talk to you and easier for you to follow us. So please do that. And thank you all for being here.
We did it. Somebody clapped. Good. You're all tired. You should have had more coffee. All right, we have one final speaker, and that's Pete.
Let's see if this works. First time, all right. So I just want to step up here just because this is so weird. I just want to feel what it's like. Okay. Also, I want to say, I don't think you all understand the level that Jason plays at. He's gotten shoes for the speakers that are epic. And so just step it up his game, really. Just step it up his game. That's what you get, ships and dad jokes with me. Those of you that don't know me, my name is Pete Cheslock. I work for a company called ThreatStack. I'm not going to talk about ThreatStack today. I'm really excited to be here again at Monitorama. I'm even more excited to be here talking about the Vasa, which is a Swedish ship that famously sunk in the 1600s. For those of you that don't know, I presented a very hastily written lightning talk about the Vasa here at Monitorama 3 years ago. People really seemed to enjoy it, but 5 minutes was just not nearly enough time. And if you ever watch that 5-minute Ignite talk, I'm talking about like the micro machines guy. I was just talking so fast. And so a lot of people were like, it's so great, but I could barely understand every word you're saying. It's like, yeah, I could barely understand anything I was saying. So there's a lot of interesting details I wanted to get to about it. But more importantly, this talk isn't about just the Vasa. We're going to talk about failure in general. I have put up a copy of the slides already on my handy website, pete.wtf/Vasa. And I've also added a bunch of the supporting kind of case studies and other links and interesting stuff that I found about it. It's pretty fascinating. So before I get started, though, I do want to send some thanks to a lot of people who helped me make this talk a thing. Dr. Richard Fairley is actually the creator of a couple of great case studies that serve as the source of this talk. And Andrew Schaefer, who is Little Idea on Twitter, actually sent me over the PDF many years ago at like 1 a.m. and started, I would say, my infatuation of this story. It's such a crazy story. And Bridget Cromout sent me over great pictures from the Vasa Museum that I got to include here today, and also made me really jealous because I still have yet to go to the museum itself. So the parallels between the failure of the Vasa and how modern software engineering projects fail is almost eerie. When I originally gave this talk, I had a really simple title, which was 17th Century Shipbuilding and Your Failed Software Project. But it wasn't quite as clear as I wanted, and also for this talk, I just didn't want to reuse the same talk title. I wanted something that was a little bit clearer, so I thought about maybe, eventually you'll ruin everything and no one can help you. It's a little mean. You're probably going to break it, and that's okay. Because anyone who's been in this business for any reasonable amount of time probably has a story about some epic failure that they were involved in. And if you don't have a story about some epic failure, then welcome. As I've read through this story, I pretty much saw all of my most epic failures, but with a lot less fatalities at the end. I can't even fathom how people who work in these highly regulated industries, where people's lives actually hang in the balance, do their job. When I screw up, it only means things like you can't get to your favorite website, or I deleted all your email, or I accidentally took down a portion of global DNS traffic for a short amount of time. I'm really not saying that any of these things ever actually happened. It's just an example. There are two types of ops in my mind. There are people who have fucked up production, and people about to fuck up production. It's pretty clear you're one or the other. This is the reality that we live in, and it's even more so in this crazy, high-growth startup world where the ultimate goal is to move fast and break stuff. We make bad decisions that are only clear to us years after the fact. Or a good idea at the time that just has unintended consequences down the road. Or a decision made just with a pure lack of experience. Happens to us all. This is an example of that. This is from the 1986 kindergarten class cookbook, my kindergarten class cookbook. Why you would have a bunch of 6-year-olds coming up with recipes, I have no idea. Let's review. This is for my banana soup recipe. Red. Start off with 5 gallons of water. You're gonna boil the water, obviously. Just chuck those bananas right in there. Then just pour some cans of vegetable soup, because why not? And then add in 5 more bananas. Cook it for 1 hour, and then you eat it. And I was really glad that I put in this recipe, and then you eat it, because looking at those ingredients, I wasn't even sure this was edible. And I was going through this book, and I mean, there were 30, 40 different recipes, and I wish I could say that there was something worse than this that I could show you. No, this is the worst. So you think that 6-year-old me was willfully making a bad decision? It sounded like a good idea at the time. How many times have you said that at your job? It's probably fine. I've seen others make food before. How hard can it be? I just had no real experience with cooking. The ultimate problem is there's just too much stuff, and there's not enough of us. We're just moving too fast. You just need to ship code, and don't think, just ship. Hop on your treadmill desk and keep shipping until you die. And we all try to move fast. Maybe we leave helpful comments for our coworkers. Maybe we leave some of that neat self-documenting code. I don't know. Is it any wonder that we keep screwing up, that we keep doing the same things over and over and over? Remember, the story of the Vasa is from the 17th century. In many times, we're not even given the ability to actually improve our situation because it may not be in the company's best interest. Technical debt is not a technical problem. It's a business problem, first and foremost. The company may want to ship features, but the bad decisions, they just keep piling up. So we haven't yet gotten to the point in software, like that one episode of The Simpsons, and this might be too obscure for some people, but it's the one where Mr. Burns thinks he's indestructible because he's got so many diseases, they're all stuck in this perfect balance, right? When we have so many bugs that things are actually stable because of it. We haven't quite got there yet. Now, I've seen some places where there are so many software bugs, they're actually turning in the features. The patch notes for Dwarf Fortress will show you some great examples of that. I think my favorite has got to be, I don't know if I added it on here. Yeah, there was one of them that was like, you know, the undead were passing out. There it is. Fix problem with undead passing out from strangling. You know, God forbid that you fix a bug on the API that one of your big customers is actually using on a daily basis. It's a bug to you, but that customer may not think so. So it leads me to a conversation I had at DevOps Days Austin last year with my friend Nick. We had been commiserating about computers at the end of the event, talking about all of the most ridiculous duct tape wire infrastructure that we've either built or has been given to us to support. And he mentioned this one point about Flintstone ops. So if you remember from the show, they would have these animals that would basically do all the automated or manual tasks, and it'd go about as well as you can expect. Here's actually a good picture of Fred Flintstone just DevOpsing so hard. You got all these animals doing things that could and should be automated. They don't have this great technology that we have today. They don't have the cloud. They don't have whatever. They're also a cartoon, and they're not real, but I digress. In many ways, we glamorize companies that are much bigger than us, especially if someone that's at a startup. I look up to companies like Amazon and Google, and I think they must be doing things so much better than us, right? They must be. I mean, like places like Google, like I get it. Computers, you know, am I right? I just love this one too, because it was like an outage message that failed to like, just too good. Let's take a quick look at the postmortem from the recent S3 outage. This is a really good postmortem they've written up, and I just highlighted a few of my favorite sections here. An S3 team member, an authorized S3 team member, executed a command, and unfortunately one of the inputs to the command was entered incorrectly, and a larger set of servers was removed than intended. And the servers that were inadvertently removed supported 2 other S3 subsystems. Like, I know them feels. I have been there. I was just there last week. I mean, this happens all the time. And it makes me feel a lot better about the situation I'm in and the situation I've been in. Like this one ill-fated time, I was taking over ownership of a series of NFS clusters running on AWS even. And it was just one big old JBOD of EBS. Just a bunch of disks is what that stands for if you don't know. And this was back when the maxed disk size was 1 terabyte. So, well, when you fill up 1 terabyte, what do? Just add another terabyte, right? Add another disk. Need more space? Add another disk. 50 terabytes later, formatted with the ext3, you can't even run a file system check anymore because it'll take you like 283 days, right? Flintstone ups. So the Vasa is probably not the earliest example of some epic breakdown in project planning. The fact they were able to recover the ship helped researchers understand just what went wrong. So this is actually a picture of the Vasa. It was one of the grandest ships ever built by the Royal Swedish Navy. It was completed summer of 1628. It was actually the most expensive project undertaken for Sweden at the time, and it calculated about 5% of Sweden's GDP. Today, that would be about $28 billion. So it was a huge project. In August 1628, the ship set sail on in Stockholm Harbor, and after sailing for about 1,300 meters, a light gust of wind caused the Vasa to heel over onto its side, water poured in, and the ship sank with a loss of 53 lives. It was in the 50s that the ship was actually rediscovered, and due to the salinity of the water in the Baltic Sea, it was well preserved. I mean, these are actual pictures of the ship itself. And it was so well preserved that it actually floated when they raised it up in the 1960s. So the king, in a message, demanded the guilty parties to be punished. So a board of inquiry was formed, and the captain and the crew were interrogated. They reported that the guns had been properly stowed, and the crew was sober at the time. It's a thing. And actually, I found one article. I couldn't get confirmation, so I didn't really add it. But they said that the crew was sober, and it was confirmed because most were coming from religious services that day. That's how they confirmed the crew was actually sober. So they questioned the officers, they questioned the crew, they questioned the contractors who actually built the ship. Everyone said they did their duty without fault. No one was punished in the end, and most of the blame actually fell on the original shipbuilder, who actually died a year before the ship even set sail. Now, I have been blamed for outages before. I was once blamed for an outage a good 6 months after I quit that job. But I was still alive when they blamed me, so I don't think this still counts as a blameless post-mortem if that person has died. The real reason the ship sank is that it was unstable. This is a side cross-section of the Vasa here. It was an issue with the hull construction itself. Too much of the hull was actually built above water. The 2 gun decks that you can see at the top there, they were much taller than normal. And you can see in this cross-section a very tiny amount of ballast below those barrels there, the stone. So the king also wanted the ship to be outfitted with these ornate and gilded painted carvings. And the idea was the Vasa was meant to impress and outdo every other vessel on the water. So they spared no expense at all. And they all contributed to the high center of gravity. That was the ultimate downfall of the ship. So in those days, even the experts believed that the taller and more impressive a warship was, with more and bigger guns, the more indestructible it would be. So the artisans of the time also had no way of calculating any sort of operational characteristics of the ship, things like center of gravity, stiffness, etc. So the captains had to just figure this out, trial and error. And they would do that after the ship was launched. The Vasa was the most impressive ship to sink during the 17th and the 18th centuries, but it definitely wasn't the only one. Measurements taken actually showed the Vasa was so unstable that it would have heeled over at a list of just 10 degrees. And then even more recent calculations showed that only a 4-knot gust of wind would have caused it to heel over. So it's pretty impressive considering it's a sailboat. So back in 1625, the king Gustav II directed the admiral to sign a contract to build 4 new ships. He wanted 2 108-foots and 2 135-foot ships. During the next 6 months, the king, of course, who is an expert at shipbuilding, sent a series of ongoing and confusing changes to the shipbuilders, and because of those requests, the shipbuilders actually cut enough timber to do the same 2 108-foot ships, and now just 1 135-foot ship. Then in September, the Navy lost 10 ships in a devastating storm. So what do you think happened? The king ordered the 2 108-foot ships to be built as soon as possible, right? We just lost 10 ships, we need them right now. And for some reason, as I was reading through all the different changes to the plans the king had made, I just imagined that if this happened in the modern era, you just know there would be an email thread like 50 deep with a Word doc attached like ships v9 final.docx, right? And it's in caps too. That's how you know it's final. It's also important to point out here that the construction of the Vasa actually started in early 1626 as one of those smaller ships and completed 3 years later with numerous changes along the way. This is fine. So a couple of months later, what probably should have been the final requirements change, the king now wanted them to be 120 foot in length because they wanted to add more guns in a standard closed deck configuration. And this was all to create more powerful ships because they were actually actively at war with Poland. But they only had enough wood to build an 111-foot ship and a 135-foot ship. So then the shipbuilder just got approval to say, we'll just do two 111 ships instead. So these two ships are actually the Vasa and its sister ship, the Aple, which did not sink. The only real difference between the two ships, and they were built approximately around the same time, was that the sister ship actually was 3 feet wider. So remember 3 feet width. It's very important in a few slides. So now the problem is the king learned that Denmark was building a ship with 2 gun decks. Well, they gotta have 2 gun decks too, right? Instead of starting over, they just scaled it up. It's worth noting here that the king changed the plan. When the king changed the plan, no one in Sweden, including the shipwrights, had ever built a ship with Docker before. I mean, 2 enclosed gun decks. Whoops, sorry. What's most interesting is that there's a wealth of preserved documents from this time period, from the Vasa, and actually none of the documents found show any sort of reference to an 111-foot ship or a 135-foot ship. What they believe happened is the shipbuilder not only just scaled up from the original 108-foot ship, but then just scaled it up again to be 135, right? So it's very similar to my tried and true strategy for scaling up on the cloud, right? Just scale it up. Just scale it up. It's fine, it's fine. So if you thought the changes on just the size of the ship itself was silly, the requirements for the guns changed almost as many times. So they started with 32 24-pound guns, and that was for the smaller 111-foot version of the ship. Well, then the ship kept changing. It was going to go and be a bigger ship. The 135-foot version was going to have significantly more guns. After a series of even more revisions, they decided to have 30 guns, larger guns on the bottom deck, and then they were going to do a same number but much smaller size on the top deck. Now, the final decision was actually the first good decision that they made. They chose all 24-pound guns, which meant more firepower, and it also meant they could standardize on ammunition, fittings, and all the other things required to operate the cannons. So after all these revisions and escalation, it really reminded me of this one. It's like, do you want a few cannons, or like, do you want to get real, right? So I don't know why, this gets me every time. It's like that escalated quickly. So remember when we talked about unintended consequences, things that seemed like a great idea at the time? I call them banana soup decisions. So in the end, they could only get 48 of the 64 guns they wanted because they changed the plans so many times that there were the time constraints, they couldn't even get them built fast enough. Because of the rush job on the guns, they were made of such poor quality that they would have likely have failed when used anyway. So instead of sinking, the ship probably would have blown up. So in addition, the upper deck, which had been originally designed to hold only the smaller 12-pound guns, now had to support larger 24-pound guns, and that further raised the center of gravity on a ship that was already lopsided. So what do you mean lopsided? Ships should be symmetrical, right? In 2008, Fred Hawker, who's an archaeologist at the Vasa Museum, he had a team that actually measured every part of the ship over a 3-year time period. And what they found was significantly more structure on the port side rather than the starboard side. So if the ship were unballasted, then the ship would heel over to its port. As it turns out, when the winds hit the ship on that fateful day, the ship did heel over to the port side. So the real question is why was this ship so lopsided? So while Hawker was examining the ship, he discovered 4 different types of rulers that the time had used. Oh no, that's good. Oh, it's coming. It's coming. I can't just give you the good stuff, but thank you. So two of the rulers were in Swedish feet, and two were in Amsterdam feet. So how long is a Swedish foot? In modern terms, 29.69 centimeters. Meanwhile, an Amsterdam foot is 28.3133 centimeters. My favorite quote, though, here, straight up from Wikipedia, is there were anywhere from 10 to 13 inches, that's what that is, in a foot based on local regulations, right? That's a difference of nearly 5%, which is pretty significant when you're talking about these large ships and how sensitive they are to the center of gravity. Remember the Vasa sister ship, the Aple? The only difference between those two was an additional width of 3.1 feet added. That was the margin of error here. Everything is coming at Millhouse, right? Like, we are getting there. So we talk about how the difference, this margin of error was only 3 feet in between failure and success, but it's not like they didn't know that they had a problem. The admiral and the captain actually did a stability test. They actually tested first. They called it a lurch test. You take 30 people on the deck of the ship and they run back and forth across side to side. It's actually how I load test Elasticsearch too, if you didn't know. Just run back and forth until that sucker, falls over. So they stopped the test after 3 rounds back and forth because the ship was about to heel over. So normally in this situation, you just add ballast. There was no more room. There wasn't any more room at the bottom of the ship to add ballast. And if they added more ballast to the ship, and it was later calculated they would have needed twice as much, the lower gun ports would have sat below water. So why would you launch after the test failed? It's a question I ask myself every week. It was later found that neither the shipbuilders nor the king were even present at the stability test and were never told about it. So it leads me to my favorite exchange between one of the officers and the admiral, which occurred after the failed stability test. So the officer said, "The ship is narrow at the bottom, lacks enough belly." The admiral says, "The shipbuilder has built ships before, and you should not be worried." The officer's like, "God grant this ship will stand upright on its keel." I'm pretty sure the admiral then said, "Hold my beer." So what can we learn from the Vasa? There really was no reason to let it go this long, but deep breaths. So the Vasa was completed under strong time constraints, and it was to meet this pressing need of the ongoing wars that Sweden was involved with. The loss of the other ships Sweden used to defend itself also stressed this schedule. Many of the operational requirements of this ship were made while the ship was actually actively under construction. The specifications, which were non-existent, because, fuck documentation, were never updated as the ship scaled up from 108 to 111 to 135 feet long. So the original shipbuilder, who died midway through the project, had no documented project plan. The project plan completely fell apart after that, and they've been unable to find any plans created by the assistant that took over the project later. No one in Sweden, including the shipwrights, had ever built the ship with 2 gun decks before. And now they had years of experience. These were accomplished shipbuilders, and they had years of experience building ships. But because they hadn't done it before, they didn't grasp the impact of what a second gun deck actually would bring to the ship. And we know this because the height of the second gun deck was significantly taller than the average height of a crew member at this time. So many innovations were added onto the Vasa after it had started construction to accommodate the larger size, again, as well as the larger gun deck that was already added on to an already scaled up ship. It had evolved so much over this 2.5-year timeline, no one even understood the impact of the changes. They believed there were about 400 people, 400 different artisans working on this ship. And most importantly, the king was far more involved into the design and all of the changes in the requirements than was normal for the time. There were no standards of any sort of measurement just on defining what a foot meant, something as simple as that. Different lengths from one worker to the next. Sometimes you have to define the words before you get started just to make sure people know what's going on. There was no known way for the shipbuilders to calculate things like center of gravity, stiffness, any operational characteristics. They launched after the test failed. Everyone here does that. I know, I see you. And they didn't tell anyone that could actually make an attempt at fixing it or stopping the launch entirely. But really, this is the reason the story of the Vasa is so fascinating. It's a perfect storm of bad decision making. Everything from schedule pressures and scope change and excessive innovation with that creation of the second gun deck. It's the most impressive dumbassery has to be the fact that they tested it It failed, and they shipped it anyway. That never happens today, right? So those that can't remember the past are condemned to repeat it. The next time that you're sitting in one of those big project planning sessions, remember the Vasa and the types of decisions that led up to it. I like to call them banana soup decisions. Because let's be honest, that's the real travesty here today. Thank you very much. All the slides and stuff are up there. Really appreciate it.
No questions? Okay. So, we're all done for the day. More? Okay, so there's going to be 4 more talks. Just kidding. So tonight at Pips and Bounce at 7 o'clock, there is a ping pong tournament. There's a draft sign-up thing in the Slack channel. There will be snacks, but those snacks may not be substantial enough, especially if you've been listening to challenging math content all day. You've burned all of the calories in your brain. Yeah, right. The speakers apologize. Let's give a round of applause for the mathy speakers. And an even bigger round of applause for the non-mathy speakers. So if you're hungry, and you should be, I recommend you grab food on your way to Pips and Bounce unless all you need is some snacks. There are options in the area, so you could head there and kind of fan out. Look for people who seem like they know what they're doing and follow them. And maybe ask first. But we will see you at 7 o'clock, and then we'll see you tomorrow morning. I believe doors open at 8:30. I made that up. See you then. Bye-bye.